Ladies and gentlemen, keynote will commence in 10 minutes. Can I please ask you to make your way to the auditorium? Ladies and gentlemen, keynote will commence in 5 minutes. Can I please ask you to take your seats? Wasn't that a bit? Ladies and gentlemen, keynote is about to start. Can I please remind you to silence your mobile phones?
Welcome to Google Developer Days India. We're happy that you'll be joining us for 2 days of talks, demos, hands-on training, and more. By now, you've checked into registration to receive your badge. Your badge must be visibly worn at all times, and don't forget you'll need it for the amazing after-party at the end of the day. The help desk is located near registration. If you have any questions or are in need of assistance, feel free to stop by. All sessions will be taking place in either Hall 3A or the Jacaranda Room in the Conference Center. For hands-on trainings, be sure to visit the Gulmohar and Kasia rooms in the Conference Center, where instructors will teach you how to use the latest Google technologies. No Google event would be complete without showcasing the newest products and technologies, so we invite you to explore the different demos, office hours, and review clinics in the Hall 3B Sandbox area. Be sure to check out the Community Lounge and Google Developers and Cloud Certification Lounge, which are also located in the Hall 3B Sandbox area. There will be scheduled meetups, fun activities, and engagement opportunities, as well as places to just sit and relax and meet with your peers. We're looking forward to a fun 2 days with you and would like to take this opportunity to remind you that Google is dedicated to providing an inclusive event experience for everyone, and that by attending GDD India, you agree to our code of conduct, which has been placed around the venue and on the website. Thanks for attending Google Developer Days India, and have a wonderful time exploring everything that Google has to offer.
Ladies and gentlemen, please welcome Sebastian Trzynski-Clement.
Namaskara Bengaluru. मेरा नाम सेबास्टियन है और मैं गूगल में काम करता हूँ. आप सब लोग कैसे हो? I try to speak Hindi. Actually, I have to go out of my script now because I was expecting a very mild response. Sometimes I pretend I'm from Kashmir because I have blue eyes and I try to speak Hindi. And I guess it worked a bit today, right? let's see if you're a bit more awake than I thought. I'll stick to English if you don't mind, because Hindi is not exactly my native language. And I'll repeat my question. But this time, I'm expecting a much, much louder response from you. With all the sessions yesterday, the concert, the free food, how good was the day yesterday? Tell me. All right, that's much better. Dhanyavad. So, I'm Sebastian, and I have a very complicated last name, as you can see. I've been 11 years at Google, and I guess that makes me a bit old. I currently lead our developer ecosystem teams across Asia, the Middle East, and Africa. We tried to organize a very inclusive event over these 2 days. We have people from all over India, and even beyond India. Thank you to you for coming all the way. There are men and many women. In fact, GDD India is probably Google's biggest developer event in India to date. And according to the stats I have received, we have 36% of the audience who are women. We still have a lot to do. Thank you. We still have a lot to do when it comes to gender diversity, but getting to 36% at a major developer event, especially in India, I think is already pretty good. So thank you. Google cares about diversity and inclusion. When we develop products, we think about the diversity of our users, wherever they are, whomever they are, those who only use mobile phones, those who have disabilities. And inclusion is also about respecting and including the diversity of languages, opinions, religions. We want to help you, developers and startup founders, to think about how you can make your products work for everyone or solve challenges for different segments of the population. We also want you to think about how we can create tech communities and engineering environments which feel safe for everyone. Today, I'd like to talk to you a little bit about an Indian startup which is based out of Bangalore to illustrate how technology can radically improve the lives of women around the world, but especially in India. Not only that, but it also uses artificial intelligence and machine learning to come up with innovative ways of solving a major health issue. Now let's start with a number. 1 out of 4. In India, 1 in every 4 women who is diagnosed with cancer has breast cancer. This is a serious issue. In fact, breast cancer is the largest cancer killer for women today. 500,000 women die every year from it, 500,000 every year. This is one of the leading causes of death for women in general across the world. It directly or indirectly affects all of us. We all have mothers, wives, sisters, daughters, female friends. So we care about them and we love them. But having cancer does not have to be a fatality. It's actually quite often possible to heal from cancer, except in India. In India, 1 out of 2 women diagnosed with breast cancer dies within 5 years. In the US, the fatality is less than 20%. In China, 25%. Early detection is one of the main reasons for the fall in mortality rates in those countries. The problem in India is that for the majority of the population, breast cancer awareness is almost inexistent until it's almost too late. In addition, there are sociocultural and economic barriers. Indians either don't feel comfortable or have preconceived notions about breast cancer screening. And this results in most people identifying cancer at a stage 2B, which is already pretty late in terms of a stage for cancer. And so the survival rate for cancer is pretty low compared to other countries. Niramai is a startup based in Bangalore. It was founded in July 2016 by Geeta Manjunath, who's the CEO on the left side, and also Nidhi Mathur, who's the CEO of the company. Now, Niramai is an acronym. It stands for Non-Invasive Risk Assessment with Machine Learning and Artificial Intelligence. If I'm not mistaken, it also means painless in Sanskrit, or to be healthy. So how is Niramai solving this problem? It has built a diagnostics platform using artificial intelligence to detect breast cancer at a much earlier stage than traditional methods or self-examination. The solution is low cost, accurate, automated, portable, and that can be operated by a simple clinician and in the near future by everybody. So the startup's method of screening is based on the principle of thermography that can detect tumors 5 years before mammography or a clinical exam. And unlike mammography, Neramai's solution is radiation-free, non-touch, not painful, and it works for women of all ages. In case you're not aware, mammography only works for women who are older than 40 years old. By processing thermal images and using machine learning, you can get reliable and accurate results. And the best thing of it all, it's as accurate as mammography, if not better. Now, this unique solution can be used as a cancer diagnosis test in hospitals to prevent and early detect cancer, but also to deploy this large scale across rural areas. Neramai's innovative approach provides accurate, non-invasive, and privacy-secure detection to breast cancer, and that will help to identify the disease early in the process. Now, Neramai has also been accepted at Google Developers Launchpad Accelerator program. Now, what is Launchpad Accelerator? It's a 6-month acceleration program that matches top startups from emerging countries with the best of Google, our people, our network, our technologies, to help scale great products. Now, we're very excited to see how we can help Neramai scale their fascinating solution. And now, and it was not completely expected, I'd like to invite the CEO and co-founder of Neramai on stage because she drove all the way to be with us today. Now, please give a warm welcome to Dr. Geeta Manjunath.
Hi.
Good morning.
Good morning, Sebastian.
So let's have a seat. Thank you for being with us today.
Thank you.
I have a few questions for you.
Sure.
Now, what or who inspired you to create this startup just about a year ago?
The key inspiration is really about how technology can make a difference and create a social impact on this. So, in fact, in my family, very close cousins, Bharti and Lakshmi, had this horrendous disease in their 30s. And I lost them before they were even 40. So with that as a background in my mind, I was just thinking, how can we help detect cancer in young women as early as possible so that the number of deaths can be minimal. In fact, breast cancer is the only cancer that can be cured completely. And as a researcher in data analytics lab at Xerox, started working on this problem. And we got excellent results, and it was a pure coincidence that we were able to try and address the biggest problem in women's health today.
Now, you have very ambitious plans. What's next for Neramai? What's on the roadmap?
Sure. So right now, we have the solution available in a few hospitals in Bangalore. We are starting to do some more critical trials in one of the promising hospitals. Now we want to sort of expand in India and beyond, create scalable solutions where we can make sure that the data collected is really accurate. There are good procedures in place so that there are no errors that is coming up. We can train the patients, train the technicians so that they can collect the data well. And then rest is done in the cloud. So it's just about how we get the data in. So that is the sort of main thing that we're looking at right now.
Now, you got accepted, as I mentioned, to Google Developers Launchpad Accelerator program. Why did you apply to it? What are you expecting from it?
We are very privileged and very, very happy that we are part of the Google Launchpad program and looking forward to the exciting time of learning. So really, this solution can be used by everyone, right? We are also creating a very small, handled kind of a solution. It can be used by every gynecologist, every physician to treat the lady that is coming in. So this, the scalability is very, very key. And so who else but the IT giant can help us reach the scale? So we are looking forward to ML on the cloud and getting guidance from Google.
Great to hear. Now, to inspire you, and because you're a good observer of challenges, what problem do you face every day in your life that you think nobody has solved today? And maybe someone here in the audience can try and solve it in the months to come.
Yeah, so maybe over the last 25 years, we have looked at several problems in my IT career. But as Niramai, what the problem I'm trying to see is and solve is, how do we convince people that AI really works, right? So in whatever problem you're taking, you're dealing with domain experts, doctors in our case, right? So if you put a machine and say it can do at least 90% as well as you doctors, how do we convince them, right? So that is the sort of major challenge every day we are facing through additional clinical validation and so on. So whatever problem you pick, try and see how do we prove that it is actually working. Right? So put test cases and trials in place so that it is actually proving what the decision making is working. Right? So that's mainly what's different when you actually look at AI/ML powered solution that needs to be
What's
solved.
the best advice you can give to developers?
Yeah. So if you believe in a passionate idea, if you believe there is an idea that you think it will work, don't let somebody else try it, because only you know the complete undertakings and sort of issues that may come in and so on. So pick it up, go for it. You'll be able to solve. There will be several challenges, but you will be the only one who knows how to handle those challenges, right? If you believe in an idea, go for it, create a startup. It's really worth it. Thank you.
Do you, this will be my final question. Do you have a quote you live your life by, or maybe something you think of often, or a book that is a reference to you?
Yeah. So I get influenced by Indian spirituality and all that quite a bit. So two things I believe in. One is learn every day, right? Keep looking out for small pieces of advice, be it from your neighbor, be it from your boss, be it from your own small kid, whatever, right? So keep learning every day. Be open to learning. Second thing is, especially when you're in the turf, right, when things are not going well, everything happens for good. Whatever happens is for good. So I keep thinking like that, okay, if I'm here, there's something that's coming up later. So that keeps us going. So these two things are what just makes me run. Yeah, thank you.
Thank you very much for sharing all these bits of wisdom. Thank you very much for coming today.
Thanks a lot for having me here.
Thank
Thanks
you.
a lot, Sebastian. Bye.
And now, we're going to hear about inclusive design, how you can design products with inclusion in mind. Soumya Subramanian is an engineering director at YouTube. She's also been at Google for 11 years, and she will talk about inclusive design with many interesting, funny, sometimes surprising examples. So I'd like you to welcome on stage Soumya.
Thank you, Sebastian. It's great being back in India. I was born in Chennai and did my high school in Calcutta, and was fortunate to grow up in different parts of the world, including Lagos, Nigeria. So to be here today presenting inclusive design and how we can build products for all, including emerging markets like India and Nigeria, is really exciting. As Sebastian said, I'm from YouTube, and you'll be seeing a lot of videos in my presentation today. Let's get started with one. Can we roll the video, please?
Me love rewind. Nom nom. Trust me, I'm a INDEPENDENT hustler, chasing dreams since I was 14 with the 4-track bustin'. That validation comes from giving it back to the people. Now sing the song and it goes like. And it goes like. What the fuck say? You wanna change the world? You're a goat. You can do that.
Can we go back? This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us. Like the ceiling can't hold us. Can we go back? This is the moment. Tonight is the night. We'll fight till it's over. So we put our hands up like the ceiling can't hold us.
This is a clip from one of my all-time favorite YouTube Rewind videos, as it captures the essence of YouTube. YouTube started with a very simple mission: broadcast yourself, and has grown into a global platform with global reach. We have over 1.5 billion users visiting YouTube every month, with over 80% of our views coming from outside the United States. YouTube is an open and democratic platform with over 400 hours of videos uploaded every minute by creators all around the world, making YouTube the platform with the most diverse content. In the time that it took me to say this whole sentence, almost a day's worth of videos have been uploaded to YouTube. YouTube, unlike traditional media, has no gatekeepers. Anyone can have a voice and reach an audience. While this is still very true about YouTube, a few years ago, when I was looking at some usage data on YouTube, I realized as our platform and usage have grown, human dynamics and unconscious biases are creeping in. So on YouTube too, we see biases and gender gaps, for instance, similar to traditional media. For instance, a lot of our fashion content is created by female creators, and a lot of our STEM and science content by male creators. This insight drove me to start a pitch and a dialogue within YouTube and across Google about diversity in the context of product design and how unconscious biases are playing into our products. So what if YouTube, in addition to optimizing for watch time, became more intentional about a demographic goal, such as gender reach or ethnicity reach on our platform? This would open up opportunities for us to deepen engagement and onboard more users onto the platform, thereby driving growth. For the first time, we expanded conversations around diversity at Google from diversity in hiring and building balanced teams to diversity being a critical factor in defining our product strategies and growth strategies. So what is inclusive design? It's about engineering products for all your target users across all demographics. Broadening your demographic reach helps unlock opportunities that will drive growth for you. Inclusive design is not just about user experience or visual design. It's also about the algorithms and machine learning, about testing and training data, about how you brand your product, the marketing, the PR, and more. It's about asking the question, for which of my target users can I be doing more for? It can be in the form of gender, reach. It could also be that your product works great when you have good connectivity, but not so well when you're in the developing world. It could be about optimizing your experiences to deepen engagement with a certain cultural group. We as an industry have been doing inclusive design for years now in the form of accessibility work. And this is about expanding that across other dimensions. For instance, when airbags first came out, they caused more deaths and injuries in women and children. Why? Because airbags were tested with only tall male crash test dummies. Were the engineers who designed this test program and plan sexist? No, it was their unconscious biases that informed their approach. Female drivers tend to have a smaller build, and in real-world crashes have a 47% higher chance of fatal injuries. Once the automobile industry realized this and incorporated women into their design and started using female crash test dummies, safety of airbags improved significantly for women and not just for women, but for anyone with a smaller build. So this is a great example of gender-based inclusive design. Kids are still an underserved market here and an opportunity for them. For this next example, I would like to start by rolling a video.
My coworker Wanda and I are sitting in front of an HP Media Smart computer. It's supposed to follow me as I move. I'm black. I think my blackness is interfering with the computer's ability to follow me.
So she moved this way, and the camera followed her. And then he'd get into the screen, and it would be completely stable.
No face recognition anymore, buddy.
Anyone know what's happening? For this, we need to go back to the 1950s when Kodak dominated color photography and introduced the original Shirley color card that has become a standard in photography, but has one problem. It works better with lighter skin tones. So what this means is you often have exposure issues when taking multiracial photos. This became a big problem in the 1970s when chocolate makers and wood manufacturers were having a hard time creating advertising material because it was hard to capture the different shades of browns in their products. And also as the film and media industry was starting to become more diverse. Finally, in the 1990s, a group of engineers decided to take an inclusive design approach and introduced multiracial color cards to help bridge this gap. While it's improved a lot, there is still a slight light skin bias. And I'm really proud to say that at Google, the camera team has taken a proactive inclusive design approach to help bridge this. Let's see a video of what the team has done. Let's roll the video, please.
Pictures tell stories. It doesn't really matter if it's a selfie or if it's a portrait that somebody is taking of another person. You are sharing in that human moment.
Let's take a picture, you two. 1, 2, 3. No, he's too dark.
So this is where the discussion started.
Here, just use my phone. It's got a better sensor.
Better sensor? What does that even mean? Color tuning is an extremely complicated process. When we look at images, what we try to do is figure out how much of a difference there is between, let's say, a reference image and the image that we actually are trying to quantify. We were running some tests on a product, and it was the proximity sensor we were testing. And we said, oh, it looks like it does 60 centimeters. And we looked at each other and go, we're both white. The technology itself, as many people will say, is not racist. It's just that it wasn't tested properly to make sure that the designers weren't unconsciously biased. Hey, there's an entire world out there and we want to make sure this works for everybody. I love the fact that we get to influence cameras, that we get to share those experiences of life and emotion. And to me, that is what imaging is about. It is a vehicle to express humanity.
Take a picture of you two. 1, 2, 3.
Thank you. How many of you know of Cheetos? Again, like them? Most of the room. I like them too. Did you know when Cheetos first came out, they were only available in one flavor, the original cheese flavor? Until a janitor who worked for the company started adding chili and lime to his packets of Cheetos because he was Latino and liked the flavor of that. His friends and family took to it too. So he decided to pitch an idea of introducing this new flavor to the CEO of the company, who actually listened to the janitor and experimented, thereby unlocking new markets. Every time I tell this story, people want to know what happened to the janitor. He is now a senior executive at the company, a true rags to riches story, and more importantly, a great case of culture-based inclusive design. This next example is near and dear to me. It's from YouTube. A few years ago, we wanted to increase the engagement of YouTube with kids and families. So we brought kids into our UX labs to see how they use YouTube. So this is what we normally see. This is how kids see it. They only care about the content on the screen and nothing else. And that is when we realized to increase engagement with kids and families, we have to reimagine YouTube from the ground up, build a special app just for them. And that's how the YouTube Kids app was born. The YouTube Kids app provides an easy-to-use, engaging, and enriching experience for kids and families through a combination of several user experience and interaction innovations, and also a lot of back-end algorithmic and classification work that we did. This is a great example of age-based inclusive design, and it also showcases that sometimes to meet the needs of specific target groups, like demographic groups, you may have to build something special just for them. I wanted to roll a video to show the original launch video of YouTube Kids.
Okay, so do you want to tell a story?
Sure. Yeah. Oh my gosh. Now everything is popping into my brain. Okay. Once upon a time, there was a boy named Alex. 3 sisters, a bunny, 2 twins. He got caught in a bubble, and then he was floating around. He went to France, and then he sees Dracula and a few ghosts and Frankenstein. And then the robot came and ate the whole town. And everyone went like crazy. And then they had to destroy the robot. That was the only thing. So they put it on the sun, so. Because since the sun is made of gas, it couldn't eat anything there. He got surprised, and then he jumped back and popped the bubble and he fell. The end. It's really weird.
How many of you use emojis? Most of you. You're not alone. 90% of the world's online population uses emojis. While there are many to choose from, they're fairly stereotypical. Like this is how boys or men are portrayed, and this is how typically women or girls are portrayed. To bridge this gap and to inspire young girls, Google has introduced a whole new range of emojis representing men and women in different roles and different skin and hair colors to be more inclusive. And this is now becoming an industry-wide standard with iOS, Facebook, Twitter, and others embracing these. Again, a great case of gender-based and ethnicity-based inclusive design. How many of you are familiar with harassment of women in online gaming communities? Any gamers in the audience? I see a few. So it's been a big problem in terms of female gamers and how hashtags and online commenting is used to harass them. And many of you might have heard of Gamergate as well. A few years ago, we organized a Women at YouTube hackathon around the theme of bridging the gender gap to bring around organic thinking and momentum around inclusive design. One of the salient projects in this hackathon focused on improving our comment system on YouTube to help women combat harassment and feel safer on YouTube. As a result of this hackathon project, we've released a lot of features and enhancements to our comments moderation tools, providing a lot more control to creators to handle these. A great example of gender-based inclusive design helping us deepen our engagement with our female creators, and also shows you that grassroots momentum can be built using things like hackathon to bring about change. YouTube Go, how many of you use it? Some. A few years ago, we realized that emerging markets have their own specific needs. With connectivity and bandwidth issues, many of you, I'm sure, have experienced the spinning wheel when watching videos, waiting for it to load. I see some nods and smiles. Also, socioeconomic factors. Not many have the latest smartphones and have hardware constraints. And also, localization of the content to make it more interesting for the local audience. To bridge these gaps, we built from the ground up YouTube Go that provides localized experiences and also focuses on offline first and is very bandwidth sensitive, giving users a lot more control and transparency over how data is used within the app. So now I've shown you several examples of inclusive design across different industries, many from YouTube and Google too. And I want to switch to talking about how can we do inclusive design at scale? And how can you become more proactive in inclusive design thinking rather than reactive after the fact? At Google, these are the different phases, typical phases of product development that we have. And we are starting to become more intentional about demographic goals at every phase of product development. So starting from the idea and target user definition, we are looking at our metrics and the business opportunities to understand what demographic gaps are there within our target user segments and which ones should we prioritize to try and fix and bridge. So as a part of target user definition, for instance, in addition to saying we are targeting users 18 to 34 of age, we say 18 to 34 with equal representation of men and women. Once we pick that demographic goal in that target user definition phase, we carry it through rest of the phases of product development. In testing, whether we are selecting users for user research or usability testing, or running live experiments and monitoring how the metrics are moving when you roll out new features, new changes, or internal dog food testing, making sure that our dog food users are representative of the target users we're trying to go after. A lot of what we do at Google is also about machine learning and algorithms. And you might be wondering, how can machines be biased? They can be because the training data that goes with them have biases. I want to roll a video from the machine learning team explaining the different kinds of biases that you want to watch out for. Let's roll the video.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool on the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
And finally, once a product is built, it's important that the branding, the marketing videos, PR, even the support that you offer are tailored to echo the demographic goals that you set. For inclusive design to really work within your companies, it's still very important to make sure you have diverse perspectives and you have balanced teams that you've built up and foster an inclusive culture. So to this end, the Google Computer Science Education and Media efforts is increasing access to technology education around the world to diverse populations. It's raising awareness of unconscious biases and unconscious bias trainings, and also changing the portrayal of engineers in the media because this can be an extremely powerful influencer. This next video I want to roll will show you some of the work we've been doing in partnership with the media companies.
When I think of the lack of diversity in Hollywood and the lack of inclusion, I figure if I'm not part of the solution, then I'm part of the problem.
When I meet students who look like me, I see their eyes light up when they learn that I'm an engineer.
The most rewarding aspect of this work is showing girls that they don't have to choose between computer science and their passions. Computer science is really just a tool for what they love.
Computer code can do anything. This one searches for signs of life in outer space.
Growing up, I was so good at math and science, but I didn't feel like I could pursue a career in STEAM because I didn't see anyone who looked like me doing it, especially not on TV.
A Google-funded Gina Davis Inclusion Quotient shows that even when women are leads in film, they still receive 3 times less screen and speaking time than their male counterparts.
The only way to find the source address is to access and analyze the datagram packets in this broadcast.
We want technology to look fun, accessible, and common as something to do for girls, or as some would say, normal, because it is.
I'm here because I want the billions of women and girls all over the world to know that you can be literally anything you want to be.
Our CS and Media team strives to change the narrative of computer science for people of color, the LGBTQIA+ community, people with disabilities, all aspiring youth, so they can finally see their reflections in the media.
As a woman of color and a mom, I want my kids to know they can pursue any career, regardless of gender or race.
Yes, absolutely. If the platform doesn't exist, we need to create it.
Google is in a unique position to work with partners to provide students with access to technology and empower them to be creators.
It is so cool to see their minds filled with possibilities.
So now it comes to you all. Hopefully I've inspired you about why it's important to do proactive inclusive design thinking. And I want to leave you with a little bit of a cheat sheet of what you can do when you go back to your offices or colleges. So think about the demographic gaps that are there. See how you can measure it and have metrics to go with it. Prioritize which gaps you want to go after solving, bridge them, and celebrate your success. Also foster an inclusive culture within your teams through things like hackathons and bringing about inclusive thinking across the board. And as you go through the rest of the day, if you have thoughts on one thing that you will do differently when you go back and you want to share it with us, please tweet it with #GDDindia. We'd love to hear from you. And next time we do Google Developer Days, maybe one of you will be here talking about how inclusive design has changed your business and your products for your users. Thank you, and I want to invite Sebastian back on stage for some wrap-up comments.
Thank you, Soumya. I hope you were inspired by this talk, and I had a few closing remarks, if they could be loaded on my screen, because I just forgot them. One thing is, I'd like you to enjoy the rest of the day today. You have a full day ahead of you, and the conversation doesn't stop with this wonderful event. There are many ways to keep in touch. Women Tech Makers, Google Developer Groups, Developer Experts, Launchpad, Android certification programs, developer agency programs. So Google any of the programs I've just mentioned to know more, or come talk to us today, or find us online. We are here to help you create amazing solutions to help solve real problems. And I want to hear from you. I want to hear these stories. I've been hosting events across emerging countries for the past 7 years, and I have to say, this event is quite something, but it was not possible to actually host this event without an amazing staff and production crew. People whose, I will not name everyone, but among others, Monica, Peter, Ben, Laura, Vanessa, Karthik, Dishot, many of them which I'm forgetting, but it's thanks to them that we can have this great event and have all of us come together today and share that experience. So let's give them a warm applause. Thank you for them. So, final few words. Bear with me. Apka safar anandai ho, aisi meri shubkamna, ar me apse fir milne ka ashwashan kartahu. Thank you very much.
Ladies and gentlemen, please can you make your way to your chosen breakout session, which will begin in 5 minutes. Thank you.
Good morning, everybody. Hi, I'm Amrit. I'm a developer advocate at Google, and today we're going to talk about performance tooling. Imagine you built an amazing app, and you've now rolled it out to a lot of users. They've installed your app, and then they tend to start seeing that even though you've built an amazing UI for it, some things are not right. Things are loading up slowly, there are crashes at times, or it takes too much of battery, for instance. These are all things that can hurt the user experience really, really badly for a user. They might not be able to kind of use the app and slowly start uninstalling, and you'll start seeing a bigger uninstall. If you look at performance, some of the things that we talked about, it's actually a two-step process. You have to be proactive about it, and at the same time, be reactive to changes also. What I mean by proactive here is that you've got to plan, measure, and profile your app before you even publish it. You might want to look at your competition. You want to look at how well your app is performing, and maybe benchmark against some of your competition to see whether your app is actually meeting the expectations of your user. And once you publish your app, that doesn't mean that your job ends there. You need to kind of continuously monitor and at the same debug any issues that are coming. So once you roll out your app to millions of devices and users are starting to use it, you need to take that data and start improving upon areas that you find that the app is lacking at. I'm going to talk about some of the tools that you can use and techniques that you can use to improve, measure, profile your app. I'll start with Android Profiler. We released this with Android Studio 3.0. I hope most of you guys are using that now. And this is a replacement for the Android Debug Monitor. This is the unified time model that you most probably work with when you're looking at performance. Let's take a look at all the different areas in it. You have the CPU, memory, and your network. Three things actually shown in terms of a timeline. And on top of it, you also have input events. This allows you to kind of track how your app is actually performing in these three respects with respect to what the user is doing. We also flag things like system events like a rotation of the screen. Now, if you see, the icon shows that the screen is actually getting rotated at this point, the activity is getting recreated, and you see a small spike in the CPU at that point. So you can relate some of these things in that one timeline. Now, you also have the activity state here, which allows you to kind of see what your activity is doing at this point of time. Is the activity stopping? Is it actually running right now? Where is the CPU spike? Where is the memory spike coming in? And you can use all these points of information together as you see the timeline. Let me jump into the CPU profiler. You might want to understand, because we have, in India, if you look at it, we have a varied set of devices. We have a lot of low-powered devices too, where the processor is not as fast as the latest and greatest of devices, and people still continue to use that. You want to be able to understand how your app is performing with respect to CPU. This is, when you click on the CPU part, the tab, this is what gets loaded up. Now let me walk you through some of the sections here. You have the thread list, which is basically all the threads that were running in the timeline that you've talked about. You have the CPU activity, which basically has three things that you can very quickly look at. The green, which is basically how the CPU is used by your application. The lighter green, which shows how CPU is used by the system. So you can make a correlation of how you're contributing to the system's load. And also the number of threads that are running on the device. The dotted line represents the number of threads. So you can sometimes relate that, oh, there are more threads running right now, so my CPU is spiking. The system is not loaded, but my app is actually using a lot of the CPU, things like that. You also have a thread state. So when there's a CPU spike, you can see, oh, what all threads are actually running in the system right now. And you can look at that correlation and see, oh, this is where I might need to optimize the CPU. Maybe this thread, the code that runs in this thread is where I want to kind of make some changes so that the CPU spike is kind of reduced at that point of time. But if you want to go more deeper into it, you need to do something called method profiling. This is basically tracking the entry and exit of methods that your app uses. There are two ways in which you can actually do method tracing. One, the red button basically starts it off, but the more interesting thing is the drop down next to it. The first method is that you can sample. You can do it in a sampled manner, which means the system will actually, what it will do is, it will take it at regular intervals of time, and it will start tracing, capturing all the invocations and exits of application functions. And the other one is called instrumented. Instrumented is where every single invocation is actually tracked. A lot of you might think, oh, then the instrumented is much better, right? Because we get a much more detailed information. Not exactly, because instrumented has a much more higher load on the system because it has to work continuously. So if you use sample, your state is not loaded as much. So depending on the use case that you're using and what you're trying to solve here, take one of these two. Let me load up one of the profiles that you have. Even though I'm showing static images here, these are continuous timelines that you can actually take. So this is a timeline that got captured, and then I've loaded that data in here. If you would see at the bottom, you have the call chart that is there. And at the top, you have the timeline and the threads and their states. Let's go a little deeper. I'm selecting a certain section of the timeline where I see a CPU spike. And then we want to analyze that a little better here. Now, the selected recording is the area that is in the blue. And you have the call chart for that area displayed and visualized here. Let's go deeper into that. Now, when you look at the call chart, there are a couple of things that you want to very quickly understand. The orange basically represents all the function calls which are system made. So your onCreate, what activity classes would do, things like that, fragments would do. And the system calls are all the orange ones. Your code is basically the green bars in there. And you can also see some blue color. That's basically system library code. So let me take one example here. If you look at that long green bar, which is basically an activity create, it is at a point where your system is rotating. You have the image detail activity getting loaded. And you see that the onCreate is really long. But when you go a little deeper into that, you see that the set content view in the activity is only 1/3 of the time. The rest of it is actually done by an initialization process called init, and then an image fetcher. Now, armed with this information, you can very quickly understand that, hey, in this case, my activity could have loaded a lot faster if I can move some of this code that is written by my application, is in my application, to another later point of time, or initialize it somewhere else. Your activity would load. So there's a point where the user could see a slow loading activity, and you have an option to kind of improve it by maybe rearranging your code or rearranging the flow of the data that you have in your application. So instances like this are very easy to pick up when you start analyzing this. This is not the only way you analyze. If you look at it, you can also see a top-down approach where you start from the top thread in your application, and you can see all the way down to the final invocation. This could be used when you want to trace a path and see all the functions that are being called and how they are getting what effect they have on the CPU. The other one is a bottom-up approach. Now that you've identified, hey, I have this function is a place where I'm going to optimize. How is this going to affect? Who are calling this one? So you take that function and you can do a bottom-up approach. That is this particular screen that I'm talking about right now. And that helps. The second one we're going to talk about is memory. This, again, for us, is very critical. For India, we have the variety of devices and the amount of RAM on these devices from low to high is such a big variance. You would see that out-of-memory exceptions is more common in some of the applications that we build and we deploy in our region here. So to help with that, you have the memory profiler, which basically looks at, it color codes all the different sections of your memory, the Java code, the native heap, the stack, all these things are color coded differently so that you understand how they are growing at each point of time. You also have things like GC events being shown here, which lets you know that, hey, at this point of time, the garbage collector kicked in. You have the option to actually force GC to understand the behavior at certain points of time to see that at this point, when I'm doing a lot of computation and the memory is increasing, can I force a GC to do something? Will that affect the application? Now let's take a segment of it and analyze it a little more deeply. Now when you select a set time segment, what default comes in the default heap, as is shown below, with all the allocations that are there. This is per class. So each class or a type is actually shown, and how much of allocation and deallocation happened over that period of time is clearly shown here. You can also arrange it by call stack. This is how you would want to, once you've identified some areas that you want to look into, the arrange by call stack and other options that we hear will help you really dig deeper into this. Now, when you arrange by call stack, you would see that, hey, at this function, my app is allocating these variables or this much memory. Now, you found out that at this function, the app is slowing down, or there's a lot of GC events happening. You want to identify why. So you drill down and see the allocation count, and you can fine-tune it to the last function call that has been made, and you can look at how much it is allocating. Now, there is another option that we have, which is very interesting, which is called which is basically by arranged by package. Now, in most of our apps, we have a lot of third-party libraries being added so that we reuse some of the code. Now, you might want to just work on certain parts of your code and optimize it to the best, leaving aside code that you don't have actually access for. You're actually just using the library in that case. So when you want to do that, one of the things you could do is you could select by package and avoid all the packages that you're not interested in focusing on, and then just select the ones that you want to work with, thereby improving those packages and the code that you've actually written. When you select one of the allocated allocations, what you would see is all the instances of that in that timeline that got allocated as well as deallocated with some additional parameters. So this gives you a fair sense of how many threads are getting constructed, how many times this is getting called. Should I actually make a static variable of this to improve? You can get to start thinking of all these options with that. Now, clicking on one of those instances, you also get the allocation stack. Like in every place, you want to kind of dig a lot deeper into it. So you can do a heap dump and then load that into the profiler. And this is how you will see a heap dump getting loaded. The same way you have the splits that I talked about. But when you click on the instance properties, you can also get the references to the instance. So if you see that you have a memory leak, this is a much faster way to kind of figure out how you want to drill down to the point and see what references are holding to this one. So it's much easier to work with them. The last profiler that I want to talk about today is the network profiler. Now, network, as we know, right now we have a lot of bandwidth, but people kind of tend to optimize a lot for network usage. And that is because one of the bigger concerns is the battery life of the device. Battery life can be affected drastically by overusing the network because the radio states, as most of you might know, when you use the network radio, it actually goes to this high power state. Then as you stop using it, it comes to this low power idle state, but it still consumes power. And then only it shuts down after some time. If you continuously use to transfer data or receive data, what happens is the device will keep the network hardware at its high power state, thereby consuming more battery. You don't want an experience where users love your app, but your app drains the battery so quickly that they decide to uninstall. So the network profiler will allow you to kind of see how much data you're transferring. At the same time, look at the radio states to understand whether you're actually impacting battery because of the network. So that blue line is where the network, different states of the radio is actually shown, where you've seen it at high power, or low power, or if the person is using Wi-Fi. Now you have a data transfer graph also. You have something like how much data got transferred, how much data was received. So the blue line here, the blue graph indicates how much data transfer is happening at what. And the orange line, not the dotted one, the orange solid line is how much data is being received. The dotted line is the number of connections that you're actually having, the network connections you're keeping. Sometimes you see that you are keeping unnecessary network connections and keeping a lot of resources. So these graphs very quickly visualize areas of concern for you and allow you to kind of drill down deeper to fix the problem. Like all the other graphs, you can actually take a time slice of this, look deeper into it. When you take a time slice, every HTTPS and HTTP requests are shown, visualized with a timeline next to it. They will tell you what type of network call it is, what have you actually requested for in the digging the mine, what is the size of that request, so that you can go in and how much time it took. So you can then literally go in and see, hey, I want to optimize this one network call. If you select one of those networks, you actually would get the response. If it's an image, that image will be actually rendered. This allows you to find things like, hey, is my cache working really right? Am I downloading the same image too many times? Am I downloading the right resolution for the image from the server? And you can also look at the headers to think about issues, find about issues, things like how much time to live is actually being shared by the server, so that the HTTP cache would hold this for longer. Things like that. You can also look at the call stack and see additional parameters here. Now with Oreo, Android Oreo, you can profile any debuggable app without any changes to it. But if you're actually targeting Nougat or below, you would actually have to enable advanced profiling and build it on Android Studio 3.0. Again, in order to enable this, if you're running the app, the system will actually prompt you with a nice dialog. So you just have to say OK, and it'll be the advanced profiling will be automatically enabled for you. The second one I want to talk about is API debugging. Now, once you have a problem, you want to go back and look at a little more into what's happening, right? Now, to profile and debug, you might be like developing a game using a completely different thing other than Android Studio. And you want an option to kind of go ahead and analyze and profile your app using Android Studio. In this case, we have added a new section where you can actually build your APK. When your APK is ready, then use Android Studio to go ahead and profile and find all the information that we talked about earlier here. So when you do that, what happens is it creates a dummy project, loads your APK, and then opens it up by default in the APK analyzer. The APK, and you can then go ahead and attach your sources, go ahead and attach your libraries, so that dependencies and other things can be fulfilled, and you can start profiling your code better. With the APK analyzer, that's the next tool that I want to talk about. How many of you guys use APK analyzer? I'm glad, a lot of you. Those who haven't raised your hands, please go back and look at that tool. It's really useful stuff. So you can actually invoke the APK analyzer from the build menu, or every time you create a build, it will actually show up with this nice dialog where it says locate your APK or analyze the APK. Clicking on analyze will actually load up a screen like this, where your app is actually shown with its different parameters in the APK, the different sections, things like classes, the dex files, the resources, your manifest, how much space they're taking with respect to total size of your application. By the way, there are two sizes being displayed here. One is a raw size, which is the APK size as a file, and the second one is a download size. The download size is basically how much data is going to be downloaded for this app when you are actually installing it from Play Store, because Play Store can do some additional compression on that. So sometimes these numbers cannot match with each other, won't match with each other. Play Store most probably will have a better will compress it a lot smaller and send it down the line. So the user will only download the download size, whereas your APK size is the size on the disk. And looking at this, like in this case, we have loaded the dex file. You can see that the classes.dex is taking the most amount of space in your APK. We have visualized it by showing you the size, the percentage of size this file is actually taking in your APK. A lot of times, it's not the classes.dex, but your resources that you will see as the offender when it comes to the APK size increase. You might have a resource which is really large, and that's occupying a lot of space. Then this allows you to kind of drill down to the area in your app which is taking most space and reduce the APK size drastically. And I want to also call out that this can be run from command line now. So you can actually add it to your CI systems and make this as an output, which is going to your CI. Every time your CI build runs, automated run, you can actually run this and get the data and do comparisons. Write a little bit of code, shell script. You can get comparisons against your previous one. Or you can get more data about what has increased, where's the area that this build needs to focus a little more with respect to app size. The last section that I want to call out is Android Vitals, which is actually part of the Play Store. Here what we have done is we have actually visualized a few of the parameters that are in the real world. So your app is out there, it's being installed and used by a lot of users. And if you look at these users, how is this app behaving on their devices? Now that data is collected and actually given to you in the Play console. And as a developer, when you sign into the Play console, you can go into the Android Vitals page, and you would see things like ANR rate, crash rate in real world. We visualize some of these parameters: ANR, application not responding; your crash rates, how many crashes are happening in the real world; slow rendering. This is something that's not easy to kind of find out otherwise. On how many percentage of devices is slow rendering happening? Frozen frames, maybe it's because GC comes into picture at times, but this is really good information for you to start saying, hey, I have this one problem in the real world. Let me start going back and being reactive about things. Let me go profile again, find out the areas that are of trouble, and then fix this, because this must be the thing that is affecting my users a lot. There are more things like stuck wake locks. You might not recognize, there might be coding errors or things that you missed out of your testing which has stuck wake locks, which is again going to ensure, which is going to make sure that the CPU doesn't shut down or the screen doesn't shut down, and at the end increase the battery usage of your app. Or excessive wake-ups. Is your app in the real world waking up too many times because of external signals, push notifications, or just because there are too many alarms on it? Any of these things, background processes, all these things waking up your app too many times. And we also have a section in DAC, developer.android.com, where we have specified for each section how the Android Vitals, what are they, and how you might want to respond and work with them. That's it from me for today. I hope some of these things are useful for you and you've learned something new here. Go back and profile your apps, and if you make substantial improvements, do let us know your story so that we can come in and help you with more stuff. Thank you.
Hello, good morning. Thanks for being here on a Saturday to hear more about PWA, AMP, other exciting things. My name is Ben Morse. I'm a developer advocate at Google, where I work on the web, helping make the web easy for programmers, fast, beautiful for users, and such. Before I was at Google, I used to make websites for companies like the New York Times, AOL, and before then I was a musician for some years. The band last night was incredible. If I could sing that way, I'd quit coding tomorrow and be a singer. I won't sing for you today, I promise. But we're here today to discuss something else, not my vocal ability or lack thereof, but the Shadow Reader, an example of the PWA and AMP pattern of combining these things together into a single application. The first question is, why? Why do this? Why learn new stuff? Well, I'm thinking about what I call sometimes the web app dilemma. 19 years ago, back in the previous century, the previous millennium, for front-end developers, life was pretty simple. Any kind of complexity, almost all the code was on the back end. There was Perl, maybe there was PHP, something else. The front end was HTML and CSS, and maybe just a little bit of this cute little language called JavaScript, which was used for small, cute little tasks like button rollovers. The mouse moved over the button, it would change color. That was kind of nice. That was JavaScript. Well, it's changed since then, and now JavaScript is this immense, complicated universe of frameworks and technologies and ideas, and these are all wonderful, don't get me wrong, but it ends up being a little bit hard for you and for the user. It can be hard for you because you're learning new stuff all the time. You're learning Angular, you're learning React, learning all the latest stuff that's going on. And if you want to have a fast application, it takes a lot of time working on performance, of tweaking things again and again so it isn't too slow. Because a lot of JavaScript, a large JavaScript framework, takes a long time to load and then to parse and execute on mobile devices. This was the problem. If you're on your nice computer in your office and you've got a fast wired internet connection, then all the JavaScript in the world might be fine, but on mobile devices, especially in countries where 3G is the norm, it takes a long time to load things up and parse things. So making the user actually deal with all that is unfair to the user. And you pay a price for that. You can see over here that over the years, the size of the average web page has increased quite a bit. It's just increasing more and more. And what happens is users are waiting for something to happen on their phone. They don't know all your wonderful frameworks in JavaScript are loading up and waiting to get parsed and executed. They're just saying, why isn't this thing loading? And they're liable to bounce off your site. So, okay, the web is kind of hard to write for in some ways. How about making a native app? Apps are easy, apps are good, and apps are fine. But the problem is the average user will probably never download your app. It turns out that, at least in the US, and it's probably similar here, 80% of users' time is spent in the top 3 apps. And out of the top 10 apps in the US last year, 8 of those 10 apps were owned by either Google or Facebook. So users tend to go, I apologize for the large, well-known apps like Gmail, like Snapchat and so on, and your app is not as liable to get downloaded. For repeat users, it's good. For first-time users, it's harder to say, download, install my app. And in fact, can you guess the average number of apps the average user downloaded in the US per month last year? The average number of apps the average user downloaded last year per month in the US was 0. It was actually a bit less than a half. But the point is that apps are very, very useful, but making your own app, it may never get used by anybody. So what do we do? I mean, the old days weren't so good. Websites were very simple, and users now demand more, especially on their mobile phones. They want an immersive, really nice, clear experience on their phones that a website couldn't provide 19 years ago. So what do? They want a site that loads quickly, and that is responsive, that is beautiful, intuitive, and so on. What do? Is there some easier way? is there an answer to this question? No. OK, thanks. Good night. No, wait, hold on. I'm just kidding. You also can try the combination of progressive web apps and accelerated mobile pages, PWA plus AMP. If you've been here for the last day or so, you've probably heard talks about these things. Who here knows at this point what a progressive web app is? How about accelerated mobile pages? All right, so we could maybe discuss this a little bit further, what these things are. Progressive web apps, as you may have heard or not, are an idea about making a mobile site more of an app-like experience. Fast, integrated, reliable, engaging. Note the first letters there do spell fire. This is not a coincidence. The idea is to make a mobile site as good as an app. And this is possible these days with modern web technologies and modern browsers. You want to have things load fast initially, to load fast throughout the app, to be app-like, immersive, to be in the whole screen of the phone if they want it, to have offline content, push notifications. All these things are now possible with mobile websites. And that is basically the progressive web app idea. AMP, or again, as we call it, accelerated mobile pages, is a way to make sites very fast. And you may have heard of it before because it first became used by publishers for kind of simple static pages. But AMP has evolved since its inception 2 years ago. And it's not just for publishers anymore. It's actually become a thing that can be used not just for simple web pages, not just a way to get into Google's AMP carousel on google.com and google.co.in and so on. But it's actually a nice new pattern to make sites faster, especially, and simpler and easier for users and for you, the developers alike. A little more about AMP. So AMP, first of all, custom JavaScript is no longer allowed, with a couple of exceptions here and there. Some expressions and things are still allowed. So all your frameworks you know before can't be used anymore, except for on the server side. This may seem very harsh, but all that JavaScript is useful, but can slow things down. So it forces you to have a performant, fast site. But on the other hand, with AMP, you also get an expanded version of HTML. With web components, you get new HTML tags that do the things that JavaScript did before. Also, CSS can be no more than 50K. A little more about AMP over here. I forgot. Sorry, the slide is next. That sounds kind of hard to do, to combine these things together. But we're going to discuss a simple example of this called the Shadow Reader, which is so simple that it requires no frameworks of any kind in JavaScript, not even jQuery. I think I skipped some slides somehow. That's weird. I lost some slides. Where are they? Here they are. OK, they're later in the presentation. All right, excellent. So going on over here, let's say that you're working at a major newspaper of some sort, and you've got a nice website, but it isn't that nice a website. And like most newspapers, you've got AMP on your pages. And the boss says, you know what? We need a better newsreader app over here for our site. We want to take our existing AMP pages and kind of mush those in to some sort of nicer, better progressive web app experience. So, all right, how is that possible? As we said before, these things can be combined. The animation there makes it clear. PWA and AMP are very different ideas, but they're compatible. And we'll show you how to do it. So why do this, first of all? Let's consider AMP in a few ways it's not usually considered. First of all, we'll think about AMP as web components. Second of all, as a source of rich data. And third, as portable, embeddable units of content, thanks to a thing called Shadow DOM. First of all, AMP as web components. So AMP began as this way to make simple web pages for publishers, but it's evolved since then into this powerful web components library. Here's an example of AMP. This actually will make an image carousel. Those things where images slide around the screen, where users can swipe images around, or they slide by themselves. This requires some JavaScript, perhaps a JavaScript library. It requires some work to make it performant, to lazy load images that are off screen. Well, AMP does all those things for you. It's performant, and it involves no JavaScript. You just say AMP carousel, specify the size of the carousel, because in AMP, all elements have their size specified in advance. So as things load in, then things on the page don't jump around. And then you just use AMP image tags in there, which provide performant versions of images. And then that's it. That's a carousel. That's the whole thing. Another example of an AMP component, a YouTube embed, for example. You just specify the width and the height and the ID of the video, and there it is. No embedding JavaScript, nothing else. There it is. And it's performant also. This component actually involves some complicated streaming technologies YouTube uses you can't usually access, but it's all there as part of this component. There's a lot of components in AMP. Analytics, ads, as you saw yesterday, if you're at my talk yesterday, AMP bind and AMP lists now enable dynamic content on the page. I think that honestly, a lot of pages on the web could be transcoded over to AMP, and they wouldn't lose a whole lot. They'd just be a lot faster. Again, it's simpler than other things on the web. Certain things are harder to do or not possible to do without JavaScript, but most things that most web pages do can be done with AMP components pretty easily. Next, AMP as rich data. So consider this. AMP is a set of web components and HTML. It can be used to store data, say about articles or about some sort of post, things that involve text, images, other things. It's kind of like a version of Markdown on steroids, because it also combines the power of AMP components into the data. So for example, let's say we had some JSON over here for an article about some random band called Ancient Babies. I don't know who they are. And then some content over there. The same thing in AMP might contain things like an image of a guitar. It might contain H2, some sort of markup information. It might contain also even an ad. All those things can be in your data. So again, AMP as a source of very rich data. Number 3, AMP as portable, embeddable content units. So you can take these AMP pages, and they're already units of content with this rich data and markup. You can plug these things in to other pages. So once again, you can take an entire piece of content, which is rich data with markup embedded into it, even things like ads into it, and plug it in to other pages. Which means you can take existing AMP pages, as most publishers have, and repurpose those things in other web pages. And now you're thinking, wait a second, that's what I was looking for my web app over here, for my boss. Taking existing AMP pages, repurposing our AMP pages in something else. Well, we can do that. But how? We use the magic of Shadow DOM. I love the term Shadow DOM because it sounds very mysterious because it involves the word shadow. So all Shadow DOM is a DOM that's embedded in and encapsulated in and attached to an HTML element. It's kind of like encapsulation you'd use for objects, for functions, basic good computer science practice, but the same idea applied to the DOM instead. So you see over here, you can imagine these AMPs kind of attached to DOM elements in a PWA. This allows a valid accelerated mobile page to exist inside a different page. The thing is that, as you may know, AMP has to pass validation. If AMP isn't validated, then AMP caches won't serve it. So Google, for example, will not actually accept AMP pages that don't pass validation. The validation includes no JavaScript, for example. But with Shadow AMP, you can have a totally valid AMP page stuck inside something else. Another way of seeing this is that a whole subsection of a page can be made into AMP, and the rest of it doesn't have to be. Here's how this is done. If you've used AMP before, you recognize there's a runtime that AMP loads up. This is a different runtime, which is called shadow-v0.js. This is the Shadow AMP runtime. How this works is when this actually loads, then it creates a global object called AMP. And then on the bottom, we have an attached shadow doc method that will use the AMP global object to attach to your chosen container an entire AMP document. Notice also that we use an asynchronous pattern here because we want things to be performant. So we load the script async. So then what happens if it's not loaded yet? How do you use it? There's a trick in the middle over here. We define this AMP ready function that takes a callback and attaches that callback to an array. That array is window.amp, the AMP global object. If AMP isn't loaded yet, we define AMP to be an array. When AMP actually loads, it then knows the array exists and sticks it back into the object. And then when it actually loads up, all your callbacks in the array are executed in turn. So thus, you have asynchronous loading over here that still allows you to attach your document to your chosen container using Shadow AMP. So we actually made this thing called the Shadow Reader that illustrates this pattern. And I'll show you how it actually works over here. If I can go over to the demo. There it is. That was like magic. So this is a thing that we built that uses existing articles from The Guardian in London. And you can see over here, this is a nice looking page. This is a PWA. And these things over here are all links to articles. You can see over here on the bottom, if you look at the source code, if you can see it, you probably can't see it. It's normal HTML. It's not AMP. But clicking on any article over here, very, very quickly, see how fast that was? The Wi-Fi here is kind of not very good today either. It pulls up the next article, and this article is an AMP article. If we actually inspect over here, if you can see this way down there, let's see if I can find it over here, you will see all this AMP stuff in there, AMP Pixel, AMP Analytics, and over here there's an article with this shadow root. So that's where the AMP is attached down there. We can go back to the other version over there. Notice that things animate nicely. These cards animate beautifully. There is, oh, that's not working. Actually, we'll see this in a minute too. If there's not an AMP version of the page, we check for that to avoid errors of any kind. And let's do that again. Pretty quick, right? Notice also the news here may be historic in the US. Michael Flynn is pleading guilty. Interesting stuff is happening in my home country. So there's how the Shadow Reader works. Also, there's an offline cache, so things can appear offline. It's a full-fledged PWA. Now let's go back to the slides over here, and I'll show you more about how this was built. There's the slides, OK? So again, as I showed before, the AMP exists inside a PWA. Here's how we do it. First, we pull in that AMP data from an RSS feed. Next, we take the AMP HTML and inject it into the DOM. And finally, the Progressive Web App makes the whole thing look and feel good for the user. The first step, pulling in the AMP content, pretty straightforward. We use a response XML over here. We use the XXML HTTP request. We don't use fetch because it turns out that the response XML already contains a parsed DOM. So this is pretty convenient over here. We then remove parts of the page that aren't needed. So the AMP page for The Guardian has these things like the header. It's got a menu over there. We don't want those things showing up inside our PWA, a second header, a second menu. That's going to be strange. So we simply remove all those things. And notice also, no jQuery has been used here, no JavaScript frameworks. It's all vanilla JavaScript. Second, we inject the AMP HTML into the DOM. As we showed before, you create a shadow root. You attach that there to your chosen container element, and then set it to pre-render, and there it is. So first, we actually loaded the AMP from RSS. Second, we inject that into the DOM. And finally, PWA does all the interesting stuff. Let's discuss the PWA part of it now. First of all, you get a fast initial load using an app shell. So it loads quickly when it first loads up. And then as the user moves around the app, things remain fast. And then as the user uses the app, it's an immersive app-like experience. We also use a manifest to let the user add this to their home screen like it was an app, and to have the display taken over entirely by the website like it was an app. And then offline content is also possible. all through the magic of PWA. We'll go over these things each in turn. First of all, the app shell, the idea of PWA, the app shell, is to have the basic shell of the app load first. So your logo, your title of your company, or in this case of your newspaper, some color, some stuff to indicate to the user that right away you're there in the app. As more things load, they can wait for those things. And here there's a very simple text-based way of showing things are loading. It's just a bunch of tildes and a pattern that kind of resembles an article. You could have graphics instead, but this is a simple app showing how fast you can do these things with as minimal stuff to use to actually make this happen. I noticed a couple years ago, I was using Facebook, and I was looking at my Facebook newsfeed, and I said, wow, Facebook's much faster all of a sudden. Things are already half loaded. I just clicked on this thing here, and the newsfeed's already mostly loaded. It turned out that it wasn't. They were tricking me. They were using these little bluish-gray boxes and lines, a static image that will then be replaced by the actual content. But I thought it already was half loaded. Users like this kind of thing. Here's an example of that, using just tildes to show the articles are on their way. Next, things load quickly anywhere you are on the app. This is easy because we're using AMP content. AMP content is fast, is written for speed, and the Shadow DOM lets us stick the AMP content into our app. Third, the app-like immersive experience. This is part of the pattern because as content changes, the HTML gets injected into the DOM automatically. And we use a service worker to handle URL transitions. You put in some animations and things like that, and it looks good. This was not very hard to do. And by the way, all this code is available online on GitHub. Check out amp.cards. Look for the Shadow Reader online. It's all there to look at as an example. Number 4, these kind of fancy app features, adding the home screen, that full screen display, are very easy to do. The manifest.json file lets you define icons and colors and things like that. Your phone will recognize these things if it's an Android phone and allow adding the home screen. And then the display is similar. You can specify what kind of display you want. In this case, standalone, which means it'll take over the entire screen like an app. Also very simple to do. Pardon my drinking some water over here. That's some good water. And then finally, offline content. This can be a little harder sometimes with PWA because you have to actually use Service Worker and define your own caching. This can be a little bit challenging, but in this case it wasn't. We did use one JavaScript library here, which is called Workbox, which has been discussed also at talks at this event. Workbox is a super useful and fast way to have caching happen and other PWA things happen. Over here, we simply cache some common routes. So once they're actually executed, that'll be cached in the browser. We cache certain key elements like some images and things like that. And notice again that these are some examples of actual code. None of these things use jQuery. You could use jQuery, but you don't have to. Just to show that you don't have to, we didn't use jQuery or any other kind of JavaScript library. So you've got your app. It works. The boss is happy. You did it. Congratulations. Good job. You kept your job. So you made this beautiful PWA. But is this AMP? I thought AMP was a thing that you had to do for Google because Google wants you to have AMPs. You can get into Google Search Carousel, and valid AMP is important. So is that OK? Can I do that? I mean, yes, you can. Does it actually matter? If the experience is good for the user, isn't that the most important thing? And in this case, if you want your pages to get served from the AMP cache on Google, it still happens because you've got your original news articles, which all have passed validation. So they all get in search results. They're all served from the AMP cache. Your PWA is something else. It's just a fast, nice way to read the news. Here's an example that just came out about a week ago. La Repubblica did this exact same pattern just now. These two screenshots show the same things that amp.cards Shadow Reader actually used. There's your homepage over there. Click on the article, which is in Italian, and then there it is over there. Over there on the right or I guess, yeah, your left, your right. It's your right, it's my left. Over there on that side, closer to that side where I'm pointing, awkwardly, is the actual article. And if you looked at the actual site, if you go to your laptops after this and check it out, you will see in there the shadow root and the AMP stuff I showed you a minute ago. This pattern can also go beyond publishing. So for example, let's say you're making a site which is a lead generation site with a form that involves multiple pages, say 5 different pages. Often these forms are hard for users to do. What if you use AMP forms, which have automatic validation, which are fast to load, which are quick, and then use a PWA around those form pages? User can then swipe between them, smooth transitions. Same idea, different vertical. Or e-commerce, for example. We discussed yesterday a whole different kind of e-commerce pattern. This pattern over here might be, for example, browsing a series of product pages. And as you change from product page to product page, PWA makes smooth transitions, allows offline content. So AMP product pages are more and more common. You can use those AMP product pages that already exist and stick those things into a nice immersive PWA. Another example, travel. Let's say you're looking for hotel rooms or some sort of shared rooming service or something else like that with multiple listings. The listings can be AMP pages, and then stick those things into the PWA. The upshot is all of this makes you money. You save money because it's easier to write these things. You can reuse existing pages. They're simple apps. And also you make money because users like the experience, which is fast and engaging, and you have more conversions. So you're making money on both sides. It's not all about money, though. For me, as a former musician, and still occasional musician, it's also about simplicity and beauty. I think that actually things that are simple and beautiful are good things because, I mean, as a programmer, you learn to make things that are clean, that are clear, that aren't cluttered with extra code that doesn't do anything. You want things to make sense to people. It's that simplicity and that beauty that make code good, and not just good aesthetically, but also more maintainable because it's easier to know what's going on. If you have less code and clearer code and simpler code, it works better. People in 5 years won't curse your name for putting in all this complicated stuff. Another reason to consider AMP is the simplicity and the beauty of things that are simple and beautiful. If you have questions, you can find me after this over at the Sandbox, over at the office hours. And also, people are asking a lot about where they can find out about AMP. So I added this slide just this morning. These 3 sites over here let you get started with AMP. AMPproject.org is our site that lets you understand the various components, the validation, the cache, how various AMP things work. AMPstart.com contains templates you can download to use that are pre-designed to make beautiful sites quickly, including yesterday's e-commerce template, the bike shop. AMPbyexample.com is a good way to actually see examples of AMP components and try out the components yourself in a playground to make modifications to things and to see the result immediately. Thank you very much, and have a great day.
With the instant access of the web, there's no place that I can't reach. The impact of the web on the newsroom was monumental. It's now more the reader telling the newsroom, this is important to me. You really have to start to build from scratch what is a story on the phone. With a progressive web app, there's a link, tap it, install it with no friction. The PWA is on their phone, done. And once that is installed, we are able to alert you to, hey, we got some more information for you. If you're interested in whatever areas that you are, you can install that subject, that topic, and we're going to serve you the content that you want. And that's going to change our business in a big way. The technology has enabled us to make our new PWA faster than their current mobile site. We're now able to deliver visuals faster. And if you can start to deliver visuals faster, then you can start to change the formats you do. People are willing to stay longer. If they stay longer, they see more advertising. The PWA is going to result in more personalization. Personalization will yield more engagement. The web has made me realize there's an audience out there, and there's an audience that's knowledgeable, and there's an audience that needs to be understood.
Polycasters, and welcome to a surprise edition of the Meownica Show.
So if you work in software development and you don't exercise your design skills, just practice, just do it. Do it even though you know that it's bad.
If you want to improve the quality of your site but don't know where to start, the new Audits panel is a great place to get some inspiration.
This is a quick web series about solving web problems with standards. Let's go.
I'll be right here to tell you what's new in Chrome.
That's Webpack Performance.
One day I'll get around to learning it.
You could just watch this video.
Knowing what is and what is not visible can be very useful information. I can change these properties in DevTools to find the ideal value for my layout.
It's Rob Dotson. Welcome back to the AliCast Show. I want to show you what just landed in Chrome DevTools version 60. So follow me over here to the laptop.
If you want the latest news and ideas in web development, subscribe to the Google Chrome Developers YouTube channel.
right. Hello, everyone. It's a good turnout for second day after lunch. I hope you guys had a good lunch. Right. A quick show of hands. How many of you are professional Android developers writing apps? Great. And I'm sure you must have heard about Android Oreo's background restrictions. So this talk is about background in general. And I will actually start from basic concepts and cover some use cases and a lot of best practices. My goal is to cover everything in Android background. And I hope that after this talk, you'll have a good understanding if you're having some questions or some doubts about that area. There's also a very fast-moving talk. So I'll move very quickly. If you have any questions, you feel free to get me after the talk. Let's get started. So what does people actually mean when they say running in background in Android? There are different views to it. So there could be running off the main thread on a background thread. So that's one very common use case when people say running in background. Or it could be running for a short time after the user has left the app. So you still want to do some processing when the user is not actively interacting with the app. Or this could also be a case where app is not even visible, not even there, but you are reacting to a FCM, a Firebase Cloud Message, or a broadcast, or even an alarm. There could also be a requirement to do some kind of periodic sync with the server. So you may want to run it when your app is no more there, but you may want to periodically wake it up, run something, get some data back. Or this could be some other scheduled job of some other kind, not necessarily network, but something else. Or it could even be playing music or doing something like that for which you may need a foreground service, even though technically not background, but essentially in that case, the user is not interacting with your app. So I almost categorize this as a background use case. But let's take a step back and see how the system, that is the platform, views the app in these scenarios. And that's the process state I'm going to talk about for a little bit here. So there is a foreground state of a process where if you're running an activity and it's in the resume state, the platform thinks of your process to be in foreground. This could also be the case when a service is actually on start is called on the service for a very brief time. There could also be a visible state of the process where your app is running, it's visible to the user, but it's not actively doing anything. It could be like pause is called on your activity, or you're running a foreground service. It could also be a service process where nothing is visible, nothing is running, but your service is running in the background, and that's called the service process. And then also a cached process, which is not so commonly seen, but it is the most commonly seen process state by the system. So if you have, in a device, you have dozens of hundreds of apps running, chances are that most of the processes are actually in this cached state. But the first two states are important for this discussion, because when I talk about background restrictions, these two states are the states which are known as the foreground state when the system sees the process, whether it can run a service or not. So I'll come back to it in a little bit. And then I already talked about the cache state, where most of the processes running on the device will be in the cache state at any given time. But let's just move into a concept of threads. So of course, in Android, there are various ways of doing threads. And generally speaking, there are 4 main types of threads in Android. Of course, Android developers will be familiar with the UI thread or the main thread. This is the thread on which your app runs. This is the thread where all the callbacks of the systems are called, from the system is called. And this is where the UI updates take place. This is the only thread that can actually do a UI update on the app. There's also these binder threads, which are also system threads. They are usually seen only in the case when you have a bound service, and that bound service is called by an external process. Some other app calls into that bound service, or you have a content provider where some other process calls into that content provider. All of these calls happen on system-provided binder threads. So binder threads are only useful or replicable when you are having inter-process communication, not usually seen in most of the use cases of the apps. Then there are so-called platform-managed worker threads. And I call them platform-managed even though they are regular threads, because there are some constructs provided by the framework that enable you to create those threads. Things like async tasks or things like intent service, which you use the system API to call to create them, but they are just regular threads. But the number of threads are somehow limited by those API surface. And then there are app control worker threads in which you can create your own thread pool. You can even, like, if you're using async tasks, you can use your own executor service right there. So you can basically create your own worker threads anywhere you want. At any given time, your app runs mostly on the worker threads. The UI thread or binder threads are mostly for system callbacks. So as any Android developer would know, you want to quickly go over to your worker thread and do anything you want to do, which is slightly long-term on those threads. All right, with that, there are different concurrency and async constructs provided by the framework. Of course, there is well-known async task, which is a convenience way of moving the content from, or moving the processing from main thread to worker thread and back and forth. There are some issues with async task. I'm not going to go into too much detail about them. Most of the issues are the way people use it. It leads into some kind of either memory leaks or some other issues. But that's aside. There is also a looper handler mechanism in Android. This is one of my favorite ways of doing threading in Android. It's also very central to Android. I don't see this being used very often in apps. But if I were to give you like a 30-second update on what this really is, a looper is nothing but a thread with a message queue. That's all there is to it. So there's a message queue, and a looper is just tight loop on that message queue. And a handler is a piece of code which is actually interacting with this looper. So on the handler, you have code to send message to that message queue or process message from that message queue. So that's all there is to it. So with these two, you could pretty easily create a worker thread, creates its own message queue, and then run a loop on that. Android app really is nothing but a looper. It's a looper which is getting messages on its so-called UI thread or main thread. That's all basic. That's central to Android in some ways. You could also use your own executive service if you're using Java. You create your own thread pool there. There are a lot of convenient libraries that provide worker threads for you. You don't have to do anything there. So like Retrofit provides some background threading for networking. If you're using RxJava, of course, there are convenient ways to create worker threads. You can observe something on a worker thread, and then it emits message back to the main thread. There are schedulers that you can use to switch between different thread pools. So there are various ways of doing multi-threading, and there are much more. I'm just covering some of them. But what do these constructs really have to do with the states that I just talked about in a little bit? So there are, of course, process states. I talked about them. And there are also component states. So your activity goes through a state transition, your fragments and your views and so forth. Nothing. You can essentially create as many threads as you want. But the process states and the component state is only governed by what the user is doing with the app and how the system is viewing your app. So between these two things, you can have as many threads, but the app can easily go into the cache state, even if your thread is actively doing anything. So each of these multi-threading approaches have very similar issues to deal with. No matter which approach you take, they run into similar. Some of them provide abstractions to help with those, whereas some like async tasks make it easy to make common mistakes. But there are very similar concerns. So activities, fragments, and views, as you know, are routinely destroyed and recreated. So you rotate the phone, the activity goes away, and a new one is created. So if you're doing multi-threading, you have to be aware of that. You have to make sure that you're not holding on to the stale reference of an activity which just got destroyed. If you're running a background task, you may also want to stop that task when it is not needed. So your main activity goes away or your main processing stops, but you may want to stop the background because you don't want to continue to burn battery for no reason. At the same time, which is more likely, if you started some processing, you may want to preserve that work somehow. You don't want to just completely stop that and throw away the work that was done in the last 5 seconds or so. So you may want to do all of that. So the question is, how do we actually deal with that? But before we do that, what are we really trying to do with this? So as I mentioned, the most important thing that Android developers deal with is to get off the main thread, get off the UI thread, and do something on the worker thread. That's easy. But then you also have to post the result back to the main thread so that you can actually show something to the user on the UI. That's a very repetitive pattern you'll see, and that's the reason why you look into all these multi-threading aspects. So let's take a simple example. I'll walk you through this sample in which it's a really simple sample. You can sort of apply it to any other example that you have, where you have a app in which it is getting the latest value of a stock from the network server, and you want to show it to the user whenever the stock changes. So in this case, you would want to start a background thread because you want to fetch something from the network. You want to periodically get the stock price. You want to update the UI, but only update when the UI is visible. So you don't want to try to update when the activity is no longer there or the fragment is hidden or something like that. You also want to survive rotations or configuration change in general. So you don't want to kind of crash or destroy something or leak something. So you want to do that. You also want to preserve the work. So assume that you downloaded the latest value of the stock and you're running some algorithm to kind of do some calculations on that. You have done that on a background thread, and you want to preserve the work. You don't want to throw it away even when the app goes away, at least for a few seconds. But you would also want to stop cleanly when needed. So you don't want to run forever. You don't want to run unnecessarily. So you want to stop also. So as you can see, even in this simple sample, you have a lot of these requirements that almost everyone has to contend with. And there are various ways of doing it, and this is where people make mistake. So with this, I want to introduce a best practice to do these things using Android architecture components. Yesterday, you may have attended a talk where we talked about architecture components in depth. There was also a ILT, a training that was there on architecture components. Here, I'm going to give you a brief, very high-level overview of that. And if you missed the training yesterday or session yesterday, I would recommend you go back and listen to it again. At a very high level, I'm just talking about two components here for architecture components: view model and live data. A view model here I'm using almost as a holder for live data objects, and the live data is essentially a lifecycle aware component where it is tied to a widget or a view element on the activity, and it knows when to update that. So it automatically updates because it's aware of the lifecycle of that component. That's at a very, very high level. And as you can see, the scope of the view model is associated with the activity, but not the instance. That's the critical difference here. So even if the activity instance is created and recreated, the view model will survive that. So it survives the entire life cycle until the activity finally goes away. The user clears it up or finishes call or system kills it. But in any other case, the view model preserves the state of the data alongside the life cycle of the activity. And I said live data is life cycle aware, so it knows when is a good time to update the UI. So with that high-level background, let's just look at some code here. So yesterday, if you had attended the talk, we talked about different tiers of architecture, a best practice, so to speak. And one of them was a repository, which is basically a set of classes which deal with getting the data either from the network or from the database and making the data sane for you in one place. So this is really a naive sort of implementation of that. I'm calling it Stock Manager. And in this, what I'm doing here is I'm creating a worker thread. I'm using a handler thread class in Java, in Android, sorry, which creates a worker thread for you. And essentially what I'm doing here in the handle message is there is a listener that is attached to it, and I'm calling that listener every time there is a price change. In this case, I'm only incrementing it, but in the case of price plus plus, you can think of going to the network and getting that value because this is running in a background thread. There's also this request update method, which somebody will call, a client will call in, and they attach their listener to it. And there's also this remove updates where the client goes away and they remove their listener. And I'm actually using handler.postDelayed here, which is resulting in sending the message to myself where I'm checking if there are no more clients. If there are no more clients, then I'm actually stopping all the work. So it's a pretty straightforward way of actually cleaning yourself, either giving some time or looking at the state of your clients. The good thing about this class is that it has nothing to do with Android. This is pretty standalone repository kind of class which you can test in isolation. So with this, I'm able to start a background thread, and I'm able to periodically get the stock price update. A view model, as I said, is a class that is associated with the activity. And all I'm doing here with view model is using it as a holder for my live data. The live data is actually just a piece of a data that is holding on to the stock price. The live data class is a little more interesting. So first of all, here I'm creating my listener. Remember the listener that I attached to my stock manager? I'm creating it here. And whenever the callback is called, I'm doing a post value. A post value is live data method which is used from the background thread to update the value of the live data object. And then we have these on-active and on-inactive callbacks. The on-active callback is called when there are active observers to this live data. And I'll show the observers in a little bit. But as soon as there is an active observer, an on-active is called. So I'm requesting the updates to my stock manager. And on inactive is called when there are no more active observers. And in this case, I'm removing the listener from it. If you remember in the Stock Manager class, I'm stopping the work there. Can you guys hear me fine? There's some background noise. No? You can hear me, OK. Because I can't hear myself from here. If you look at the activity class, all I'm doing here is basically getting hold of a view model. And this view model is the one that I said is associated with the activity in general. And then I'm creating an observer. And with this observer, I'm observing the live data which is there. So this is where I begin to get the updates whenever the live data changes. So that's all there is to it, essentially. So you can see there are 3-tier model, a repository, a view model, live data, and my main activity class. All right. So as you can see, with very few lines of code, I'm able to achieve all of this pretty easily. I'll share this slide deck and some code after the talk with you. So a best practice here is to use any background thread mechanism you want, but be aware of the UI update issues and also component and process lifecycle. So that's the key here. But people say, OK, what about intent service? So there is intent service which we have been using, which essentially is nothing but a hybrid of a handler thread and the service component, which is a very nice way of actually doing some background work. However, intent service is just a started service. And started services don't run freely anymore with Android Oreo. With Oreo, the service will stop very soon after your app is not in the foreground. And you cannot start a service if you are not in foreground. So app can be in temporary whitelist state. There are some states defined, whether you're handling a high priority GCM message or handling some kind of an SMS. In those cases, you are in a temporary whitelist and create a service. But that's very, very rare. In most of the cases, you will not be able to start a background service from background. So what is foreground again? So if you remember, I showed you the states here. Here is a more comprehensive view of it. I'll not run through every line here, but at a very high level, you can see that there are only 2 states where the app is considered to be in foreground. So there is an activity running in a started or a resumed state, or a service which is running with a start foreground. Other than these 2, your app is mostly in the background state. So in other words, unless the user is actually seeing something, you are in background. And in background, you cannot run a started service, including the intent service. So if you're wondering how do I know what my state is in, you can always run dump_sys command shown here. In this example, I was running a background service with a foreground activity. When I ran it for the first time, the first line, my state was foreground, and the process state was stop-activity. And the second one was when the activity went into the background, and the service was still running. And the last one when the service was actually stopped. So, but what are we really trying to do with background services in general? So a good example for that is that I was running my app, and I was running something in the background. And the app goes to the background, but I still want to finish what I was doing. I want to continue what I was doing. I don't want to just stop it right there for a little bit more time. So with that, I want to introduce a best practice for using a job intent service. If you're not familiar with job intent service, this is a new construct added in support library 26.1. The way it works is that if you use job intent service, in the pre-O devices, it runs as a normal intent service. So it behaves exactly the same if you're familiar with intent service. If it is running on O or later devices, a job is dispatched via a job scheduler.enqueue method. And it will start almost immediately because it uses a new method which is called set override deadline with a 0 there. So it will immediately start processing almost as if it is a job, as if it is an intent service. So here is a simple refactor. If you're familiar with intent service, you can easily convert it into a job intent service by just extending the job intent service. Instead of calling start service, use enqueue work. Instead of having on handle intent as your callback, use on handle work as your callback. And in both the cases, you will be called on a worker thread. So the worker thread is automatically created for you. So it basically does the same thing as intent service, except it is more robust and backward compatible as well. So for any background work that you want to ensure finishes after your app is no longer visible, use job intent service. So, but if you really want to use a background service for something different, like for example, syncing of data. So your app is no longer there, it's no longer visible, but you still want to sync data periodically, or you want to sync data after some time. So that's a valid use case. But be aware of DOS and app standby. So this was a new feature, or a feature that was added in Marshmallow, and it's been progressively increasing in complexity, where if the screen is off or stationary and not plugged in, you will not get any network access, and the wake locks are ignored and so forth. So I'm sure you're aware of it. I'll not go into too much detail here, but be aware of that. So even though you want to run something in the background, chances are that you may not be able to do what you want because of these restrictions. Here I want to introduce Job Scheduler. So I'm sure people, you're already familiar with Job Scheduler, but real quick, it is for any background work that you were using a started service before, I would strongly recommend to use a Job Scheduler now. Why? Because it works well with the DOS maintenance windows. You will get complete network access and everything else you wanted to do in a very nice and efficient way using Job Scheduler. You can also specify conditions when you want your service to run. So you can say what network type needs to be there, or what should be the retry policy. In fact, with O, we added some new constraints in which you can actually say that run only when there is a certain battery available, run only when there is enough storage available on the device. So you can have additional constraints to run your job. That's really, really valuable. So for most longer running background work, for which you were using a started service before, use Job Scheduler. Foreground service can also be used for a user noticeable, longer running task which does not need user interaction. So an example of this could be a media app. So you want to play some music or something like that, or a navigation app where you want it to be running, basically even when the screen is off, use a foreground service. You may also promote a background service to a foreground service by calling start foreground service, or a new method defined in context. New method defined context, creates a foreground service while you are in background. So you can do that in Oreo and above. But the most important takeaway from this is that do not surprise the user. So you should not be using foreground service when the user is not expecting it, because foreground service will need to post a notification to the user. So when they see that, they should be able to relate to it. That yes, of course, I use this. I need this. So let it run. I'll just quickly skip over a few things here. Sync adapters is another Android construct which you may already be aware of. But I'm talking about it very high level because this is sort of a legacy mechanism. It is somewhat cumbersome to set up. And it's only useful if you're already using content providers. And the content providers essentially is again another Android component which should really only be using when you want to expose your content to another app on the device. If you don't have a use case to actually exposing your content to other applications, you really should not be using content providers. So instead of that, you should use a combination of Job Scheduler, Room, or some similar library for your database, and your own sync logic. So that is what I would recommend if you're not already using sync adapters. Another important construct for background is alarms. Use them sparingly, as I said. It is a system-level service which you can use to send a pending intent to your app, and it can be triggered with inexact or exact times. But remember that your app may actually be in background or when handling a pending intent. So if you were starting a service before, you will not be able to do that anymore. You can, though, send a broadcast to your receiver, and while you do that, you can post a notification to the user. So if the user interacts with your notification, at that time, you can definitely start a service. Or you can do something else, like with the notification, you can take the user to some activity. Like they were expecting something and they see the activity. Or you can even start a foreground service if that makes sense for your use case. You can even schedule a job with Job Scheduler with an alarm. And you may even use a set alarm clock functionality for a user visible clock event. But like I said, for all of these cases, you have to be very careful to use Alarm Manager for only when you really want to be doing something at a specific time. But for all other cases, I would say use Job Scheduler again. This is a very useful construct which system manages really, really efficiently, and you will be able to do most of the things that you were doing with either service or alarms using Job Scheduler. So really high level, I'll not again go into too much detail of this chart, but this tells you what is actually happening when your device is in app standby or light DOS or DOS mode. Most important takeaway from this, as you can see here, is that there is no network. In any of these states, you do not get any network. Even though your alarms may fire, even though your app is called back, but you don't have any network. So there is really no useful use when you actually are in, let's say, dose light mode and your alarm fire. So try to stay away from those scenarios and make use of Job Scheduler again. I'll wrap this talk up by talking about Firebase Cloud Messaging. So at very high level, there are two types of Firebase Cloud Messaging messages, a notification message and a data message. And both of them can be sent with normal and high priority. A normal priority FCM messages are batched for dose maintenance, whereas a high priority FCM message can interrupt dose and app standby. However, you should only use a high priority FCM message when it is absolutely critical to notify the user about something. For example, a new email has arrived or a new text message has arrived. Let's talk about some best practices here real quick. Do not use high priority FCM unless it is a user critical. I already said that once. You should use normal priority FCM messages for any notification message, for any minor user update. For any data updates, and this is very important, for any data update, even if it is like a sync message to your device or to your app, try to use the payload of the FCM message itself. This is very battery efficient, and you will be able to do a lot with 4K. So try to send all the payload to your app, and then the app can update itself over time. If it is absolutely necessary to fetch any additional data after an FCM message, then either use a job intent service or schedule a job to get that data. But again, always notify your user when you're using a high priority message. So today, it is possible to not do that. But as you know, that Android is moving more and more towards scenarios where we don't want to surprise the user. We want to preserve the battery. So expect that there will be some more restrictions on these lines. So be prepared to handle FCM message in a way where you're actively notifying the user as soon as you have a high priority message. So with that, it was a very quick talk. I actually covered a lot of ground on various background scenarios. But with all of these best practices, I would urge you to go back and look at your app again and try to see if you can fit in any of these best practices. If you still have any questions or concerns, or if your use case doesn't fit into these things that I mentioned today, feel free to talk to me after this session. I'll be here, and I'll also be at the office hours. Thank you.
你只需要打一个连接，你就可以开到那个网页了。你不觉得这是好像一个魔术一样吗？我在马来西亚长大生活。马来西亚是一个多元文化、多元种族的国家。我们有马来同胞、华人、印裔同胞、卡达山族。虽然大家都有不同的宗教信仰和文化。大家都能在这片土地上和睦共处，这是最值得骄傲的一点，这也是马来西亚的特色。在城市地区，大多数地方都有 WiFi 连接，通常上网不是一个问题。但是可能在比较郊外的地方要上网的话，就可能比较困难，因为设施还不完整。老一辈的都慢慢开始会使用网页，使用 iPad， 用电话上网。父亲并不完全知道我的工作性质是如何，他只知道我是做关于 IT 的，他只知道我是偏写软件的。我爸呢，一开始接触上网的时候，其实他最想要做的就是要知道即时彩票开券的号码。当他知道他可以上网得到这个资讯的时候，他就开始叫我和弟弟叫他上网。我爸现在拥有智能手机，他会上网，他会上 Facebook， 他会用 Bud Apps 和我们聊天。我们还有一个家庭组。因为现在很多在做 Web Development 的，都是从学校毕业出来。其中一个很大的挑战，你学到的东西并不是和你在领域上面需要的东西是一样的。在他们学习的当中，他们必须要令他们自己精修。所以我觉得必须要做的是，要有一些课程，要去一些学校里面跟他们说，其实现在这些就是最新的科技发展，你必须要实时更新自己。我开始找寻我第一份工作的时候，我遇到了困难，因为当时我所学的技术和当时领域需要的技术是不一样的，所以当我去第一份工作面试的时候，我失败了。当时那个面试者对我说：“你不适合做网页开发者。”当时我还蛮伤心的。过后我没放弃，我去面试第二份工作。幸好当时我第二位老板对我蛮好，他说只要你肯做，我就给你机会。所以我就开始做那份工作。过后渐入佳境，我也升职了，还有机会去面对客户然后渐渐的我发现我越来越喜欢我现在所做的工作。我希望别人叫我工程师，也可以叫我女性工程师。在马来西亚很少找到女性是做 Web Development 的，身为女性还是属于少数的，好像是 Real Girl KL 还是木湖 KL， 我们会有talk 的 session， 我们会有一些 meet up， 我们会有一些 collab， 去教导一些科技之类的知识。所以我觉得这是一个方法去 gather 女性在同一个 community 里面，就更加方便交流。当你们有交流的时候，你就知道别人其他的女性到底在这个领域上面遇到什么问题。
Our whole objective is to get more females to pick up coding.
It's more or less the same problem in any male-dominated industry.
Yeah. For the first project, you just can't fail. You need to prove yourself. So after that, everything will just go just fine.
So I think we as a community is the place where we provide the platform for people to start from ground zero.
当我们去 organize 这种 workshop event 的时候，因为在马来西亚就很少类似的 session。如果我把40张票放上网的话，如果我们没有控制的话，可能30张票就会给男性直接塞了。当然，我们也不是说要特别去turn到男性去参加这个 event， 因为我们是Women Who Code嘛，我是希望更多的女性参加这个 workshop， 所以现在我们做的就是可能把大概70-80% 的位置先保留给女性。在传统华人而言呢，父亲是扮演一个比较严厉的角色。父亲通常不会说一些说你令他骄傲的话，只是从别人口中就会听到，就是从他巴萨里的朋友口中就会听得到。一开始我是觉得惊讶，因为他从来没跟我说，就惊讶比较多。惊讶过后就有点窃喜，因为他算满意我的成绩。我觉得呢，网页是无法被代替的，只是有什么是我们可以做，可以令网页更加 popular， 更加多人使用的。学习网页、学习开发这一部分，在马来西亚还是比较缺少的。我觉得我个人的经历是有影响到我如何去 mentor 新的人，去领导他们怎么学习网页。 我希望我是其中一个推动网页发展。我希望做到的是，让这种知识更普及，更多人知道如何开发网页。
All right. Well, good afternoon, everybody. Thanks for joining me. My name's Pete. I'm a developer advocate on the web team at Google. And I've been working on the web since pretty much as long as I can remember. I love the web because I think what's most awesome about it is that it makes the world accessible. As a developer, I don't need any crazy hardware. I can start with a really low-end computer or a really high-end computer. And for my users, it's the same thing. They don't need to go buy some crazy brand new high-end computer or high-end phone. You can do it with basically whatever device you have. The web really makes it easy for us all to connect. So it's one of those things that is a pretty awesome experience, and it's why I love the web. And today, what I want to talk to you about is progressive web apps. How many people have heard a little bit about progressive web apps so far? Awesome. Yes, that's the answer I want. Well, I want us today sort of blow away a myth. And that myth is the idea that a progressive web app means starting from scratch, right? You don't have to start from scratch to build a good progressive web app. All of us have spent a huge amount of time and effort to build a really great experience with what we currently have. And to take that experience and throw it away to start all over again, well, it's a lot of work. And our boss is probably going to say, no, not going to happen. So I want to walk us through an idea of how we can take a progressive, or take an existing app and turn it into a progressive web app. We need to do that, we need to have some ideas and sort of some tactical things that we can approach in order to take those steps to get there. So in that spirit, let's set sail on a little journey and turn our single-page app into a progressive web app. Now, this app that I've got, it is a single-page app, like I said. It uses the iFixit API in order to access repair guides, all right? And this initial implementation uses client-side rendering to go in and render everything. And it uses React as its sort of rendering engine. Now, this uses React, but everything I'm going to talk about today works for whatever browser, or not browser, whatever framework you want to use. If you use Angular, Angular's got stuff there. You can do this with Polymer or whatever that you're building your platform on. You don't just have to be using React, all right? And in fact, I'm not much of a React expert. I've played with it like once. So that gives you an idea of where I'm coming from. Now, if you want to see the code that was used for this, as well as all the diffs for each of the different steps, you can go to the URL up there, and that'll give you all the code. You can grab the code, play with it, see how it works and what's going on. Now, I'm going to let you in on a little secret. I'm not going to do any live coding today, and the demos that I have, I pre-recorded them a couple of days ago. And I did that because, well, sometimes the network goes out, and sometimes the network, or the demo gods get really mad at you. And so rather than fight the demo gods, I recorded the demos so that we can see them. And also, I have a hard time walking and talking and typing, so you don't want to watch me do that. Anyways, so let's have a look at what the app looks like. So this is Chrome. Type the URL in, sure. This looks exactly like I expect it to look. I've got a list of different products that I can repair. I've got a bar up top. All right, looks awesome. Now, as developers, we need to be testing in all the different browsers, right? So let's have a look at it in Firefox. So Firefox, same thing. Go type in the URL, see what happens. All right, looks exactly the same. Good. Now, Safari. Now, I'm going to do something a little bit different here. And I've disabled JavaScript in Safari, all right? Because I want to see what the experience looks like for a user who has disabled JavaScript. All right. Uh-oh. There's nothing there. Now, there's nothing there, not because it's a problem with Safari, but because this is rendered client-side. And with no JavaScript, we can't render anything. So yeah, this is not very good. This is one of the things that we're going to want to fix during our little journey today. Now that we've got a feel for what this app does, we're going to go and use a new panel in Chrome DevTools called the Audits panel. This is going to go run a series of audits and tests on our progressive web app or on our app and give us suggestions on how we can fix this. Now, if you've played with Lighthouse before, or if you were just in the sandbox area and you saw Lighthouse, this is the same thing. All right? So it goes in, we've moved it into Chrome so that you can run it anytime you want. It's really easy to run. But it's also available as a node module. All right, so that means you can run it as part of your build process. Maybe if you're using something like Gulp or Grunt, or maybe you've got some Travis integration, so that when you check something into GitHub, you can say, hey, how's this going to work? Did this PR, did this pull request break anything? And in fact, a couple of projects that we have at Google, we do that with our GitHub repos, so that we can make sure that we didn't break anything. All right. So we'll run Lighthouse to get a baseline, to understand what's going on, see what's working well, and what maybe doesn't work well, and what we can improve. So let's see Lighthouse in action. Pop open to DevTools and go click on it. And this is going to go and reload the page a couple of times. It's going to reload and look at the traces. It's going to turn the network off. It's going to try and reload the page then. It's going to see how long it took for things to become interactive. It's going to do all sorts of different tests, and you'll see things flash up and down. Now, usually this takes about 60 seconds to run. So the other advantage of doing this with a couple of videos means that we don't have to wait for the 60 seconds. We can just sort of skip ahead. Now, Lighthouse is a really great tool. And it's really useful in looking at numbers and seeing, hey, what score did I get? And looking at what audits passed and failed. And it's going to give you a score out of 100 for each of the different categories. But I'm going to tell you right now, don't focus on that score. That score is important. That score is good. And getting 100 out of 100 is awesome. Like, if you get 100 out of 100, give yourself a pat on the back. But also, let's be realistic. How many people got 100 out of 100 in every class in school? Right. Nobody gets perfect scores all the time. And as you learn, as things change, your scores will change. So don't expect to get one score and have it perfect. Things will change over time. All right? And the other thing is Lighthouse is a great tool to go, yeah, this works well. But this isn't the only tool you should be using. You should be looking at things like your analytics to see what browsers your users are using, and checking things out in those browsers. Checking it on different operating systems, different ways of that. So with that caveat out of the way, let's have a look and see how we did. All right, so I told you don't worry about numbers, but 36 kind of sucks. All right, so we've got 1 red, we've got 3 green. So obviously, there's a lot I can do to improve my progressive web app score. I can get that from 36 up pretty high. Performance is at 79. That's OK. Like, if I got a 79 in school, I was usually pretty happy. Accessibility, 91. And best practice is 85. Generally, my goal when I'm working on a project and what I recommend to other developers is you want to aim for like a score of above 90. All right? Above 90 says, yeah, you've probably done most of the things that you need to do. You might be missing a few things here and there, but there's room for improvement, but you've hit the major pieces. So let's have a look at why. In our progressive web app score, we've got a lot of failed audits. You can see there's 7 failed audits there. There's no service worker. It doesn't work when it's offline. It doesn't work when JavaScript's disabled. We haven't done anything to make the app work well on our device, like adding a manifest or setting any of the meta theme colors or anything like that. So really, there's just a ton that we haven't done, which means there's a ton of room for us to go do stuff. We did have 4 tests pass, woohoo, but really only 3 of those. So I ran this on localhost, which says hey, HTTPS, well, we don't need HTTPS because this is getting served from your computer. The page did load fast on 3G. We've set the correct meta viewport. We've sized everything properly. So we've got a good number of things that we did right. Then it also has some suggestions on some manual tests that we should run, some things that we want to check to say, hey, what else can we do that Lighthouse itself can't really test? Now, in terms of performance, I'm okay. I could probably do better. But the big thing that I'm seeing here is that time to first meaningful paint. So the first time that I saw something useful on screen was almost 4 seconds, right? You can see the film strip view of what was going on up there. So like at 2 seconds, well, at about 1 second, I got the blue background. And then at 3.3 seconds, I got the toolbar. But it was almost 4 seconds until I got something that was kind of useful to me. That's really long. And our speed index is almost 4,500. That's way too high. We want to aim for that around 1,250 or so. All right, in opportunities, it gives us a bunch of things that we can do to improve our performance. Some things that we can say, hey, enable text compression, running this on localhost, not a big deal, reducing some of our render blocking styles and all that kind of stuff. I could go and spend lots of time hyper-optimizing this, but I'm not going to do that. I've got other things that I want to focus on today. We've done well on accessibility. There's a few things we could change, but again, we're above 90, so I'm going to save that for another day to go and improve those pieces. We're generally doing pretty well on our best practices. 85, I could maybe do a couple of things to get that up, but again, there are places where I can spend my time to get the scores up and do better. So I'm going to sort of not do anything intentional to change this. So the first thing that I'm going to do is add server-side rendering. And that means that the browser is going to get that fully populated page as soon as it makes one request, right? It doesn't have to go and make multiple requests to say, oh, hey, I need this, and oh, hey, I need that kind of thing. So it means also that it's going to work if JavaScript is disabled, right? Or maybe switched off. Or maybe, oops, I kind of goofed my JavaScript up, and my JavaScript died on me, right? So this works for this app. And it may work for your app, it may not. So sort of take this with, should I be testing this? Is this really important for my experience? Now, it's fairly straightforward to add in server-side rendering to this React application using universal JavaScript between the client and the server. So we're going to share the rendering code on the server and on the client. It's going to be identical in both places. I'm going to use Express, which is a web server to serve my files, because it works really well with the React router. It just kind of makes my life really easy. But speaking of React, other frameworks have similar ways of handling server-side rendering. So if you're using Angular, you're using Ember, whatever, they have their own way of doing that. And you can just check that out and go down that path. So this is not just a React thing. So the first thing that I'm going to do, like I said, I'm going to show you the code snippets, because watching me type gets really boring, and I have a lot of typos, and you don't want to watch me typo. It's just, I've done it a couple of times, and I always fail, and I'm just like sad panda going, So the first thing that I'm going to do is add this serve task to my gulp file. So that's going to go and start the Express server. And that's going to mean that I'm pretty much serving this stuff directly from my server. Then in the server, I'm going to add React, and I'm going to go and render the content into the React bit. So I have to update my app to go and add all the stuff I need for that. And then finally, I need to update my index file. So go in so that it goes and inserts and injects the right HTML into the right place. Now that we've got this set up, let's take a look in Chrome and Safari to see how it looks. Now, I don't expect anything to change in Chrome, right? Like, we're rendering exactly the same thing. It should look exactly the same. Looks pretty much exactly the same. One thing you may have noticed is it did feel like it rendered a little faster, but I'm not really sure. Like, That's the thing about not using a tool yet. You can't really tell how fast it did. So we'll see how it did in a second. Now, Safari, go run that. Type in the URL, and it works, right? Because we got that fully populated page there. Even with JavaScript disabled, we're in a good place. So let's see how adding server-side rendering did for our Lighthouse scores. Now, the same things happen again. Go up to DevTools, go to the audit panel, right-click, go. It does the same thing. It loads the page, refreshes things, turns network off. You don't want to listen to me talk and babble. All right. So this is good. By adding server-side rendering, we saw a pretty good jump in a couple of our scores. Our progressive web app score went up from 36 to 45, so we had about a 10-point jump there. And our performance went up by, I can't do math on stage, 11 points? Went up to 91. Like, we're above that sort of magic bar that I was talking about earlier. Let's take a look at why. Since we only added server-side rendering, I wouldn't expect a lot to change here. And only one thing did change. We got 9-point increment in our score because the one thing that changed was now that JavaScript is available even when JavaScript is available. Now content is available even when JavaScript isn't there. So, all right, that was 9 points that I got pretty nicely. In terms of performance, we got a huge bump, right? We got an 11-point bump, and we're above 91. The biggest thing that changed is looking at that first meaningful paint. Remember before we were almost 4 seconds? Well, now we're down under a second. We're at like 870 milliseconds. That's a huge drop. Because we don't have to make all these multiple requests to get different things, parse and compile the JavaScript, then go, oh, hey, I need this thing over here. We're able to really speed up that experience. And our page speed index dropped as well. It went from almost 4,500 to down to just about 2,000. It's still above our number that we're really trying to aim for, but it's a lot closer, right? It dropped more than in half. Opportunities to improve have now changed. I could go through and fix a bunch of these, but meh, 90, happy. All right? Let's go ahead and add a service worker to make sure that it works instantly and reliably, even when the network isn't. But one thing I want to remind folks, service workers are great for that second load, and they work in a lot of browsers, but they don't work everywhere. So we want to make sure that we really focus on that experience. So when we structure this app, the way that I structured it was to use the app shell plus dynamic content model. And that means that I'm going to take all of the HTML, the CSS, the JavaScript, the stuff that doesn't change, right? The stuff that's required for my app to run, and I'm going to cache that and load that directly from the cache every time. And that means that I take the network out of the picture. I don't have to worry about, oh, hey, what's the network like? I don't have to worry about anything that. For the data, I'm going to use a set of runtime caching strategies so that when I go to ask for something, I'm going to get it, and then I'm going to store it so that if I need it later, I can get it from here. But if I need something else, I'll go get it from somewhere else. I'm using in this tool, in this project, a tool called SW Precache. SW Precache is a precursor to Workbox, but both of them have a set of predefined strategies, or they're a library with a set of predefined strategies that are going to help me write my service worker code and really easily be able to go and do a lot of the things that I don't want to write a lot of code to go do these things. So this is a great tool, definitely worth checking out. So the first thing that I need to do in order to get my tool to work is import SW Precache into my Gulp build script. And then I need to add a new task that's going to generate the service worker for me. You can see there what I've gone and done is I've said, hey, I want to statically cache these things. And then below that, where you can't see, I'm saying, hey, I want to dynamically cache the rest of the content. And then in my HTML, I need to register the service worker so that it's there and works for all of the pages. All right, so now that we have the service worker in place, let's run Lighthouse and see what goes on. We've seen this a few times, so I'm going to skip the watching of a demo. But another bump. All right? By adding a service worker to pre-cache our content, our progressive web app score has gone up by almost 20 points now. All right, from 45 to 64, and we had a 5-point bump on our performance score. That's really good. You know, we went from 91 to 96. That makes me a happy camper. We've improved the reliability of our app by adding that service worker. It's now going to work and respond when the network is slow, when the network's not working. Maybe if you were here yesterday and the network was kind of... so good improved experience. It's also helped to improve our perceptual speed index and dropped it down to about 1300, so just above our ideal number. One quick tip, after you've added a service worker, I always recommend that you go into the network panel and take a peek there and have a look at that size column, just to make sure that the service worker is handling all of the requests that you expect. This looks good, and here's my favorite bit, those super fast response times. Everything is essentially under 30 or so milliseconds. So it means that all of my pages are getting served up really fast. While we're in DevTools, I also want to point out another really good, important panel, and this is the application panel. This is the central place where you want to spend all of your time for debugging and understanding service workers. In here, I can see that my service worker is running and without errors. One little tip I'll mention, I usually keep this open. If I change my service worker and refresh the page, before I refresh the page, I look at that number. You can see number 46 activated. When I refresh the page, I expect to see that number increment. So I want to see 47, 48, 49. From there, I can also force it to update. I can simulate a sync event or a push event. I can unregister and get rid of it. Or I can use a bunch of these checkboxes to improve some of my debugging experiences. The offline checkbox lets me simulate an offline network failure, right? So it's going to be, hey, nope, network doesn't exist, so I can see how that behavior exists. Update on reload is really neat. What it does is when this is checked, if you hit reload on the page, instead of doing a normal reload, first thing it does is it goes and refreshes the service worker. So it goes and reloads the service worker. Then, once the service worker has been reloaded and the new one's been installed, it reloads the page. So it means that you're always running with the latest service worker right away. And then finally, bypass for network is super useful if you're trying to figure out why your service worker or why you're getting the old content. Essentially what it does is it skips the service worker's fetch handler and goes straight to the network to try and get that request. All right. So finally, let's add the missing application metadata. These are the options that we need to control how our app appears on the phone or on the user's desktop when it's added to the mobile screen. The first thing I need to do is add a manifest. And this is one of those things that tells the browser, hey, here's the name when you add it to the home screen, here are the icons, all of that kind of thing. But I also want this to work on iOS in Safari too. So I also need to add a set of metadata attributes or tags to the page because I want to make sure that this works really well. So let's take a look at the manifest and what I've had to do there. The first thing I did was add an icon. I added just a single 512 by 512 pixel icon. And the reason I added only one icon, I'm not a designer, and I don't care if my icon, when it gets resized, is not pixel perfect. Some of you in the room are probably wanting to just come up and hit me right now because you want it to look pixel perfect. If you want to do that, that's awesome. You just need to specify that in your manifest. You can see the manifest that I've got where I've specified a full name of the app, the short name, I've got the different icons, the URL that it should start at, background color, theme color, and all that kind of stuff. So I've got that. And then finally, the last thing that I need to do is add the link tags for the icons so that Safari has something when it goes to try and use those. Chrome also uses these when you think of your tabs in your top bar. So I want to add those icons. And I also want to add the Apple Mobile Web App Capable Yes. I love that line. It's so long, I can never remember it. I have to copy and paste it every time. So I add those two. And then the other thing I want to do is add a link tag to my manifest and set the meta theme colors. So that makes sure I've got all that. So with those added, let's have a look at how it looks in Safari on iOS. So I recorded this on the emulator. So go click Add, so it gets added to my home screen. There it is on the home screen. And it loads full screen. Looks pretty much like I expect it to look. So this is pretty good. It looks mostly like a native app. It won't work offline because Safari doesn't yet support service workers, but they have said they're going to, and it's coming. So sweet, good. Now that we have the service worker, let's take a look at Lighthouse and see how it looks. So we'll skip the video. All right, with those changes, we're at 91 for our progressive web app, 96. I'm above 90 everywhere. I'm a happy camper. The only outstanding issue is that I don't have a redirect from HTTP to HTTPS. I'm running on localhost. I can deal with that. Our performance still looks great. Time to interactive is under 3 seconds. Our first meaningful paint is at a second. Accessibility stuff, that hasn't changed. But we're down to one thing that we need to change in our best practices. We're not using HTTP2, which is fine. We're running on localhost. I also want to point out in DevTools, you can see the manifest here. And one little pro tip that I always recommend to folks, once you've added the manifest, just take a look and make sure that all of the icons are showing up properly. There have been a couple of times where I've gone and done this, and I've typoed the icon name, and I get one icon that doesn't work. So just take a peek at that. You can see in here your service worker that it's up and running, and you can dive in and see what's been cached by the service worker. So you can go in and just make sure everything's been cached properly. Now, there's one little bug I want to tell you about, because this has had me hitting my head against my desk several times. We do code labs with progressive web apps, and this gets everybody. There is a bug in Chrome right now. I think it gets fixed in 63, which should come out early next week. But that little icon in that is not live. So what you just have to do is go right-click on that, click refresh, and then you should be able to see. So if you do go in and you're like, why is it not showing anything? Just refresh it, and you'll be able to see what goes on, making sure that you've got all of the right stuff. I think it gets fixed in 63. Fingers crossed. If it doesn't, tweet it at the Chromium DevTools team on Twitter and be like, when's this getting fixed? Because the more people who yell at them about it, the better. All right. So as developers, I've shown you sort of how you can do this. Sit down with DevTools, run the audit on your existing app, and find out how it works. How does it score? And what can you do? Where can you spend a little bit of time to increase those scores? You can't necessarily always do it overnight. But if you start working through and say, hey, I want to get this up, I want to get this, I want to go add this, you'll get a better experience. The goal is not to necessarily, I always get in a little trouble for this, but progressive web apps are a great marketing buzzword. Really what they are is building a beautiful, amazing user experience that's fast, that's integrated, that's reliable, and that's engaging. And that's what we want to make for our users, is experiences that they love so they keep coming back and buying stuff on our site or using our service or doing whatever. We want to make sure that they've got that great experience. So using something like Lighthouse to help get you there is a great tool. I've got a few links here with some more details. You can go grab the code for this. for both the iFixit sample and for Lighthouse. Lighthouse is a great open source project. So if you have ideas for other audits, you can go to the tools and check those out, or go to their GitHub repo, see those, and suggest things there or add comments. With that, I will say thank you very much. I'm going to go over to the Lighthouse booth and hang out there. At the Lighthouse booth, you can run your tests through Lighthouse and see how it goes. Hopefully the network's a little better. With that, thanks everybody.
I'm Yasmin Evian, and I'm a design advocate at Google. And I'm here in India to meet with Ola Cabs to talk about the unique challenges they face. So tell me, what is Ola? Like, what does Ola do?
So Ola is India's largest ride-sharing company. And I always say that Ola's product is not our apps, our product is Cab Ride. For many people, we are their only, transportation option to get to their workplace, and that's my product.
With smartphone penetration outpacing traditional desktop devices, India has quickly become a mobile-first nation. We need to ask ourselves, how might we design for the next billion users while being mindful for the unique challenges mobile-first nations face? We have a responsibility to create things that are focused on the human experience, things that are centered.
Hi, everyone. Thank you for taking your time for our session, Android meets TensorFlow. I'm Kaz. I'm developer advocate for Google Cloud team. And for the first part of this session, I'd like to talk to you about how you need machine learning, the power of machine learning, running on your mobile phone applications. And in the latter part, Anita will talk to you more detail about the TensorFlow Lite, which is the lightweighted version, specifically designed for the mobile and embedded systems. So these are the agenda. Why ML matters, what is TensorFlow, blah, blah, blah. Why ML matters for mobile applications or mobile developers. And this is the slide I have used already in the keynote, I think, to tell the difference between AI and machine learning and neural networks. So I won't go through, repeat the same things. But the thing is that neural network is having the booming or the breakthrough of the algorithms, so that at around 2012, we have been seeing a breakthrough at around in the area of neural networks. And we are spending much resources and times on developing a new neural network technology. And yeah, this is the same slide I have used. So you can think neural network as a function, just like the function as you write in the Java code. So it takes any kind of data, and it gives you an output. So you can replace these cat and dog images with your own data acquired from the mobile phone. For example, if you have mobile phone, you have the acceleration sensors. You can try use the acceleration sensors as an input for the neural networks and try using neural networks to classify what kind of the movement you are sensing with those sensors on mobile phones. That could be one use cases of neural network on mobile. And we have been using the neural network, especially deep learning technology, for over 100 production projects. Not only the traditional classic machine learning algorithms, but also the deep neural network model has been already on production in many places at Google. Especially for the mobile use cases, such as the image analytics, or the OCR, or speech-to-text, text-to-speech, translation, natural language processing, motion detection, the machine learning, the power of machine learning could be so important because it matters to lessen the traffic and to get a faster response with mobile applications. So you can think the machine learning could be one kind of the compressor or encoder for your raw data. For example, if you're taking images or photos with your camera, the easiest way or naive implementation could be just sending all the images to the servers. And at servers, you can apply neural networks for image recognition or further analysis. But if you could have running your neural network model inside your smartphones, you can understand the meaning of its images, what kind of object you are having in the images of camera. For example, if you have the cat in a camera images, instead of sending all the JPEG images or compressed images to the server, you can just send a text label such as cat, C-A-T, to the server. So that can compress the amount of the traffic you have to send to this server significantly, like 100 times or 1,000 times the faster and smaller than the original image data. And you can apply the same techniques to any other kind of the data. For example, if you have a motion sensor data from mobile phone, rather than sending the low motion sensor data directly to the server, you can run small machine learning model running on the mobile phone to extract a certain feature vector that represents the patterns or characteristic of the motions, so that you can compress the data much, much smaller. So end result is that you can get less traffic and faster response on mobile applications. And to do that, to implement the machine learning or AI-powered applications running on mobile phones, the maybe easiest and the fastest way is to use TensorFlow, which is the open source library for machine learning. As I mentioned in the keynote session yesterday, TensorFlow is Google's standard framework for building our new machine learning or AI-based products. So this is a standard framework for machine learning in Google and created by Google Brain team. And we have open sourced it in TensorFlow.org in 2015. TensorFlow is scalable and portable, so you can get started with downloading TensorFlow code on your laptop, Mac or Windows, and try out with some sample code. And then you can move to the production level use cases by using GPU or 10 GPU or 100 GPUs. TensorFlow is scalable so that you don't have to change a major part of the TensorFlow code to run the distributed training on the large amount of data, such as terabytes of data. And another benefit you could get with TensorFlow is the portability. So after training the TensorFlow model, you can bring the model, which consists of tens of megabytes of data, that could be ported to the mobile phones or embedded systems, Android, iOS, or Raspberry Pi. So even the mobile phone or Raspberry Pi doesn't have any internet connection or cloud connection, it can learn TensorFlow model inside it to do smart decisions or make a prediction or inference on data. So TensorFlow with those benefits got popularity. It's the most popular deep learning framework in the world right now. And we have many serious companies like Airbus, Qualcomm, Movidius. Movidius is a subsidiary of Intel who's now focusing on building an ASIC or customized chips running for TensorFlow, or Dropbox, EBS. Those companies are actually using TensorFlow. But if you want to bring the technology into your mobile applications, there are some challenges you have to face. Because neural network is big compared with the other classic machine learning models. Because with deep learning, you have to have multiple layers, like tens of layers between input data and the output result, so that the total amount of the parameters and the amount of the calculation you have to do can be big. For example, the Inception version 3, which is one of the popular image classification model, that requires to have the 91 megabyte of the parameters, weights, and biases. And also, if you use TensorFlow without any changes, by default, it consumes 12 megabytes as a binary code. So if you want to bring your mobile applications in productions, you don't want to have users downloading 100 megabytes of the weights and binaries when they are starting to use your applications. You may want to compress everything into 20 megabytes or 10 megabytes or maybe a few megabytes. So we have to think about the optimization for mobile applications. Things like freezing graph, quantization, memory mapping, and selective registration. Freezing graph means that you can remove all the variables from the TensorFlow graph, convert it into the constants. With TensorFlow, usually people have the weights and biases, so the parameters inside neural networks as variables, because you want to train the model. You want to train the neural network with training data. But once you have finished training, you don't have to have those parameters in variable. You can put everything into constant. So that by converting from variables to constants, you can get much faster learning time, removing the checkpoints. Quantization is another optimization you can take for the mobile applications. Quantization means that, I think there's no other slide. OK, yes, I have to use this. Quantization means that you can compress the precision of each values in parameters, weights, and biases into a small, fewer precisions. For example, by default, we use the 32-bit floating point numbers for representing any weights and biases. But by using quantization, you can compress that into an 8-bit integer. And by using 8-bit integer, it must be, you can shrink the size of the parameters much, much smaller. And especially for the embedded systems or mobile systems, it's important to use the integer numbers rather than the floating point numbers to do all the calculations such as multiplications and additions between matrices and vectors. Because hardware for floating point requires much larger footprint for implementation. So TensorFlow already provides the primitive data types for supporting quantization of parameters and operations, quantizing and dequantizing or operations that support the quantized values. So with that, I'd like to pass the stage to Anissa. She'll be talking much more about the TensorFlow Lite, which is the new runtime we will have for specially designed for the mobile applications.
So hello, everybody. We now understand that machine learning adds great power to your mobile application. So with great power comes great responsibility. So armed with this power, let's talk in detail about TensorFlow Lite and see what it takes to build an app using TensorFlow Lite. So you probably heard this many times, and now you already know that TensorFlow Lite is a lightweight machine learning library for mobile and embedded devices. TensorFlow works well on large devices, and TensorFlow Lite works really well on small devices, which is we built this so that it's easier and faster and smaller to work on mobile devices. Some of you who attended the Code Labs earlier might be wondering, what is TensorFlow Mobile and what is TensorFlow Lite? You should view TensorFlow Lite as an evolution of TensorFlow Mobile. TensorFlow Lite is like the next generation, and this is catered to be really small in size and apt for smaller devices. So we support some, you'll hear more about this in detail. So how did we go about developing TensorFlow Lite? We spoke to the Mobile Vision team, found out what their needs are to build a really strong infrastructure. We talked to our partners in Android to understand how we can leverage custom hardware acceleration. And most importantly, we listened to you guys and took feedback from our developer community to see what should be prioritized and how we build something really well for mobile. And we've tried to incorporate a lot of the feedback from all of you. So we came up with 3 goals. We wanted to have a very small memory and binary size. So even without selective registration, we wanted to keep the binary size small. And we wanted to make sure that the overhead latency is also really small. You really can't wait 30 seconds for an inference to happen by the time the model is downloaded and processed. And quantization is a first-class citizen. We support quantization, and many of the models are quantized models. So these were the 3 main goals for TensorFlow Lite. This is the high-level architecture. As you can see, it's a simplified architecture and works both for Android and for iOS. This talk will be focusing mostly on Android today. So this is lightweight, performs better, and leverages hardware acceleration if available. So to better understand how to write a model, let's consider how we build a model using TensorFlow Lite. So there are 2 aspects. One is the workstation side, and the other one is the mobile side. And let's walk through the complete life cycle. So the first step is to decide what model you want to use. So if you want to use an already pre-trained model, then you can skip this step because you've already done the model generation. One option is to use a pre-trained model. The other option would be to retrain just the last layers, like you did in the Code Lab earlier today. Or you can write your own custom model and train and generate a graph. This is nothing specific to TensorFlow Lite. This is as good as standard TensorFlow, where you build a model and generate graph defs and checkpoints. The next step, this step is specific to TensorFlow Lite, is to convert the generated model into a format that TensorFlow Lite understands. A prerequisite to converting it is to freeze the graph. Kaz just talked about freezing the graph. So checkpoints has the weights, the graph def has the variables and tensors. Freezing the graph is a step where you combine these 2 results and feed it to your converter. The converter is provided as part of the TensorFlow Lite software, and you can use this to convert your model into the format that we need. Once this step is completed, the conversion step is completed, you will have with you what is called as a .lite file, .lite binary file. So now you have a means to move the model to the mobile side. You feed this TensorFlow Lite model into the interpreter. The interpreter executes the model using a set of operators, and it supports selective operator loading. And without these operators, it's only about 70 kilobytes. And with all the operators, it's about 300 kilobytes. So you can see how small the binary size is. This is a significant reduction from what TensorFlow is, which is over 1 megabyte at this point. So you can also implement custom kernels using the APIs that we have provided, and we'll talk about it in a few minutes. So if the interpreter is running a CPU, then this can be executed directly on the CPU. Otherwise, if there are hardware acceleration, then it can be executed on the hardware, accelerated hardware as well. So the main components of TensorFlow Lite are the model file format, the interpreter for processing the graph, a set of kernels to work where the interpreter can invoke a set of kernels, and lastly, an interface to the hardware acceleration layer. So the model, as I've said before, the TensorFlow Lite has a special model file format, and this is lightweight and has very few dependencies. And most graph calculations are done using 32-bit floats, but neural networks are trained to be robust for noise, and this allows us to explore lower precision numerics. The advantages of lower precision numerics is lower memory, faster computation, and this is vital for mobile and embedded devices. This, using lower precision, can result in some amount of accuracy loss. So depending on the application you want to develop, you can overcome this and use quantization loss during training so you can get better accuracy. So quantization is supported as a first-class citizen in TensorFlow Lite. And we also have a flat buffer-based system, so we can have speed of execution. Flat buffers. So flat buffer is an open source Google project, and it's comparable to protocol buffers, but much faster to use. It's much more memory efficient. And in the past, when we developed applications, we always thought about optimizing for CPU instructions. But now CPUs have moved far ahead in the memory, and writing something efficient for memory is more important today. So this is flat buffers is a cross-platform serialization library. And it is similar to protobufs, but it is designed to be more efficient. You don't need to, you can access the data without unpacking, and there is no need for secondary representation before you access the data. So this is aimed for speed and efficiency, and it is strongly typed so you can find errors at compile time. The next component of TensorFlow Lite is the interpreter. It is engineered to work with low overhead and on very small devices. And we have very few dependencies, and it is easy to build on simple devices. Like I've said before, we've kept the binary size to about 70 kilobytes and 300 kilobytes with operators. So it uses flat buffers, so it can load really fast. And the speed comes at the cost of flexibility. TensorFlow Lite supports only a subset of operators that TensorFlow has. So if you are building a mobile application, and if the operators are supported by TensorFlow Lite, then the recommendation is to use TensorFlow Lite. But if you're building a mobile application that is not supported by TensorFlow Lite yet, then you should use TensorFlow Mobile. But going forward, we are going to be using TensorFlow Lite as the main standard. Ops and kernels, let's talk about that. It has support for operators and used in some common inference models. The set of operators are smaller, like I said, and so not every model will be supported. In particular, we provide a set of core built-in ops, and these have been optimized for ARM CPU using Neon, and they work in both float and quantized UINTs. These have been used by first-party Google apps, and so they have been battle-tested. And we have hand optimized for many common patterns, and we've fused many operations to reduce the memory bandwidth. So it helps if there are ops that are unsupported, we also provide a C API, so you could use custom operators, and you can write your own operators for this. Finally, interface to target custom hardware is the Neural Network API. TensorFlow Lite comes preloaded with hooks for Neural Network API. If you have an Android release that supports NN API, then TensorFlow Lite will delegate these operators into NN API. And if you have an Android release that does not support NN API, then it's executed directly on the CPU. So neural network APIs are supported for Android with the 8.1 release in Oreo, which we just announced beta a couple of days back. So it will support various hardware acceleration you can get from vendors for GPUs, for DSPs, and CPUs. And it uses TensorFlow as a core technology. So for now, you can keep using TensorFlow to write your mobile app, and your app will get the benefits of hardware acceleration through Neural Network API. It basically abstracts the hardware layer for ML inference. For example, if a device has DSP, it can transparently map to it. And it uses neural network primitives that are very similar to TensorFlow Lite's. So its architecture for neural network APIs looks like this. Essentially, there's an Android app on top. Typically, there is no need for the Android app to access the neural network API directly. It will be accessing it through the machine learning interface, which is the TensorFlow Lite interpreter. The NN runtime, the neural network runtime, can talk to the hardware abstraction layer, and then which talks to the device and runs various accelerators. If, like I said before, if nothing is available, then we run it on the CPU. So how do you use TensorFlow Lite? This is the same high-level diagram we showed earlier, and let's just walk through high-level code on what needs to be done to make your model work with TensorFlow Lite. So the first step is generating a model. This is standard TensorFlow code. Nothing has changed. If you've written a model using TensorFlow, use the same thing. Write a model that's generated using TensorFlow. The next step we said is to convert the model into TF Lite format. So this is the simple code. You call a convert function to actually convert the buffer to a flat buffer format. The converter can be used in command line after the model is generated, but it is a convenient practice to put it in your Python script so you can find errors earlier if the model cannot be converted for some reason. So again, some operations are not supported. So earlier you convert, ahead of time, instead of you running training for days together and then figuring out that the model is not supported by TensorFlow Lite. So adding it to your code is a good practice. The output of this is a binary binary stream. So you can just write it into a file and get a binary file format. So once you have in your app, this is the app Gradle file that you write. You say uncompress because you don't want to add an extra latency if you have compressed your file, to decompress it and then access it. The repositories is the Maven repository saying where TensorFlow is available. And the dependencies for your app will be TensorFlow Lite, which will be linked to the app. So we've provided with TensorFlow Lite the demo application as well as an AAR on Maven. You can download and integrate it into your app and see how you can use it. So now once we've done this, we are now ready to use the model on the device. So we provide both C++ and Java APIs. For this talk, I've just added Java here, but you can go look up documentation on GitHub to see the C++ APIs as well. So you initialize the interpreter with a model file and then run model inference. And if you have custom ops, we provide 4 functions for custom ops. One to initialize the op, to uninitialize the op, to prepare the op by giving inputs, and then finally to invoke the kernel. You can refer to the GitHub documentation if you want to see more details. So we released TensorFlow Lite 2 weeks back. And as part of TensorFlow Lite, we provided C++ APIs, a converter, a set of built-in apps, the demo app. And also we've supported MobileNet, both float and quantized versions, Inception v3 for float version, and also the Smart Reply text model. That's also open sourced. So be sure to go check out. And I have added links here. Please feel free to go refer to this documentation for TensorFlow Lite, and also download the code from contrib under the TensorFlow master GitHub repository. So this is how the sample app has just given you some screenshots from the sample demo app. You can download the app and test it for yourself. And as you can see, it's identified the objects in the top 3 choices with a pretty high accuracy rate. So some stats, I've already told you that the interpreter without operators is about 70 kilobytes. This is actually 15 times smaller than TensorFlow. So that's why we say it's very suitable for mobile and embedded devices. And it is also 4 times faster to load. So between quantization and float, quantized models are 4x smaller, and they're also 50% faster to load on your device. So future work, we want to improve and add additional tooling and make it more user-friendly. Like I said, we support only a subset of ops. If you want to see what are the subset of ops we support, it's available on GitHub. I can tell you the path later on under the TensorFlow Lite documentation. And we want to extend this ops, but we still want to keep true to our goals by adding selective registration and other mechanisms to ensure that the binary size does not increase. We want to target smaller devices, not just Android and iOS devices, but also Raspberry Pi and other smaller devices. And eventually, maybe even do on-device training. Currently, we do on-device inference, but eventually, we want to do on-device training as well. So that's about it. Thank you very much, and go check out the TensorFlow Lite code.
So I'd like to wrap up this session by showing the actual use cases of the TensorFlow application running on mobile. I'd like to introduce a very interesting application. This is actually a production application for last 1 year called Gymnastic Exercise Scorer, made by a Japanese application vendor called, what was the name? Kurusugawa Densan, yeah, what's the name? This is available for both Android and iPhone. And actually, I have to explain what is the background. In Japan, somehow, everybody, like millions of people, do the morning exercise, gymnastic exercise, by listening to the music on the radio. So it's very common to do the morning exercises for millions of people in Japan every day. And this application measures the movement of your exercise, the arms and everything, to score how well you have been doing the exercise. And to implement these applications, they have built their own TensorFlow compiler. This is comparable to TensorFlow Lite, which we are now developing. But because this vendor has a very talented expertise on the TensorFlow, so they were able to build their own TensorFlow compiler, just like TensorFlow Lite. That shrinks the model from the tens of megabytes into a few megabytes, like 2 or 3 megabytes, so that they were able to put the whole TensorFlow model running inside these small Android applications. This compiler does many of the optimization techniques I have mentioned, like the freezing, or the quantization, or the removing all the unnecessary binary files, everything. So let's take a look at the actual
live demonstration of the exercise scorer. So can I switch to the So this is the applications where you can choose the various kinds of the exercises, and I'll be playing the most standard one. So this is the music.
It's weird. I did this in Rust.io in the United States. It was so embarrassing. And I'm holding a smartphone.
So just like that. So let's stop. Oh. It's enough. It's enough. So now the TensorFlow model is trying to evaluate how well you have done with the exercise. And you can see the bar chart here. That is the evaluation by the TensorFlow model inside these applications. It's a real thing. Okay? So go back to the slide.
Yeah, you saw the score. Yeah. The score was actually measured by the TensorFlow model running inside the mobile phone applications. And so the technology is now available, and you can do the same thing with TensorFlow Lite when it's available. So I hope maybe this year and next year we'll be seeing more and more Android and iOS applications that runs the real deep learning model running inside it to solve the real world problems. So that's it. Thank you so much.
I'm Yasmin Evian, and I'm a design advocate at Google. And I'm here in India to meet with Ola Cabs to talk about the unique challenges they face. So tell me, what is Ola? Like, what does Ola do?
So Ola is India's largest ride-sharing company, and I always say that Ola's product is not our apps. Our product is cab ride. For many people, we are their only, transportation option to get to their workplace, and that's my product.
With smartphone penetration outpacing traditional desktop devices, India has quickly become a mobile-first nation. We need to ask ourselves, how might we design for the next billion users while being mindful for the unique challenges mobile-first nations face? We have a responsibility to create things that are focused on the human experience, things that are centered.
All right. Welcome, everybody, to the Android Instant Apps session. My name is Lila, and I'm an Android developer advocate. This session will cover building an instant app, including core concepts, the modularization process, APK sizing, and important related APIs. Now, instant apps were announced at Google I/O 2016, but they became generally available at Google I/O 2017. And now, any of you could build an instant app. But first, let's talk a little bit about what instant apps are. Instant apps are native Android apps that require no installation. But instead of me waving my hands around and using a lot of words, let's just take a look at what that looks like. Sorry. OK, so here I am doing a search for the show on Red Bull TV called The Crevasse. I click on a link for the instant app, and I'm immediately taken into an immersive native app experience. This works from any URL that you own, whether it's from a Google search, as in this example, or from a text message from a friend. Now, instant apps work on Lollipop and Higher. So in fact, if you have a phone running L or Higher, you could take it out, search for New York Times crossword, and go ahead and click on that card that has the instant app, and you can see the experience yourself. Instant apps are supported on over 900 million devices. In addition, many of our early access partners created instant apps, and they've already seen increases in session duration and engagement from their instant apps. OK, so I'm going to go ahead and take a dive into how you would actually set up your app to be ready for instant apps. Now, the whole point of instant apps is to decrease friction for users. we want it to be so that you click on the link and you get into this native app experience. So you don't want to be showing them some sort of log permissions dialog when they do this. Instant apps require runtime permissions to show contextually relevant permissions during runtime. In addition, for instant apps, you're obviously going to be mapping URLs to different activities in your apps. And this is exactly what app links do. So we use app link functionality to enable this on instant apps, so you need to support app links. Notably, app links also allow you to get rid of that disambiguation dialog that you'll sometimes see when clicking on a URL. So app links require basically two things to get working. First, you need to make intent filters in your manifest file that associate those activities with the URLs. Second, you're going to need to generate a digital asset link JSON file that you upload to verify that you actually own your server. Now, there is an app links assistance tool in Android Studio that will get you started with both of these. It both generates the XML intent filters that you need, and it will also generate for you that digital asset link JSON file. Now, both app links and runtime permissions are for API level 23 and above. But as I said before, instant apps work on API level 21 and higher phones. So to achieve this, there's actually a runtime that's managing your instant apps. And the instant runtime backports both of these functionalities for L and higher apps. So if you actually want to see that runtime running on your phone, it's called the Google Play Services for Instant App Runtime, and you can see it running on your phone as shown here. So runtime permissions and app links are the two major technologies that your apps will need to be able to support before you can start building instant apps. But in addition, there's also a smaller checklist, there's a checklist of sort of smaller preparations that you need to make. So for example, of some of these things on the checklist, you need, instant apps have a subset of available permissions, and they also require web requests to be made over HTTPS. There's a couple of other restrictions and requirements that you should look over. I'm not going to list those out now, but we have awesome instant app documentation, so you can go to the site and kind of get that full checklist for yourself. OK, so now let's actually, so we've made our app sort of ready to become an instant app. So now I want to talk about how instant apps are actually structured. So one of the central goals when making an instant app is that you want to make sure when you click on that link that you're getting to your app fast and that it's not dragging out a really long time. Now, you're probably used to having a single module for your app, probably called app, which contains all of your code and resources. But within your code, you probably have separate features. So for this example, I'm going to be taking you through a fictional travel app called Banjara. And Banjara uses your location to give you a list of nearby attractions. So for example, in this app, you can view specific details about an attraction, get a map to go to where that attraction is. You can also write reviews if you happen to be a fan of that attraction. So each of these 3 different activity flows can be thought of as a separate feature. Features are discrete experiences where the user accomplishes some sort of meaningful task. For instant apps, a feature must be associated with an activity or activities. Banjara has essentially 3 features. Okay? The first one is browsing a list of nearby attractions. The second is posting a review about an attraction. And the third is getting that detailed information about one attraction. So a user could use any one of these features independently, and they'd still be able to do something interesting and useful for them. OK, so features probably don't have completely separated code. Most likely, they will share some code. So for example, you probably want your activities to have the same colors and logos and not to be switching those things up. So they'll probably share common styles and graphics. Similarly, you'll probably have some shared utility classes, such as a class to set up dependency injection. And finally, there are probably some common libraries, like the support library or maybe architecture components, that you're going to be using in all of your features. So for all of this shared code, I'm going to be calling this code base, and that's going to become very clear why I'm doing that soon. OK, so here it is all mapped out. We have our single module, but remember, inside our module, we have these sort of different sections of code for the different features of the base feature. So one of the core principles behind instant apps is this. If your users only need to use one feature, why are you wasting their time and their data downloading all of the features? Another way to think about instant apps is the user clicks on a link and they download only the compiled code and resources for the single feature that they need at that moment. So if your friend wants to send you the details of an attraction, you could click on a link, and via instant apps, you would only download the Banjara details feature. And you wouldn't have to download the feature where you're searching for attractions or the feature for where you're writing a review. And you can do all of this without having to fork your app's code. So you're not going to create an extra little mini app on the side. One of the other core principles is that instant apps build from the same code base. So you're going to use your same code base for building both your instant app and your installable app. Now, this, of course, makes maintenance easier because you don't need to maintain a completely separate code base. But it also ensures that your instant app feels the same as your installable app, which is very important because it essentially is the same app. So what you'll do instead of forking your app is to take your single app module, and you're going to separate out your code into different modules, one for each feature. And you will very cleverly call these modules feature modules. OK, and then you're also going to take that base code that I talked about before, and you'll separate it out into another module called the base feature module. Now, you're going to make 2 additional modules on top of that, and they're both for building the app. So one of those modules is going to be called your installable app module, and it's meant for building the installable app. And the other module will be an instant app module, and it's meant for building the instant app. So essentially, we're going to take our one app module world, and now we're going to break it up into 6 different modules. OK, so now to properly configure all of this and build your instant app, you're going to need to learn about some new Gradle plugin types. So here are our modules again. Now, each of these modules has its own Gradle file. And each of these modules will be using a slightly different Gradle plugin. The installable app uses the application plugin, and the instant app module uses the instant app plugin. Now, the application plugin should be pretty familiar to you. It's that standard plugin that you're using to build your APK. The purpose of this module is to create the APK for your installable app. Its Gradle file will also identify the app ID. It can include code that is specific to your installable app. For example, you might have some sort of offline mode feature that doesn't make sense in the instant app context. But you can also have it be empty and have its purpose just be for building your installable app. And because it's building your installable app, it also needs dependencies on all of the other feature modules. OK, so in comparison, the new instant app plugin creates an instant app. And basically, it contains nothing. It doesn't contain any code, it doesn't contain any resources, and it has a blank manifest. But it does depend on any of the features that you want to include as part of that instant app experience. The feature modules use a different plugin called the feature plugin, which is new. OK, so the feature plugin is what makes instant apps possible, and it's pretty cool. The feature plugin will compile differently based on what's building it. So if you're building a feature from your installable app, it'll compile as if it is an Android library. But if instead you compile from an instant app, it's going to compile as if it's a separate sort of mini APK. And of course, your feature module will contain code specific to that feature. OK, so the base feature module is a little bit different than the other feature modules. It uses the same feature plugin, but there's a flag inside of it, which identifies that it is a base feature module. Now, importantly, you can only have exactly one base feature module per instant app. And again, it's not really a feature. It's this location where you have shared resources, code, and libraries. All of your other features have to depend on it because it has all those shared code, resources, and libraries that they want. And importantly, it propagates the app ID back out to the instant app APKs. So in practice, what's actually going on when we both build the instant and installed app and then we put it up on the Play Store? So let's go ahead and look at what happens when we make an installable app module. When you build an installable app, this creates an APK similar to the APK that you're used to. Well, it's exactly the same as the APK that you're used to. And you go ahead and you just upload that to Google Play, and this is just completely normal. All of the features are included as libraries because, again, the feature plugin decided to do that. And they're included within the overall installable app. OK, so now the user goes to the Google Play Store, and they download your app. And they get that exact same APK on their device with all of the features that you've put in it. OK, so let's look at what the Instant App module does, which is a little bit different. OK, so now this looks similar. But you might notice that there's a couple of extra file extensions that snuck in there. So what the Instant App module is doing is it's not making a single APK. Instead, it's creating these separate MIDI APKs for each of your feature modules. And then it zips all those up into a single zip file. This zip file is what you upload to Google Play. Then the behavior on the user's device is this. When they click on an Instant App link for the first time, two things are downloaded. First is the feature APK that they're interested in using. And second is that base feature APK, which is going to come along with all of your different features. So if a friend tells you to check out a nearby attraction and sends you a link, you will only download the detail features APK and the base feature APK. And then let's say later that you want to write a review about that attraction. So you go to Google search and you click on the review functionality. So you already have the base feature APK, so that the only thing that's downloaded at that point is the review feature APK. So as you can see, your user is downloading only exactly what they need, and that's because you went ahead and you modularized your app. OK, so now I'm going to take a deeper dive into the code to create a simple single feature Instant App. So here's our end goal, which is a little bit complicated. And here's where we're starting, with a single module that has all of this different code inside of it. So a much easier intermediate goal is to start by just building those 2 additional modules that make your app. And then you can have all of your code in a single feature module. Now, this isn't doing that cool thing where it selectively downloads particular features yet, but it does allow you to get those 2 build processes working and then resolve any issues like implementing the correct permission structure. OK, so I'm going to black box all of this. And here's the same diagram. I'm just kind of hiding all of that internal code in the feature module there. OK, so again, all of these modules have Gradle files. And the Gradle files are how you set up the configuration and get everything to build properly. So let's go ahead and take a peek into the installable apps Gradle file. OK, so we use the application plugin. It'll contain the application ID, as I mentioned before. And it's going to depend on that one app feature module, because it needs that to make the APK. OK, so nothing too surprising there. Let's go ahead and take a look at what's going on in our Instant App module. OK, so this is basically the same as the installable app, but instead we're using that Instant App plugin. And you'll notice that there is no app ID. But we're still getting that same dependency to the feature, because we want that feature to be part of the Instant App. OK, so then finally, let's look at what's going on in our apps build.gradle file. This is the one feature that we're building right now. OK, so this is going to use that new feature plugin. And it has a special application dependency on the installable app. And the reason for this is so that it is able to go and get the app ID from the installable app. And that's pretty much why that's there. You'll also notice that we have this base feature configuration set to true. Remember how I said that all instant apps need exactly one base feature module? Well, in this simple version of the app, we only have one feature, and therefore it follows that this must be the base feature. OK, so with that, you have your first instant app running. And again, I'm going to call this a single feature instant app, because it only has one feature. And so if I did this for Banjara, I could see Banjara running as an instant app, which is pretty cool. But there's another reason to take this intermediate step, which I mentioned before, which is that it can help you flag libraries or permissions that might not be compatible with instant apps before you go through all the process of modularizing your code. But the real power does come in from that modularization process and splitting up your code into separate feature modules. So here's our end goal again. And here's where we are right now after we built those additional Gradle modules. So at this point, you're going to want to start modularizing. So where should you start first? Well, my suggestion is that you first identify what should be in that shared base feature module, and you separate it out. The base module will again contain all of the classes, resources, and libraries that the other features, the list, review, and detail, rely on. And once you've done this, you can start extracting other features one at a time and sort of testing how it's going as you go. Now, note that you don't need to have all of your features be part of the Instant app. So you could decide that you just want to extract the details feature and only include that as the Instant app. And the only difference would be that you would require an install as soon as they wanted to use the review feature or the list feature. But if you do keep extracting features, you'll eventually get to this point. So I want to talk about quickly a tool at Android Studio to help you with this process. And it's called the Refactor Modularize tool. To use this tool, basically what you do is you'll go ahead and you'll select the different classes and resources that you want to move into a different module. And then you'll right-click those, and you'll go to Refactor Modularize. This will move those classes and files over to a different module, but it's also going to tell you the dependencies that those classes have. So it'll tell you other dependencies on different classes and other dependencies on different resources, and it will give you the ability to selectively decide what you might want to also move over with it. OK, so now let's take a quick look at the Gradle files for this more complicated app. So I'm going to go look at just the base Gradle file there. OK, so here's our base feature Gradle file. It has the feature dependency. It still has the base feature set to true. OK, now notice that we have that application project dependency on the installable app module, and that's, again, to get the app ID. We also then have additional feature project dependencies on each of the different feature modules. And the point of that is simply you have that app ID, and now the base feature is responsible for propagating that app ID to each of those different feature projects. And this ensures that your entire app, your Instant app and your installable app, have the same application ID, which is pretty important when you upload to Play. OK, so let's take a look at what one of the more normal feature module Gradle files looks like. So notice that this does not contain that base feature configuration because it's not a base feature. Feature modules will also always depend on the base feature module, but they won't have any other dependencies on any of the other feature modules. You also can have specific library implementations for things that you need for only that feature in there as well. OK, so at this point, you have both your installable and your Instant app modules, which depend on all of your feature modules. And you have your feature modules, which all depend on your base module. And you have that one single base module, which has all of the shared code and resources that you need for your feature modules. And finally, that base module is responsible for propagating or for getting the app ID from the installable app and propagating it out to the rest of the app. And that's kind of what our full Instant app structure looks like. OK, so now it's my pleasure to introduce Anirudh Dilwani, who works on the partnerships team. And he's going to be chatting about managing module size and some additional Instant app capabilities. Thank you. There you go.
All right, let's talk about managing module sizes. Now, in development mode, when your device is connected to your development machine, there are no constraints on module size. It's great for first refactoring efforts and making sure your app is compatible with Instant App Sandbox. OK, understanding module size restrictions. So to be instant, your module needs to be lean. The max size for a module is 4 MB. And a module, by module, we mean a download module. We'll discuss that about later. So, but nevertheless, you should aim for less. You should aim for less to improve delivery speed and to improve user experience. OK, so the download, we said the total download bundle size should be less than 4 MB. That really means that the feature that you're trying to run or download, which has the activity being addressed by the URL, plus the base feature module should be less than 4 MB. The base describes your app to the system and has all the required common dependencies, and it's always downloaded unless it's already cached. So, and this is where refactoring into feature modules is really useful. Now, in this example, we have a base module with 3 MB in it. Now, this effectively leaves us 1 MB for each feature module. If we were to have 4 features in our app, we can have 7 MB of total app code. But there may be some cases where you want a little more room in your feature module. For example, a large SDK or a third-party library. A good example would this be a payment module. Suppose you have a big payments library. What you then want to do is you want to pull up the payments library from the base module to the feature module and create more room to add functionality. In this case, when we pull up, suppose, say, for example, a 1 megabyte library onto a feature module, our base is now 2 megabytes, and this gives us 2 megabytes in each of our feature modules. But the total download bundle size still needs to be less than 4 megabytes. So with Instant Apps, we introduced a new publishing track called the development track. This development track lets you build and perform end-to-end testing of your Instant Apps testing of your Instant Apps rapidly to match the velocity of development. This module size restriction for the development track is 10 megabytes. In addition to this, we also have the alpha, beta, and production tracks, where the module size limit is 4 megabytes. So here's a blog post that talks about the best practices for managing your download site for Instant App modules. Now let's discuss some tips and tricks for managing your module size. Use ProGuard to shrink your app. Use ProGuard to remove any unnecessary classes from your DEX files that are not being used. So you should start with your installable app first, and then use ProGuard on your feature modules. Use the APK Analyzer tool to investigate your resources, code, and assets. Start optimizing with the biggest chunk, which is usually the resources in your app. Use the unused resources link check to see a list of resources that are not being utilized in your app. Investigate and remove as needed. A couple more tips here. Use WebP to optimize your image assets. And also, starting support library version 26, you can use downloadable fonts. Okay. Quick look into the APK Analyzer. So the APK Analyzer understands your Instant App build artifacts and is able to show details for the constituent feature APKs. In the screenshot on your left, you can see we clicked on our Instant App build artifact from the build folder. This is a zip file. This will show us the feature APKs inside, and then you can drill down into the feature APK, into its specific code resources, and investigate the size. Okay, with Instant Apps, we also introduce configuration APKs. Configuration APKs are very similar to multi-APKs, but with one key difference. They do not have any code. They only carry configuration-specific resources. We support 3 dimensions currently, architecture, density, and languages. By using configuration APKs, you can bundle resources and libraries specific to your device configuration in smaller config APKs and only deliver the required APK to the device. This places your app's DEX code and device-agnostic resources in one APK, and then a set of device-independent native and resource in separate APKs. The Gradle configuration block for configuration APKs is there. You use the generate pure splits equal to true configuration, and then you specify the dimensions that you want to generate the config APKs for. On the right, you'll see a screenshot, again, from the APK Analyzer tool. You'll see a bunch of APKs generated. Apart from the base and detail feature APKs, there are a lot of configuration APKs there, carrying the resources for that specific configuration. And we only calculate the size of the largest config APK plus the base for each supported dimension. This can help you pack more code and functionality in your 4 megabyte download size limit. Okay. Now let's talk about some Instant App specific features and APIs. So we stress that the Instant App and the installable app should be the same app. However, there may be some cases where your installable app offers some functionality that's not possible with the Instant App. A good example of this would be offline video. And in those cases, you may want to prompt the users to install the app. So We made it easy for users to install your app when using your Instant App. This can be done by placing a button. So let's check the code for install button. By default, our button is hidden in the layout. Now on the top, you will see a dependency being added. That's the Instant App library that has the install APIs. Now what we do in the code is first, we check for Instant App context. So you want to unhide the button only when you're running as an Instant App. The API there is Instant App. You check if you're running an Instant App, and you unhide the install button. And then on click event, you use the install API instantapps.show install prompt to present a dialog that installs the app. Okay. Now, we covered how to install your app. But when doing that, you want to make sure the transition is seamless from the user as they move from the instant to installable app. It is also important to keep user context and migrate user-generated data over to the installed app. The Instant App SDK provides cookie API. Similar to a web cookie, it's useful for storing user context that you can retrieve later. So on Android 8.0 and above, you can directly use framework classes to invoke cookie API. For cookie API, the specific class is Package Manager. On Android 7.x and below, you use Package Manager Compat. So let's go over the flow for cookie API. When running as an Instant App, the first thing you do is you check whether your cookie fits the allowance. This is done by calling get Instant App cookie max size on Package Manager. Once you do that and your cookie is under the limits, you store the data in your Instant App. So you store the data using set Instant App cookie. At that point, the app is installed, and now you're in the installed state. And in the installed state, you retrieve the data back. You retrieve the cookie by calling get Instant App cookie. And then you have user context and restore where the user was in your installed app, on your Instant App, sorry. Also, recently, we added the ability to let user experience your Instant App from your Play Store listing. There is a Try Now button that launches your Instant App, and it's right next to the install app, removing any friction. For integration with Try Now and Launcher, we require apps to provide a consistent landing screen. This is the default or home experience for your app. You do this by adding a default URL attribute. In the XML block there, you see a metadata tag that says default URL is example.com/index.html. This is the home or default experience for your app. This activity should be URL addressable and support browsable category and intent filters. Okay. Finally, Instant Apps are all about removing friction. So we recommend you use Smart Lock for identity and Google Play Billing for any billing in your app. Right, some final thoughts to summarize. Think of your app as a set of features. Each feature lets user complete a task. Start with a single feature app to quickly prototype, and then start carving out features one at a time. Use the APK Analyzer, ProGuard, and other tools to make your modules leaner. Provide a consistent landing screen for your Instant Apps. And finally, make the transition seamless for users from instant to installed state using Cookie API. Further information here on Instant Apps, that's the developer homepage, t.co/instantApp, link to our samples and code labs. Couple of useful resources that can help you manage your module size, and finally some related talks on Instant Apps and modularization. All right, thank you everyone. We're very excited with the experiences you will build. Thank you.
Good afternoon, everyone. Welcome to kind of the second to last talk of GDD India. My name is Mike McDonald. I'm a product manager on the Firebase team, and I'm joined with two of my colleagues, Todd and Dan. And we're here to do a brief overview of how to build an app with Firebase. Let's start with the premise of this app. So many of you are probably multilingual, English and a number of other languages. I am actually terrible with languages. I speak English passably, and unfortunately, I travel quite a bit for work. And so that's, as you can imagine, probably pretty difficult, right? If I want to go to a restaurant and order something, I just kind of point at things on the menu, or maybe I use Google Translate and try and translate it. But it'd be really nice if I could actually talk to people and have them understand what I'm saying. This is a problem that science fiction, in particular, has been trying to solve for decades. Right? If you read a number of science fiction novels, if anyone has read, for instance, Hitchhiker's Guide to the Galaxy, there's a little device called the Babelfish where you can put in your ear, and immediately everything that everyone is saying is translated to your language, and everything that you're saying is translated to theirs. Science has actually gotten pretty close to that. So I saw a demo a couple years back of a peer-to-peer communications tool. And the demo was a bunch of kids in the United States talking to a bunch of kids in somewhere in South America, and the kids were speaking in English, and the kids in South America heard it Spanish, and vice versa. Some of you may actually be thinking, wait, hasn't Google already solved this problem? So the Pixel Buds, if you've seen those, came out a little while ago. Put the Pixel Bud in your ear, tap it, and it'll automatically translate to your language. But both of those took years, right? And we have 30 minutes to build an application. Let's see if we can do that much faster, using something that we all have today, right? We all have smartphones, so we're going to build an Android app and an iOS app where you can select the language that you speak and want to hear, and then we will do all of that translation automatically for you. So how are we going to do this, right? If you didn't come to this talk, you might start building something that looks like this. So this is kind of the traditional mobile application. You have your mobile app that talks via REST requests to some Python or Django or PHP server that then proxies requests out to your translation APIs or your databases or your file storage systems. Unfortunately, there are a lot of problems with this, right? So who is going to kind of manage and maintain those servers? Who's going to even get you the server in the first place? What about uploading files over really flaky networks, right? I'm sure we've already been having conference Wi-Fi issues. How are you going to make sure that those files are uploaded appropriately? What about authentication? What about performance and scalability, right? So if we take this app, give it to you guys, and then it goes viral, is everything going to scale? Is it going to keep working? Who knows? Luckily, everyone came to this talk. So you're going to learn about how Firebase solves all of those hard problems. Unlike the apps that we saw on the previous page, Firebase applications are not traditional applications. Firebase eliminates that middle tier server and lets your devices talk directly to our powerful managed cloud services. We handle things like client-side authentication and flaky networks, so there's no need to build resumable protocols or do your own OAuth flows. And Firebase scales automatically, so the app that you build for a prototype will scale to production the next week. Firebase's smart clients handle all of those hard problems, so you can focus on building applications that your users love. So in case you haven't been paying attention over the last 2 days, and you're like, what's Firebase? Firebase, very briefly, is Google's mobile platform. It provides tools that help you develop your applications on Google Cloud Platform, understand what your users are doing in those applications, and grow an engaged user base. But we can't build an app using all 19 of these features right now. I'm going to turn it over to Dan, who's going to pick and choose a few of these and show how we can build our app. Over to you, Dan.
Thanks, Mike.
So a core tenet of Firebase is that you can pick and choose the pieces that you need. So I'm not going to explain all those orange circles. I'm going to pick the 3 that we're going to need to build this app. The first one is a highly scalable object storage that lets you upload exabytes of user-generated content. We're going to couple this with Firebase Auth, which is a serverless authentication system to handle all those complex social flows and session management with ease. And the third one that I'm going to use is a NoSQL document-oriented database called Cloud Firestore that stores and syncs JSON-like data. So let's see how we can piece these three things together. Since we need to record audio and share it with other users, we need to store the file somewhere secure that's also accessible across multiple devices. Cloud storage is the right solution for that, and it comes with Firebase SDKs. It's easy to select a file on your device and upload it directly from anywhere. We have client-side SDKs in 5 languages: Android, iOS, JavaScript, Unity, and C++, so we can meet you where your app is. These SDKs are smart and handle poor mobile connections, pausing and resuming uploads to make sure your file is uploaded. Once that file is uploaded, you can download the content directly from any cloud storage bucket across Google's global network. The same robust support from the Firebase SDKs enables you to do this. So we've uploaded the audio file to the cloud. How do you know who is allowed to have access to it? And that's where Firebase Auth comes in. Firebase Auth lets you log in your users with the common social providers, or your own email and password system, or any provider using our custom authentication experience. Instead of spinning up servers to handle multi-legged OAuth flows, our simple client-side SDKs handle all the flows and securely authenticate your users. We've also recently introduced phone number support, so you can SMS your users to sign in. This feature is really popular in India and other emerging markets. Firebase also provides an open source, pre-built set of UI components, like the above, that give you access to a seamless sign-in experience right out of the box. It doesn't matter if your users are on Facebook, GitHub, or use email and password. We always create a user record with a single ID across all their accounts. Again, this happens entirely on the client side. No need to write your own OAuth integration. By using Firebase Auth, all your users are logged in order to upload files, no matter where they came from. So now we've been able to upload and download files securely. How do we go about synchronizing the file metadata and ensuring that other users get notified when there's a new translation? Luckily, Cloud Firestore has us covered here. Cloud Firestore is Google's newest database. It's a real-time, highly scalable, document-oriented database. We'll be storing data in several collections: an uploads collection, a transcriptions collection, and a translations collection. Uploads is going to hold a link to the file we uploaded to cloud storage. Transcriptions is going to handle the text representation of that file. And lastly, in translations, we're going to handle all the translations for that transcription. And we'll see how these all connect shortly. Unlike other databases, which are often request-response style, Cloud Firestore pushes changes to clients in real time. Simply attach a listener to a collection, and we'll notify you anytime data changes. Let's switch to code to see how these pieces help Mike build an app. So the app we're going to build has a login button. It has a spinner that lets us select the language we want to hear, a record button, and finally, a text field showing the translated text. On the developer side, we're given an audio file, and we expect a snippet of text that we can play out loud. We've already imported Firebase using CocoaPods and Gradle and configured Firebase within the app. The first thing we need to do is upload the file. We create a reference that points to the file and add associated metadata like content type. We take the local file and upload it. Then add listeners on success and failure. On failure, we'll print out an error message. On success, we'll write the file metadata into cloud storage. Cloud storage is secured by default, so you'll have to be authenticated to access it. Auth is critical to any app and is really hard to get right. Since Mike's a product manager and wants this app done yesterday, we're going to cheat a little bit and use an open source library we built called Firebase UI to implement the auth flows. The first thing we do is set Firebase UI up and configure it to use Google. We'll also add some business logic and check if the user is already logged in. If they aren't logged in, we'll launch that login flow. Otherwise, we'll listen for new translations. Now that we've uploaded files securely, we need to listen for changes when a new translation is available. Since we already wrote the metadata to the database after we uploaded it, we need to listen for new translations in our database. To do this, we'll create a reference to our database, add a document listener to get new translations. In the body of our listener, we'll fetch the specific language from the database. After that, we'll simply use the text-to-speech APIs on each device to play the translation. Let's try that out. So Mike and Todd are going to compile their applications.
Testing, 1, 2, 3. Well, it's not supposed to.
All right, so we're not hooked up on the back end right now. So we're actually going to have Mike do the translations for us.
See if the internet works.
Now, Mike isn't a very scalable backend. So what we're going to do in a moment is we're going to hook up the backend pieces that will do the translation. So we'll give Mike a chance to give us a manual translation.
Not getting it for some reason.
Oh, OK, live demos. But I heard machine learning is pretty hot these days. So let's see if there's anything Google Cloud can do that can keep Mike from becoming our backend. Todd, do you have any thoughts?
Definitely. So let's write some software to fill the gap. Mike wants a universal translator app, and right now we just have an app that parrots speech back to us. And let's do that in the trendiest way possible, by adding some machine learning. But designing and training our own models it takes a lot of time, and that's not what this talk is about. We want to get things up and running fast. So that's where pre-trained machine learning APIs come in. We can pick from a big menu of APIs that are available as part of Google Cloud Platform, and they're really cool and solve a bunch of problems, including two problems our app faces today. One of those problems is transcribing voice into text, and for that we're going to use the Cloud Speech API. And for translating one language into another, we're going to use the Cloud Translation API. So our problem's solved, right? Well, not totally. How are we going to use these really cool APIs and get them wired into our app? Traditionally, Firebase apps are serverless, so this means that there's no backend that you could bake it into, which is great. But as your app gets more and more complex, you're going to start facing challenges faced by a lot of app companies. One of those challenges is secrets. Users can learn a lot from the files that make up your app, be it pre-release code for your game or API keys like the ones that we're going to use for the cool APIs. Also, the resources on the phone, although the CPU itself is pretty fast these days, the battery life is only limited, and it can crunch only so many numbers or translate so many phrases. And finally, code sharing. One of the most painful things about being a mobile developer is having to implement the same functionality across multiple platforms. Our app faces all three of these challenges, and we can mitigate them by moving our secrets and the code-intensive functionality into the cloud. And since it's in the cloud, we'll only have to implement it once rather than for each platform. If we dipped into our old bag of tricks, we might solve it this way. Spin up some servers on Compute Engine, create APIs backed by Django or Node.js. But in the end of the day, that results in even more complexity. You'd have to deal with caches, microservices, and load balancers. And before you know it, we're back here with a lot of complexity, not where we intended to be. So instead, we're going to use Cloud Functions. It'll give us the minimal glue that we need to deal with our app's serverless challenges. But instead of showing you in a silly diagram, we're going to prove it by building the app live. So we're going to write a Cloud Function, which unlike a mobile app, really doesn't require much to get started, just a few variables and a function stub. Can we switch over to the demo? So first, we'll start by adding a function that triggers when the document is written into the database. From there, we run a function that will extract the metadata from that actual file. This includes the language, the encoding, and the sample rate. Then we will send that recording to Cloud Speech API by pointing the Cloud Speech API to the specific location in cloud storage. Once we get a result from the Cloud Speech API, it'll include the transcript, and we take that transcript and write it back into the database. Once we have the transcript, though, we still need to translate it. So we're going to do pretty much the same thing as before, but with the Cloud Translation API. So we're going to attach another function that triggers when the transcript is written into the database, and then when it runs, it gets the language, and we iterate across the languages that our app support and send a request to the Cloud Translate API for each one. As they're translated, we write them back to the database, and once all the translations are complete, we signal that the function is complete. So all this, now we can go back to the slides. So basically, a deploy is very simple. It takes a few minutes, and we know that your time is precious. So here's one that we prepared earlier. You write Firebase deploy, and pretty much we do the magic. Now I'm going to hand it back to Mike.
Thanks, Todd. So the demo's been acting up a little bit, so we're not going to do that, unfortunately. But what's going to happen is, again, upload the files, goes through Firestore, all of the magic in our functions happen, and then it gets the language spit back out. That was pretty cool. I promise it does work. We're having a little bit of flakiness over the internet. But you can actually go on GitHub. If you look for Zero to App Universal Translator, you can get all the code and build it yourself. So we just built 2 apps in about 20 minutes, complete with our own backend. If you hadn't come to this talk, you might have built something that looks like this, right? Your application talks to that server and proxies everything out. But that costs a lot of money, takes a lot of time, and requires that you get paged at 2 in the morning if your servers go down. You don't want to do that. You want us to own that management. Dan showed us how to replace that with Firebase and allow your application to talk directly to our various services in order to build serverless and management-free applications. Then Todd came up and explained how to add Cloud Functions to supercharge your application by adding the rest of Google Cloud Platform, including the Cloud Speech and Cloud Translate API, to securely and performantly build the rest of that application. Just as easy as it was to integrate both of those APIs, it is equally easy to add additional Google Cloud Platform services, including other pre-trained ML APIs or your own either ML or additional cloud products. And as you saw, it's really easy to chain events together to turn complex processes into really simple applications. So thank you all for coming. If you have additional questions, we'll all be right behind at the speaker zone area. And thank you all very much, and enjoy the rest of the talk, or enjoy the rest of the conference.
All right, hi everybody. My name is Taylor Savage. I'm a product manager on the Chrome team at Google, working on our many different open source web developer products that we build as part of the Chrome team. And I'm here today to talk about one of the products that we work on Chrome in particular, that we've actually been working on for quite a long time, which is the Polymer project. And also to talk about some of the underlying new, really exciting web technology that makes Polymer possible, which is web components. So I'd like to start off by giving a little bit of background by talking about some of the problems that we set out to solve when we went and started the Polymer project and when we started this effort around web components. So as everyone here well knows, the expectations of web developers are extremely high. We're expected to build sites that work across a wide variety of different browsers, devices that work across all kinds of different screen sizes, that run at 60 frames per second, that are silky smooth to the touch and immediately responsive, that load fast on slow and flaky networks, that work offline, that can send push notifications, so much more. There's all this difficulty in building a modern mobile website today. But the tools that we're given as web developers on the web platform haven't really caught up to this challenge. The web was initially designed for documents. And so the primitives that we get on the web are tags for things like headers and lists and paragraphs, things that were great when you were trying to send a document over the wire, but just don't really work for the applications that we're trying to build today. So we don't get primitives, for example, for things like UI tab strips. UI tabs are an extremely common paradigm across all kinds of different modern mobile applications. But this is surprisingly difficult to achieve on the web, and this should really be something that's first class and easy when we're trying to build mobile websites. And so over the years, we've come up with lots of different ways to basically effectively munge together these very low-level document primitives to be able to eventually end up with something like UI tabs. And the way primarily that we do this nowadays is through JavaScript frameworks. And these JavaScript frameworks take these low-level document primitives and turn them into UI. And they work in all kinds of different ways. So some frameworks will have us kind of overload existing tags and scaffold out any UI elements we want to build using HTML, and then make some magic JavaScript incantation that will somehow know how to understand the existing HTML and create a tab strip. Others will let you kind of add more HTML and JavaScript together and kind of customize your tab strip with a JavaScript object, and also customize by using different HTML tags. Some will have us do as much as we can in JavaScript and will have us not worry at all about the DOM that it's going to construct. And then others will be some sort of mix. They'll nest HTML strings inside of JavaScript, inside of HTML, inside of JavaScript, and maybe some domain-specific language inside of that JavaScript HTML Frankenstein monster. And all of these different approaches are really ultimately solving the same kind of problems. We're trying to build a reusable UI component. But all these approaches are very, very, very different. And it can sometimes feel like there's a new JavaScript framework coming out each week, because there really is a new JavaScript framework coming out each week. And this is exciting. This is not a bad thing. Only the web platform affords the kind of scale and flexibility and diversity to support this massive flourishing ecosystem of different JavaScript frameworks. This is great. This is really good. But for us on the web platform team at Google, it's kind of indicative of a larger problem. And it also causes a lot of problems for all of us as web developers as well, which I'll get into in a little bit. So on the Polymer project on the Chrome team, we recognized that this explosion of frameworks was awesome. It was a testament to the power of the web platform, but it was also an indicator that there was something wrong. There was some underlying problem that needed to be solved by all these different frameworks in the web platform itself that we were all looking towards JavaScript frameworks to fill. And so when we set out on the Polymer project, rather than just setting out to build a better JavaScript framework, which we couldn't really do, we set out to fix the underlying platform problems itself, to actually build a better web, that's one that's more conducive to application development, to help kind of solve some of the problems that all these frameworks are trying to solve in the platform itself. So what do I mean by that? That sounds hard and complicated. Where do we start? So we started with kind of a survey of all the different JavaScript frameworks out there, which again solve many of the same problems in slightly different ways. And many of us on the Chrome Web Platform team in past lives had ourselves built JavaScript frameworks. And so we were very well acquainted with some of the problems that this proliferation of frameworks can cause with web development. So there are two really main costs that that exposed themselves as we went through this research of different JavaScript frameworks that we set out to solve by baking in new primitives to the web platform itself. So the first cost is a lack of interoperability. So what do I mean by that? This lack of interoperability is a cost that you, the developer, pays. So JavaScript frameworks bring a lot of value to make web development more efficient, and many bring their entire stacks, proprietary stacks of functionality, and all JavaScript frameworks ultimately provide a way to build a standalone component model. That's kind of the crux of vast majority of JavaScript frameworks, is allowing you to build a standalone reusable component. But the components that you build in a framework are very fundamentally tied to that framework's stack and that framework's runtime. So this is fine if you're one developer building one site, but if you're working with a bunch of different teams who each want to kind of use their own paradigm or each use their own framework, you're stuck. You can't share components at all. If you're one developer that builds a site once in one framework and wants to maybe move to a newer, more modern framework later on, all those components you built for that old site are useless. You can't port them to the new framework. So this makes for a really incredibly high switching cost when you want to switch frameworks, and it also makes that decision of what framework should I use to be kind of the most important decision that you have to make for your entire project, and you have to make it day zero, which is really scary. And it also fractures kind of the component ecosystem across all of us web developers. So this is a very costly problem, a very costly decision, not so much for a single developer, but as your team scales and as the ecosystem scales, it becomes kind of this aggregate cost. The second cost that we set out to solve was one that your users pay, which is extra overhead, specifically on mobile. So the mobile web, as we all know, has really incredible reach, but it reaches into places where your users might have slow connections, flaky mobile connections, expensive mobile connections, or be running your website on slower, older devices. And furthermore, user expectations on mobile devices are extremely high. Users expect these applications to run at 60 frames per second, to load extremely quickly. And so it's incredibly important that we're able to build sites that can load quickly on mobile, even despite these difficult kind of network challenges. So when we're using a JavaScript framework to provide our component model, the browser must download and then parse and then compile and then execute that entire JavaScript framework before your web app can even come close to running. And this is fine on big, beefy machines with wired internet connections. But it doesn't really fly on flaky mobile connections. We're taking the most critical part of our code, which can be 50K of JavaScript, and forcing it through this very narrow pipe. And that cost of abstraction becomes extremely real when you get out into the real world and start loading these frameworks on real mobile devices on real networks. So our mission on the Polymer project is to make the web platform itself a more capable development platform, so that you can build web applications with way less overhead, with way fewer costs, and that take advantage of what's already sitting there directly in our users' pockets, on our users' devices, in the form of the browser that they have on their phone. And so our motto for the project overall is to use the platform, to use what's already installed on the user's device, the browser. So there's some good news. The web platform itself is actually incredibly powerful. And I want to show you a little bit what I mean by that by taking a look at an HTML element that I'm sure many of us are familiar with, which is the humble select element. So we're probably familiar with select. It provides you with this drop-down menu that you can click on or tap on, and it expands, and you can select an item inside the select. And it's a really incredibly simple element, but it provides this incredible amount of power kind of all hidden away behind the select tag. So if you just put an empty select tag on your page, you'll get this little kind of button-like thing with the little arrows and nothing else. But you'll notice this one little tag gave us kind of quite a bit of UI. We didn't tell it how to draw on screen. We didn't put those arrows in there. We got this all for free as part of this select tag. So the select element's also composable. We can add options to the select dropdown. And in order to add options to let the user choose from, we simply compose new option children under the select element itself. And now we get this much more complicated UI. So we get the ability to kind of mouse over, and the option that the user is hovering over highlights. When they tap that option, it becomes the selected option in the dropdown. You can use arrow keys and things like that to navigate the select dropdown. Again, all of this for free just by using this little tag. It's also declarative. So beyond just children of the select element, we can use HTML attributes to make certain options selected or disabled. We can change the behavior of this component just with this declarative attribute. It's forgiving. So if we mess up and if we put the wrong child in our select element, the browser doesn't crash, our web app doesn't crash. It'll just kind of ignore that and keep moving on. It's accessible to a screen reader kind of by default. So it gives you these nice little attribute handles to make sure that this element is fully accessible. And it's also programmable. So the document object model, the DOM, provides an interface for your application to talk directly to this select element in JavaScript. So it provides a whole API. You can get and set information using properties on the component. You can listen to its events that it fires when state changes within the component. And you can call methods on the component if you want it to do something. So it's got this full kind of rich, comprehensive API, again, just for free, just by putting this tag on your page. So all in all, Select is a pretty amazing element. It's declarative, it's encapsulated, you can reuse it all you want. You drop it on your page, you're not worried about it impacting other things on your page. This is the sort of UI component that we really all want with a standard interface that's usable in JavaScript. So you might think, OK, so let's take that select element, which again was kind of great for documents and simple forms, and let's just build a whole bunch of more elements for more mobile-friendly kind of UI components. And on the web platform team, we might be tempted to do that, to add a bunch more HTML elements like select they're specific for mobile applications. And indeed, in the past, that has kind of been how we've gone about adding functionality into the web platform. But a few years ago, a bunch of browser vendors got together and wrote what was called the Extensible Web Manifesto. And this is basically an agreement saying, we as browser vendors can't really anticipate what the next high-level abstraction or the next high-level component you're going to want is going to be. So instead of doing that first, we're going to take a step back and make low-level primitives that make the browser itself extensible, so that you as a developer get the full power that we as the web platform creators would have in order to create your own HTML elements. So rather than us defining the language for you, you get to build the language yourself. So we want to be able to provide all of the power that makes Select possible to you, the developer, in the form of new low-level APIs. So what would you need in order to build your own HTML element like Select? Well, you need to give it a prototype, and you need to let the document know that you've defined this new HTML element. You need to be able to define its own internal UI, kind of like how the Select had that drop-down menu and those little arrows. You need to be able to define that yourself and encapsulate it for your particular element. You need to be able to abstract away how it manages its children and abstract away any styles for the element and for how it works so that it doesn't impact the rest of your page when you use your own element. And you want it to let it declare and handle its own dependencies. So if the element relies on other elements, it needs to be able to load those itself. So all of these features that I just described, all these features that make building your own HTML element possible, are part of the new Web Component standards. So this is a set of APIs available on the web platform that let you, the developer, extend the language of HTML itself and build your own HTML tags. So I won't go too deep into Web Components. It's certainly a trove of information there. But it's effectively made up of 3 new primitives. So custom elements, which let you define your own HTML elements and tags and add behavior onto the JavaScript prototype or JavaScript class. Templates let you define your element's internal layout in an inert and easily clonable way. And then Shadow DOM gives you composition as well as scoping to encapsulate away any styles you might want to apply to your element, but not the rest of the page. So now for those of you that may have been following Web Components, you might notice that I've left out something here, which is HTML imports. Traditionally, HTML imports have been part of Web Components. They were conceived as a way to load element definitions. But as of recently, since browser vendors are shipping ES modules as a way to load code from other code, we're leaning in the Web Components community more towards using ES modules as that loading mechanism. So I've left imports out of here just to avoid any confusion. So Web Components help really solve the 2 major costs that I talked about earlier. So they're naturally interoperable. At the end of the day, all JavaScript frameworks ultimately have to speak the language of HTML and DOM. At the end of the day, JavaScript frameworks are manipulating DOM at the lowest possible level. And with Web Components, you can now extend the language of DOM itself. So DOM itself becomes your interoperability layer. And furthermore, all of this powerful component lifecycle and encapsulation, all the things you need to build your own reusable component, are now baked directly into browsers. So you don't have to ship down an expensive bespoke component model in the form of a framework. all of that component power is sitting right there on the user's device in their browser with web platform native APIs. So what does it actually look like to use a web component? So on the Polymer project, we've built out a large set of web components ourselves to kind of provide the look and feel for Google's material design UI paradigm. And we built these all out as web components. So you can just drop something like a paper button or a paper toolbar onto your page and get this really nice looking mobile-friendly UI component just like you would with kind of a select element. So I'll give an example of how you might use one of these components that we've built. So if you wanted a responsive toolbar, for example, you could use our paper toolbar element. And this provides a toolbar that sticks to the top of the page. And you can put things inside the toolbar to make it more interactive. And you use it just by loading this definition, this paper toolbar definition that we've built, and then just dropping a paper toolbar tag directly into your document. And to give it a title, you can just nest a div as a child of that paper toolbar and put your title, My App, right inside that paper toolbar, and you get this really nice looking mobile-friendly responsive UI component. But custom elements are really all about composability. So if you wanted to add maybe a little hamburger menu to the left part of your toolbar, you can just nest another component that we've built, paper icon button, inside your paper toolbar, set the icon to menu, and that will load this hamburger menu icon. And you get this, again, really nice looking, responsive paper toolbar, material design toolbar, just declaratively, just using these web components, just like you'd write normal HTML. OK, so that's pretty straightforward. Let's jump into something a little more complex, a slightly more complicated use case for web components. So let's say we wanted to express an entire API as an element. So for example, let's say we wanted to add a marker to a Google map and drop it on our page. If we wanted to do this using the Google Maps API imperatively directly, this actually takes a whole bunch of code in order to set up, and it's kind of messy. In the world of web components, though, we can encapsulate all of this code, all of this behavior into just a single tag, the Google Map element. We can load its definition, we can put Google Map on our page, and just like that, you've got a Google Map. But that's not it. Let's say we wanted to center the map at a specific latitude and longitude. And with custom elements, we can do exactly that by using attributes. So just like attributes in HTML, we can put a lat attribute and a lon attribute on our component. We can give it values, and that'll center the map wherever we asked it to. Now, we can also set a zoom level as an attribute to zoom into the map. And adding an icon to the map is just intuitive, just the way you'd use HTML as well. So you simply add a Google Map marker element as a child of the Google Map, give it a latitude and a longitude, maybe make it draggable, maybe give it a title. And again, just like that, you get a map marker on your map. Really nice declarative way of putting together a Google Map. And we can express the full complexity of the Google Maps APIs, or whatever kind of part of the API we want to express, as attributes on our element. It's totally up to us what those attributes look like, what attributes it accepts, and what behavior they then impart to the element itself. So we've actually prototyped a whole bunch of different Google services with web components, and there are a whole bunch of web components out there for other types of services as well. And you can, of course, experiment with your own sort of services and other things you might want to encapsulate as a web component. So that's kind of the power of using web components, abstracting really complicated things or really simple things like UI elements behind just HTML tags. So what is Polymer? So the web component APIs that I talked about, custom element, shadow DOM, template, are actually very, very low-level APIs. They're very, very raw. And you can totally just use them directly, just in JavaScript. But we found that if you build a bunch of custom elements, if you build a bunch of components yourself, you end up sort of writing the same boilerplate code over and over and over again. And so we pulled out some of the common boilerplate code for creating web components into a library, which is called Polymer. So Polymer itself is just an opinionated library that provides a lightweight sugaring layer that makes it a little bit easier to build web components in a sort of don't repeat yourself way. So let's take a look at how you use Polymer to build a component. So these examples come from the new Polymer 2.0 version of the library, which uses a really nice ES6 class-based syntax. So let's look at a very simple, just totally basic element, just a custom element that just says, I am a custom element. So to create an element with Polymer, you create a new custom element class that will be the class for your element, and you extend polymer.element base class, which imbues your class with a lot of the common functionality that you might need to construct your element. You also define an is method, which returns the tag name for your element. So in this case, we're calling the tag for our element custom-element. And then here in this particular element, we'll set the text content to be I am a custom element when the element actually boots up. And then finally, we have to tell the browser, hey, I've just created a new custom element. Here's its tag name. And so for that, we'll directly use the customelements.define API, which lets you give a custom element registry a tag name for the element, which in our case is the result of customelements.isGetter, and the class that will represent that element, which is our custom element class. And just like that, when we put a tag custom element on a page, we'll get I am a custom element. So fairly straightforward, but you can start to see sort of the power that we might be able to get by using these custom elements APIs on Polymer. So let's say we wanted to make the elements UI a little bit nicer by giving it a template. So associating an HTML template with a custom element is a really, really common paradigm, and so we make it trivial with the Polymer library. So Polymer provides this notion of a DOM module, which is effectively just like a bucket of HTML that you're going to want always associated as the template for your element. So whenever your element is on a page, this template will provide that element's UI. So inside the DOM module, you want to give it an ID that matches the tag name of your custom element so that Polymer can associate the two. And then you want to give this DOM module a template child, and inside that template, you'll define any of the HTML that will make up the common user interface for your particular element. So in this case, our element is also going to be very simple. It'll just be a paragraph that says, I'm a DOM element, this is my shadow DOM. And again, we'll define our element base class like we just did in the last example, and we'll register it with the browser. And now when we put this DOM element on the page, Polymer itself will automatically stamp out that template, and we'll get, I am a DOM element, this is my shadow DOM. So again, fairly straightforward. But we want to make sure that the behavior of our specific element won't leak out and disrupt the rest of the page. We can't have any style that we apply to our template accidentally applying to the entire document. And furthermore, we want our element to be able to handle children really elegantly. So this is where Shadow DOM comes in. Now, Polymer automatically puts all of the contents of an element's template inside of an encapsulated shadow root. And this is incredibly powerful. So what a shadow root provides for an element is this kind of safe bubble, this safe space where you can put DOM, where you can put CSS, and all of it will just be encapsulated inside of that particular shadow root and won't leak outside of the rest of that shadow root. So I'll show you what I mean. So let's say we want to build a picture frame element, which just provides a little gray border around a specific image. So you can see here that inside our elements template, we give some style to just the basic div tag. We give it sort of a gray curved border. Now normally, if we provided this style to div, this would totally screw up our entire website. Every div on the page would have this border. But not with Shadow DOM. This all gets encapsulated away inside of our particular element's shadow root. And also, Shadow DOM gives us the power of projection. So it lets an element define where in its template any children of that element should be effectively displayed. So this is what's called the insertion point for your particular element, and we declare this using the slot tag. So in this picture frame case, in our template, we're going to have a div that we've styled above, and then inside that div, we want to effectively project through any children of our picture frame element so that it looks like it's appearing inside of that div. So when we use our picture frame element, we'll have our picture frame tag, and then as a child, we'll have that image tag, any image tag we want, and it will get projected through that slot inside that div, and it'll get that nice gray border painted around it. And again, all of this will be encapsulated away. So there's even more. Polymer provides some basic functionality for doing declarative data binding inside your element's template. So say we wanted to create a name tag element, where the element's owner property, the actual property on the DOM node itself, will be a string. And that string will show up inside the text, this is owner's name tag element, inside of our template. So in our Polymer template, we can use this curly brace syntax, and inside of it reference the owner property on the element's prototype. So that's what owner reference is, the property on the element's prototype.
banking should be painless, easy, fast. It should just assist you in doing whatever you want to do. So actually it's our strategy to empower people to take a step ahead in life and in business. If you look at our company, we have all this different IT landscape in all the countries. Still, we want to be able to share. And that's when we start to look at web components, and web components solve that for us, because when we use Polymer and web components as the standard underneath, we can suddenly create components which will work in any country. So you can just take that components and start delivering a feature. So now when I'm in that shop looking at that bike, I'm not only checking my balance, I'm also pressing the button, let's look ahead. And what it will tell me, next month your mortgage will be deducted from your account. So maybe this is not the best time to buy that bike. And that's what we're doing it for features and not for the UI part. We are starting to see this whole developer community which is moving to one technology, and we are seeing more and more people working together from all the countries. When this translates to results, anything can happen.
Hello, everyone. A very good evening. And thank you for joining me in this session. I'm Syed Malik. I lead search outreach in India and South Asia. And I must say I'm super excited to be here and to be talking about some of the most common issues and misconceptions related to search engine optimization, or SEO, that can affect the visibility and appearance of your pages in Google search results. Now, what I have for you in these slides is basically three things. First, we will look at the general mistakes that publishers make, or some of the things they tend to ignore, and some of the misconceptions that they have. Then we will move on to looking at things that are related to mobile-friendly sites. And then I'll leave you with a piece of advice on how to hire an SEO, meaning if you want to hire somebody to do SEO for your website, what are the things that you should look for, and what are the things that you should watch out for. So let's begin. First, some of the obvious but not so very obvious things, These are some of the common mistakes that publishers make when they do SEO, or some of the very basic things that they tend to ignore, thinking they are trivial, they are not useful, and things like that. And some of the misconceptions they base their SEO strategies on, which, of course, if they are misconceptions, they will fail them. Yeah? So what I have done in this section is basically collected a bunch of statements from Google's guidelines, and also some of the statements that we hear from the SEO community and the publishers time and time again. And some of these statements are true, and some of them are not. Let us see how many of these you get them right. Okay? Okay, the first one. Descriptive page titles, meaning which you implement using the title tag in your HTML documents, and the good meta descriptions, meaning again the meta description tag that you use in your HTML documents, are important for better search ranking. How many of you think this is true? Many hands. How many of you think this is not true? A few hands. Okay, all of you who said this is true were correct. Yes, this is absolutely true, because if you think about it, although this may look like a very trivial thing, just a title and a page description, which is actually not visible to your users on a web page, right? These things are not visible to users. However, these are very, very important. And if you think about it, when a user is on a search results page, these are the only things, or the only window they have into the content of your website. When they're on the search results page, when your site appears in the search result, this is the only window they have. This will allow them to judge basically whether they want to click through to your site or not. That's the decision point. So their decision is based on this. So if you do not basically give good, creative, and useful titles and descriptions for your pages, then even if you manage to rank well in Google search results, you may lose traffic. Now, this is not to say that Google always picks the titles and the descriptions that you give or you provide. Google may also pick the title and the description from, for example, the content of your page, right? It tries to make the description and the title of your result as relevant to the query as possible. However, if you do not have a lot of content on your page itself, then it becomes even more important for you to provide good titles and descriptions. So this is extremely important. Now for the next statement. But content is still king. Meaning, yes, of course, you have your titles and your descriptions and this and that and everything that you have done for SEO. But if you do not have good quality content, useful content, organic and original content that can give value to your users, do you think you're going to do well in the search results? Do you think content is king ultimately? Yes? How many of you? Okay, many hands again. How many of you think it is not? I will put my hand down because I do think it is extremely important. Yes, I still see some hands. Some people think content is not important, which is no, absolutely wrong. Because content is definitely the king. Because if you think about it again, why would somebody like to come to your page? What are they coming there for? not to see how well you have optimized your pages for search engines. They are coming there for basically the content of the page, right? They want to consume the content. Now, if you don't have that content providing value to them, usefulness to them, then of course they will not like your web pages. When they don't like your web pages, Google would not like to show those web pages to those users. Of course, right? Because they don't like it. Okay, now for the next one. And there is a minimum and a maximum limit of words for an article for it to rank better, right? Meaning, if your article is too short or if your article is too long, it may not do well in search results, right? How many of you think this is true? Okay, a lot of hands again. How many of you think this is not true? Okay, a very, very mixed response, 50-50 I can say. Well, let's see the results. Of course, this is not true, right? So if you think about it again, I mean, there are different types of content on the internet. So one piece of information can be delivered completely in just one paragraph, for example. And the other piece of information may need an entire page to explain, right, for it to be complete. So instead of focusing and counting the number of words in your articles, what you should be focusing on is, are you providing complete information to your users? Organic, complete, and authoritative information to users is what actually matters, not the number of words in your articles. Now for the next one. There is an optimal keyword density that can help rank better for the desired keyword. Meaning, if there is a page and you're targeting that page to rank for a particular keyword, now this word has to repeat certain number of times on that page. Otherwise, Google may not pick that keyword from that page and may not associate your page with that keyword and may not ultimately rank that page for that keyword in the search results. How many of you think this is true? Wow, a lot of hands. How many of you think this is not true? Okay, for the people who said they think this is not true, you have good news. You're right. This is not true, okay? So there is nothing called optimal keyword density. I know there were a lot of hands that were raised, and these are the misconceptions that I wanted to bust in this session. So there is nothing called optimal keyword density. What you should actually focus on is the user. Well, of course, the keywords are important. You should definitely step into the user's shoe and think about them. Think about what are those keywords that they would type in this Google search when they are trying to look for content that you are going to write, right? And consider those keywords and try to include those keywords in your content. Definitely, for sure. But overdoing that is not going to help you. Indeed, it can basically harm you, because imagine reading a newspaper article which is full of keyword stuffing, You see one word repeating many times. Would you like to read such kind of an article in a newspaper? Absolutely not. So try to make it as natural as possible. Do not focus on the density or the repetition of the words, their proximity and things like that. Focus on the user. Try to make your article sound as natural as possible and ultimately try to give them value in your articles. Now for the next one. It is super important to fix all the 404 errors warnings that are shown in the Search Console. How many of you, by the way, use Search Console here? Whoa, not a lot of you. How many of you, so the rest, I'm assuming you don't use Search Console. So Search Console is basically a free tool. And it is the only tool in the world, by the way, that can give information about your websites in relation to Google search, as in what are the problems that Google is encountering while trying to crawling your pages, indexing your pages, a number of other issues that it is encountering that can hinder your visibility in Google search results. This is the only tool that can provide you information. It is absolutely free to use. I would highly recommend you to use this tool. We will have a link to this tool in the coming slides. Please note that down. I would highly recommend you to sign up for this tool. So when you sign up for this tool also shows you the 404 errors Googlebot has encountered while it was trying to access. So it might have found some links to your pages which may not be existing or may be existing, but there are some errors there and found 404s, and it starts showing these errors in the Search Console. Now, how many of you think fixing all of these 404 errors is like mandatory? You must, otherwise your ranking will get affected. Many hands again. Okay. The good news is, no, you don't need to, right? Because for the pages that do not exist, they do not exist, right? It is right for them to show a 404, and that is what those pages are doing. But Googlebot is somehow, coming across the links that are pointing to those pages, and it's trying to crawl those pages, and it is showing you those error warnings. But if you think that page need not exist on your website, you can simply ignore these kind of 404s. What happens eventually is Google tries to crawl these pages a number of times, and then eventually it will understand that these pages do not exist forever, they're gone forever, and then it stops showing you these errors. And for the pages that you think do exist, right? But Googlebot is still showing a 404, then you should check those and then fix them. And here's another one. Google's algorithms are way smarter for me to do anything to help it understand my images better. Meaning Google's image algorithms are like very, very proficient, efficient. They can understand all kinds of images. And when you put an image, embedded image in your HTML document, there is nothing else that you need to do. Just provide the image, and Google will take care of it. How many of you think this is true? Finally, only one hand. Oh, two hands, which is good news for me. Because yes, most of you think this is not true. And of course, this is not true. While Google's algorithms are like, yes, they are great, they are brilliant. They can understand images, of course, a lot, but there are times that they cannot understand images as well, and they cannot understand all types of images. For example, you have been to on a holiday to an obscure place, and you have taken this picture of this obscure place. When you put this picture up on an HTML page, Google may not necessarily identify that place, right? Or as simple as it may not be able to differentiate between a cup of coffee and a cup of tea when they are identical, as simple as that, right? So these kind of things. So what can you do to help Google search understand your images? When Google search is able to understand your images, then of course it is also able to show it in the search results, right? So it is important for you to help Google understand these images. So what can you do to help Google understand your images? Make use of the alt tag in your HTML, right? In the image tag, you have alt attribute. Try to use alt attribute, describe your images there with a couple of keywords, right? And you can also provide the caption for images wherever applicable on your web pages. You can also name your files instead of naming it 001.jpg. You can maybe, give it a proper name that describes the image itself. These are the places where Google can take hints from to understand your images better. Okay, that brings us to the next part of this session, which is common issues and misconceptions around mobile-friendly sites. Now, these are some of the issues that we come across mobile-friendly sites. When you try to crawl them, index them, Google faces a lot of trouble and may not be able to crawl and index these sites. One of the most prominent problems is blocked resources, meaning while a lot of publishers allow their HTML pages to be crawled and indexed, sometimes they, knowingly or unknowingly, they tend to block the attached resources, the resources that are attached to this web page, like, for example, JavaScript, CSS, and image files. Now, why is it important for you to make these resources available to Googlebot as well? Why? Because how Google tries to understand your content is it tries to basically render your page, execute the JavaScript, just how it happens in your browsers. It tries to do the same thing with your pages to get all the content in the context, right, to understand them better. So this is how it tries to understand your pages. And when you block, for example, your CSS and your website is a responsive design, Google may not understand or know that your website is a responsive web-designed website, right? And it may not think that your website is a mobile-friendly site. Or if you providing some content to your users using JavaScript, that content may be blocked when you block your JavaScript, and Google may not be able to get to that content and index that content, and of course may not be able to show it. So it becomes absolutely important for you to make all these resources as well available to Googlebot. Unplayable content. This is another issue that we have seen on major websites as well, by the way. When you use plugins that are not supported by mobile browsers, for example, this makes for a very, very bad experience for even your users, and it creates problems for Google crawler as well. When Google tries to crawl, for example, if you're using Flash on your pages, Google may not be able to get to the content that is within the Flash component, right? It may not be able to read through it, right? And your users who are accessing your web pages from the mobile device may also not be able to access it, so it makes for a bad user experience. So these are the things, these are some things that can actually affect your SEO as well. Interruptive interstitials, right? I'm sure some of us have experienced this. When you open a web page on your mobile device, you suddenly see a pop-up which is like covering an entire page. It is blocking you from accessing the main components or the main content of that page, or to do the desired action on that page until you do something, you close it, or you sign up, you download something, and things like that, right? This is against Google's policy guidelines because this does not make for a good user experience. What we suggest instead, if you have to show something, then use smaller banners without blocking the main content of your pages. Slow pages. Now, this is again more from the user experience perspective. I am 100% sure that each one of us in this room have experienced this, right? Especially when you're on your mobile devices on the go, you try to access some information, and then that page simply doesn't load. In fact, surveys have shown that 53%, these are the global surveys, 53% of the people tend to leave your website if it takes just more than 3 seconds to load, right? You heard it right. 53% of the people tend to leave your website if it takes more than just 3 seconds to load. Unfortunately, surveys also show that 75% of the websites that are day-to-day take more than 10 seconds. That's ironic, right? So you would definitely want to go back and check how you can improve the speed. And when you're building your mobile pages especially, try to build them for flaky connections, interruptive connections, and mobile users. Now, the last one here, faulty redirects. This is, again, one of the major problems that create problems for Googlebot as well as users, right? So what we have seen is especially, this is applicable especially when you take the separate URL approach, meaning you have example.com as your desktop website and m.example.com as your mobile website. And then, you know, when somebody's accessing your mobile version or a desktop version from a mobile phone or a mobile version from a desktop, you know, you need to redirect your users. And these redirects do not function properly. And if they do not function properly, they create a lot of problems for Google crawlers in understanding your content, crawling and indexing your content, as well as create a frustrating experience for your users. In an ideal scenario, what should happen is all your desktop pages should redirect to the corresponding mobile version of your pages, right? But what we have seen is sometimes when you do not have, for example, if there is a page that is only available on the desktop version of your site, and this particular page is not available on your mobile version, people tend to redirect that are trying to access the mobile version of this page to the mobile home page, or they just give a 404. Right? Both of these practices are not great because users do not understand what a 404 is, and they're more confused when they're redirected to the home page. So they try to go back and try to access that URL again. So that creates for a very, very bad user experience, right? So, and even when Google is trying to crawl your pages, if you are redirecting it here and there and everywhere, then Google also get confused, and it may have difficulty in crawling and indexing your pages. So those were the things with related to mobile-friendly sites, common issues. And here are some basic tools that Google provides to make sure that Google understands your websites as mobile-friendly and to help you make your websites mobile-friendly as well, right? On the left, you have Test My Site. You can access this through g.co test my site. If you go to this link, it's a simple tool. You enter a URL. It gives you a binary answer as to whether Google considers your website mobile-friendly or not. Sometimes you may think your website is mobile-friendly. You open it on a mobile device. It works fine. But you know, at the back end, maybe some of the resources are blocked, like JavaScript and CSS, and Google may not understand it as a mobile-friendly site. Those kinds of problems can also be highlighted using this tool. The other tool that we have is the Mobile Usability Report. This basically is accessible through Search Console. So if you don't have a Search Console account, you may not be able to access this. So you'll have to first sign up for the Search Console account. And then this gives you a more holistic view about your entire website of the problems that Google encountered while it was trying to understand, crawl your mobile-friendly site, right? Okay, and there are more tools, of course, and time does not permit us to go through in detail of each of these tools, so I'll leave you with the names of these tools so that you can go back and explore. And I'm sure some of these tools were also covered in some of the other sessions that you may have attended. They are like Chrome Experience Report, Lighthouse, PageSpeed Insights, Chrome DevTools, and webtest.org. These are some of the tools you should definitely look for that can help you increase your page speed, make your websites mobile-friendly, and things like that. And of course, while talking about mobile-friendly websites, our discussion, I think, is incomplete without mentioning mobile-first indexing. Now, how many of you heard about mobile-first indexing here? Very, very few hands. OK, what is mobile-first indexing? Mobile-first indexing. So far, Google considered your desktop version of your websites as the primary version. So it relied upon your desktop version to get information like the primary content of your web pages, the metadata, and the structured data. Right? Now this is changing. Google is going to consider the mobile version of your pages as primary, and it is primarily going to rely on your mobile version to get all this information. Meaning, if you do not provide this information, the full primary content, the metadata, and the structured data on the mobile version of your site, then Google may not get all the information, right? And it may not be able to show your pages as well as it could if you did provide. So it becomes now important for you to ensure that all of these three things, primary content, metadata, and structured data, are equivalent between your mobile site and your desktop site. Now, of course, if you're using a responsive web design, for example, there is not much for you to worry about, or even a dynamic serving approach if you have taken to build your mobile-friendly website. Because what is happening in responsive web design, for example, you're just changing the format of the same content. The content remains the same. You just change the content, the format of the content to serve to desktop users and to the mobile users, right? Content is not changing, metadata is not changing, nothing is changing. Even the structured markup that you have on those pages remains the same. So there is kind of nothing to worry about. But if you have taken the separate URL approach, then of course there is something to worry about. You go back and check that your mobile version is equivalent in terms of these three things to your desktop version, okay? Now, for websites which provide their services or their content in multiple languages, like multilingual websites, when you're implementing the rel equals hreflang element, now you need to make sure that the different language websites of the desktop version link to each other, and the different language website of your desktop mobile version link to each other, meaning they do not cross-link, right? So a language website do not cross-link using the hreflang tag to a desktop website. A desktop page is not linking to the mobile site. A mobile site is not linking to the desktop. Rather, they are linking to the desktop versions of different languages and mobile versions of different languages for mobile. And as for the rel equals canonical tag and rel alternate, which you use when you use the separate URL approach, example.com and example.com, where your example.com is the primary version, the canonical version, and then the m dot version is the alternate version. So you would have tags like your desktop version is pointed as canonical and this as the alternate. You can keep that tag as it is. There is no need to change that tag. OK, now quiz time again. Now here, there are two statements here. First one reads, Google recommends responsive web design. How many of you think this is true? OK, like 50% of you, I'm assuming 50% of you don't think this is true. How many of you think responsive web design is preferred by Google's ranking algorithms? Meaning if you have a responsive web design, wow, surprisingly more hands up there. OK, let's see. Well, while the first statement is true, the second is not. Google does recommend responsive web design for various reasons, right? It does recommend responsive web design, but that does not necessarily mean that Google also prefers responsive web design while ranking, right? What this means is, irrespective of what technology you're using, what methodology you're using, what approach you're using, either your website has taken the responsive web design approach or the dynamic serving approach or the separate URL approach, we treat them all the same when it comes to ranking. Absolutely the same. Google's algorithms do not look into the background technology when they're ranking pages. They just look at the content of your page and the 200 plus factors that we have to rank your pages and whether your website is mobile friendly or not. As far as your website is mobile friendly, you're doing good no matter what technology you're using. OK, that brings us to the last part of this session, which is hiring and SEO. Now this begins with quiz. Here's another statement. It is better to hire a Google certified SEO or a SEO agency and to check their certification hallmark to verify. How many of you think this is true? Not many hands. OK, how many think this is not true? OK, some more hands, which is kind of great. But for the people who think this is true, unfortunately, this is not. There is nothing like a Google SEO certification, absolutely nothing. If somebody tells you that they are a Google certified SEO, turn your back and run away, right? Because they are the absolute frauds. We do not have anything like Google SEO certification. While we may have other certifications, AdWords and things like that, we never had or never will have, I think, Google SEO certification. Now, hiring an SEO is a big decision, you know. It comes with potential advantages, of course, if you hire a right SEO. But if you hire a rogue SEO, then you can potentially have a lot of damages. You can even lose your current ranking and money and a lot of things, you know. So it's a big decision. So how can you determine an SEO is right for you or an SEO agency is right for you or not? There are some useful questions you can ask. Things like these, you know. First of all, ask them, can you show me some examples of your previous work? Are they really established SEOs or very new SEOs, right, that are going to disappear in a couple of months? What happens with these SEOs is where genuine SEOs can work for a longer period of times because they're not violating any of the search quality guidelines, they're not deceptive, you know, so they're not frauds, so they stay longer in the business. So if an SEO is staying longer in the business and if they have good reputation and good quality work to showcase, then they are something that you can look forward to and move your conversation on with. Also ask them if they follow the Google search quality guidelines. If they say no, then they are not the people you should be hiring, because if they don't follow the Google search quality guidelines, then, you know, the Google search quality team may even take a manual action on your website, which means they can remove your website from Google's index entirely, or maybe push down your website in the results. So that can also happen. So if they're not following Google search quality guidelines, they are not the people you would want to work with. The other things you can also ask is like, what kind of experience do you have beyond SEO in general marketing and stuff like that? Because SEO is something not standalone. It can't be done standalone. It is a part of the entire mix, you know. So if somebody is doing SEO alone, then you may want to be a little bit wary and then go into the details as to what they're doing and things like that. But if it's a marketing agency that specializes in different types of marketing things, you know, social media marketing here and there, and all sorts of things, including SEO, then of course you can proceed with them. And also, one of the important questions you should also ask is like, what kind of results can I expect if I hire you? If they say, OK, we can bring you with the #1 position for this keyword in 2 months, again, turn your back, run away, because they are the absolute frauds. No one on the face of this earth can guarantee you a #1 position ever and ever, OK? So if anybody promising that thing to you, know for sure that they are frauds. OK, what kind of experience do you have in my industry? You know, this is an important question as well, because this is to understand if they understand your business objective, your business goals, and your users as well. You know, do they understand them well or not? If they do not, then probably they are not the people you may want to work with. If they understand all of those things well, if they already have experience in your industry, then those are the people that can potentially help you. What kind of experience do you have in developing international sites? This is especially relevant for people who have multilingual sites or sites that are targeting multiple regions. Then if the SEO already has an experience in there, then probably you can hire them. And then what sort of techniques do you use? If they say, no, the techniques that we use are top secret, then again, the same formula. Turn your back, maybe decide, and run, OK? Because when they're not transparent, there is something wrong. There is definitely something wrong. A genuine SEO can be 100% transparent to you. They can share with you every single thing that they're doing with your websites. And how long have you been in business? As I said earlier, good SEOs tend to stay longer in the business because they're not frauds, so they tend to be there. And then finally, can I communicate with you? Are they really open? Are they really transparent? Are they going to share everything with you that they're going to do with your website, right? yes or no. If they say, no, 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 we can't share some things, we can share only some things, then probably those are not the people you may want to work with. OK, so that's all I had for you. If you have any questions, I'm available there. A couple of my colleagues are also available outside this hall. And your questions are most welcome. Thank you very much.
Polycasters, and welcome to a surprise edition of the Meownica Show.
So if you work in software development and you don't exercise your design skills, just practice. Just do it. Do it even though you know that it's bad.
If you want to improve the quality of your site but don't know where to start, the new Audits panel is a great place to get some inspiration.
This is a quick web series about solving web problems with standards. Let's go.
I'll be right here to tell you what's new in Chrome.
That's Webpack Performance.
One day I'll get around to learning it.
You could just watch this video.
Knowing what is and what is not visible can be very useful information. I can change these properties in DevTools to find the ideal value for my layout.
It's Rob Dotson. Welcome back to the AliCast Show. I want to show you what just landed in Chrome DevTools version 60. So follow me over here to the laptop.
If you want the latest news and ideas in web development, subscribe to the Google Chrome Developers YouTube channel.
Good evening. Are you all awake? Are you really awake? Are you tired? Oh, thank you very much for overcoming the tiredness to come here. How many are you from the GDG community? Oh, how many of you are there from the developer student clubs? Awesome. How many of you are certified alumni? Nice. Thank you very much, folks. And this is a community session, so we're going to spend the next 30 minutes with a series of lightning talks. My name is Karthik Padmanabhan. I'm part of the developer relations team, representing the team, and I'm trying to moderate this 30-minute talk, which is going to be very quick, snazzy, 4-minute format. And we're going to try to get through this with little swiftness and a lot of speed. So before we get into these talks, I just want to very quickly set the context. For every particular life cycle in a developer, right, we have some Google developer programs available to you. So if you're a student in a college, you can check out the Developer Student Club. You can become a community leader. You can get more members into that, and you can get going with that. Or if you feel that you want to be employed and you want to get the right kind of employment, you can go looking for the certified alumni program out there, and some of you would have already gone check that out. And then you can eventually get into a stage where you're actually professional and you want to work. You can become a part of the GDG network, Google Developer Groups, and become a member, become a leader, and we're going to have some series of talks from that. And eventually, if you feel, especially all the women folks out there, how many of you are there? Please raise your hands. Oh, give them a big round of applause, guys. Thank you. And so you can all become a women tech leader, tech maker, and a leader, a WTM lead as part of the WTM program. And then we also, for people who really spend a lot of time and build a lot of expertise and want to go ahead and share that knowledge, we have a platform called the Google Developer Experts. You can go ahead and leverage that. And then finally, we have a startup program, and you can become a Launchpad member as a part of the program. This is all these programs across the entire life cycle of a developer, and you are able to connect with any of these programs, and you can later connect with me or the team to get more details on this. So with that, let me give, ladies and gentlemen, please give a big round of applause for Christy Anup to come on stage. He's going to share with us his journey as a Developer Student Club leader. Christy Anup, over to you.
Thank you, Karthik. Good evening, everyone. My name is Christy Anup, and I'm the lead for Developer Student Club at CMR Institute of Technology. Well, I'm a fourth-year information science and engineering student who spends most of his time outside the class than in the classroom. Now, let's not get into what I do outside the classroom. In fact, I help my friends and I mentor my juniors. This is what I do. Today in this presentation, I will be going through what we as DSC leads do, our roles and our responsibilities. The Developer Student Club program is a massive network of 190 developer student clubs all across the country. From approximately 100 cities, these developer student leads were handpicked by Google after rigorous rounds of interview from application pool of 1,000+ applications. We strongly believe that these DSC leads will have a high impact in the society. Now let me briefly go through what we do. We are students. We learn and we keep learning. We learn from the amazing material provided to us from Google, beautiful material, and we share this knowledge through workshops. These workshops are not only open for novice developers, but also open to advanced developers trying to further their skills. These workshops are custom designed for the type of audience that enter the workshops. And by the end of every workshop, we make sure to provide them material directly from Google from which they can continue self-learning. And trust me, we have received amazing, tremendous feedback for these workshops, and we will be providing more and more workshops in the coming months. Now, students have become technically strong. They know how to code, but they will have to implement it somewhere, right? They're going to help local businesses, local entrepreneurs, and local organizations help run their businesses more efficiently and help them make more money at the end of the day. This is one of the beauties of the Developer Student Club network. All this takes place through communication. They go to the local businesses, find out what their problems are, and develop mobile and web solutions for them. Now, these are not big organizations or businesses, just small businesses, and they come up with very simple solutions to help them. And in this entire journey, the Developer Student leads and the students not only become technically strong, but they also learn business analytical, business communication, as well as soft skills, and most importantly, they learn real-world problem-solving skills. How awesome is that? Now, students know everything. They're technically strong. They know the ins and outs of business. They also know how to communicate well. They're more open to employability opportunities. They're more open to full-time internship as well as freelance project opportunities. How awesome is that? That's really amazing, isn't it? This is one of the main aims of the Developer Student Club Network, to help students, to help them make more employable. And finally, we would love for you to be a part of the Developer Student Club Network. Please contact the email ID on the screen, and you will be connected to your nearest Developer Student Club in your city, where you can provide mentorship, training, and also help students solve real-world problems. We look forward to seeing you, all of us on our campuses, helping our students, helping local organizations, and helping our world an amazing place to live. Thank you.
Wow. Christy, I have a awesome. Thanks for this passionate talk.
Thank you.
Really appreciate all the great work you're doing for the Developer Student Club program. So what has been one of those important moments for you managing this program at CMRIT? By the way, he's in the 4th year Information Science and CMRIT. What has been a memorable moment for you?
So this program has completely transformed me, Karthik. I'm not the person I used to be. So I used to be a bit of a selfish person, but after coming to this program, I've completely changed into a new person. I won multiple awards, but when students who you taught in your workshops come back to you after a few weeks, after a few days, with their own application, you feel a sense of accomplishment. This is a type of reward that I've never felt before. So this is what I love of the Developer Student Club Network.
Thank you. Ladies and gentlemen, please give him another round of applause. Thank you.
Thank you,
Anup.
Thank you.
Thanks.
Thank you, Karthik.
So let's move on to the next very important program, Google certification, Google Developer Certification. Before I call on JP, how many of you have gone to the certification lounge? Wow, that's awesome. Thank you very much. So we have the global lead for certification, JP and Kamal. Take it away, JP.
Hello, everyone. We're here to talk about developer certification. Who wants to hear about developer certification? All right.
Ooh.
Do we need it louder?
Yeah. Ooh.
Ooh, developer certification. Woo! All right. I'm JP. I'm the program manager for developer certification, and we launched developer certification at I/O in 2016. With the purpose being to help close a gap for employers that are looking for talented developers and developers that are looking for jobs. In this, our mission has been to create performance-based certifications that are industry standard and help developers gain recognition and advance their careers. Since we launched the program, we have created Associate Android Developer as a certification, Mobile Web Specialist as a certification, and there's more to come. We've certified approximately 1,700 developers in over 90 countries. 300 of those developers are Indian developers. In addition to the numbers, there's also been some impact in terms of promotions, jobs, career. Alumni are reporting new jobs, additional opportunities, speaking opportunities. It's making an impact. Some of the testimonials we've basically received speak to this, and there's more. So this is just a brief overview to set the stage for certification. What I'd like to do now is introduce Kamal Avad. Kamal is one of our first certified Android developers, and he's going to speak about his experience with the certification program and what has happened since that time.
Hello everyone, my name is Kamal Ved. I am Google certified Android developer with having experience of 5+ years in Android. Currently I'm working with Infosys Limited at Chandigarh as tech analyst. I first heard about this program at I/O, and I was super excited because I found a way to test my skills. So I completed my certification back in 2016, and it has benefited me personally as well as professionally. By personally, I mean, I was looking for a job in 2016 in good organizations before my certification. Once I completed my certification, I got noticed, visibility, and got more job calls. So it helped in a way. If I talk about professionally, I'm a SME, smart professional engineer, subject architect, and working with in different programs that includes reviews, app management, and different activities in our organization. I'm getting more visibility in my current organization due to my certification, as I am the only certified guide in Infosys at Chandigarh region. There are more benefits associated with certification as well. From organization point of view, every organization wants to hire good talent, having good technical, sound knowledge under the belt, right? So they are using certification as a filter nowadays to conduct quick interviews. If you are a certified dev right now, you'll definitely have an edge over others. There are some other benefits related to certification that I have got. I want to share that. Social. If you are a social person, ever since I have completed my certification, I have been called by many universities, colleges, students to come over the place and work as a trainer to guide them and tell about the certification program and how they can go about the Android stuff. So, for example, I have been called by GDG Jalandhar for DevFest recently. So here's the link. If you are interested in this program, you can go over this link and find the stuff and go step by step.
Please, ladies and gentlemen, please give JP and Kamal a big round of applause. And please keep the certification momentum going across. And there will be a lot of new certifications coming up. So stay tuned and keep track of what's happening in the certification world. So moving on to the next talk, are you guys having fun? Is it interesting? Is breaking the monotony? Yes, no? Huh? Yes? Yes? Okay, so let's call my next speaker, who's from the favorite part of the country called Jaipur. Vikas Bajpai is going to share his thoughts and views about building the Google developer groups. So without much ado, please welcome Vikas Bajpai. Ladies and gentlemen.
Hello, Karthik.
All yours.
Hello, everyone. So one of the prime benefit of being a GDG member is you get a huge fan following. So I am Vikas. The entire country is in search of Vikas these days. Jokes apart, I am Vikas Bajpai. I am the organizer of GDG Jaipur. It's in Rajasthan. When we talk about GDG, just wanted to get to know that how many of you are aware about this term GDG? Right, so many of you. So basically, GDG gives you a platform where you can talk, you can share, you can interact, and of course, you can have some good food. Right, looking at my health, you can have trust on whatever I'm saying. So if you talk about Google Developers Group in terms of the presence all across the globe, we have 700 plus community groups in 107 countries with 300,000 people associated with these groups. And it's huge. It's huge. And it's supported by 2,000 organizers all across the globe. And if you talk about Indian context, so what we have here is we have 21 chapters which is supported by n number of developers. Some of the developers are sitting in this audience as well. And we are able to reach 75,000 plus people. If you want to know more about this Google Developers Group, or if you want to open a chapter in your city or in your region, you can visit meetup.com/pro/GDG. All the activities which are performed under this umbrella or the Google's umbrella are absolutely free. And of course, I would like to see you in the future events which will be organized by these chapters. If you want to know more, if you want to get more insight about the Google Developers Group, you can interact with some of the awesome GDG organizers who are sitting in the community lounge. Some of the people are sitting here only. And you can also reach out to me as well. Hope to see you soon. Thank you.
Hey, what you forgot to tell is that 75,000 out of this overall 300,000 is from India. So please give yourself a big round of applause, guys. It's a big chunk of community out here in this great nation called India. Thank you very much. Keep that going. So, Vikas, most important thing is that, so you've been serving the community for how long now?
Since last 5 years.
Please give another round of applause. 5 years.
Thank you.
5 years doing a volunteer work is big deal. Thank you very much. So what is that one thing that comes across in this last 5 years which you want to share with the audience?
Okay, so after every event, we collect the feedbacks. And we get the inputs from the audience, that means the attendees. And even if a single attendee says that the event was useful, we get a satisfactory smile on our face. And that keeps us motivated. Right.
Thank you very much. Ladies and gentlemen, that's Vikas Bajpai for you. Please give him another round of applause, guys. Come on. Give it. Give it. Thank you. Okay, so now I have the great honor and privilege of calling on stage Sukriti Paul. Sukriti Paul is a fourth-year computer science student from Manipal Institute of Technology. She also happens to be the Women Tech Maker lead, and she's been doing an awesome job making sure that a lot of women get into part of the WTM community out there in Manipal. Without much ado, let's invite on stage Sukriti Paul, guys, please.
To begin with, the WTM program basically provides an ecosystem which is built on visibility, community, and resources for women tech enthusiasts around the globe. Visibility means that it gives us a platform to showcase role models and also showcase the achievements of women technologists. Community is the human component, which basically helps us in building networks, sharing our knowledge, and motivation. The Women Tech Makers program also provides us with resources which help in career development and building one's technical skill set so that the women can become industry leaders. The Women Tech Makers chapters across the various cities set out to build roadmaps to accomplish our mission. And our mission is to proliferate the participation of women in technology. Back in 2012, Megan Smith started this as a part of Google I/O, and today it is led by a global team of Googlers and headed by Natalie Villalobos. So with over 4,350 participants and members and 27 active chapters in India, Women Tech Makers assume seamless functionality and coordination, and the numbers keep growing by the day. Now let me talk a little about the initiatives. Our in-house activities include meetups, speaker sessions, hands-on sessions, workshops, lightning talks, and mentorship programs. Some of the communities also promote progressive learning via collaborative projects to help our members step into open source ventures. The Women Tech Makers program this year actually is, we're glad to announce this year, there's an overall 25% women participation in the DevFest season 2017. When it comes to the global programs, the Women Tech Makers Group promotes and encourages women to participate in signature events like IWD, the Grace Hopper Collins India Conference, and the Women Tech Makers Lead Summit. Propagating Anita Borg's vision of 50-50 by 2020, the WTM Scholars Program selects and empowers individuals who show an excellent academic performance, outreach contribution, and have technical knowledge. Women Techmakers has also partnered with Udacity to provide 100 scholarships for fully certified courses for the women in technology. Now, I've spoken about the WTM story, and I'd request all the women and the men, of course, everyone in the room, to engage with us. Our social media and Twitter handle is Women Techmakers. You can join the movement by registering as a member at www.womentechmakers.com/membership. The benefits of being a member is that a global team actually curates these resources, and the content is emailed to you. So for the experienced women, there is a separate program, and they can actually register as influencers, where they mentor startups and they mentor individuals based on their expertise. So do join the movement that is centered around inclusion, diversity, and equality and equal opportunity. Thank you.
Thanks. Ladies and gentlemen, please give her a big round of applause. Thank you, Sukriti. A quick question for you. What's been one of the biggest challenge for you as being a WTM lead at Manipal Institute of Technology?
Okay. So thank you, Karthik. One of the biggest challenges for me is that my chapter is a college-centric chapter. So designing events which cater to the needs of all the 4 years of college, starting from the freshers to the final year students, it has been the biggest challenge for me, because there is a huge variation in technical skill set over the 4 years of college. Having said that, another smaller challenge was the scheduling of events, because of the college timetable clashes and different study hours. We come from a residential college, so I think these are the challenges.
Thank you. You're doing a great job in spite of these challenges. Thank you very much.
Thank you, Karthik.
And another thing is that thank you for you and all the WTM leads out there for making it one of the most diverse tech conference, at least Google has handled in this part of the world. Thank you very much. Okay, so before I get carried away, I know I have a lot of time pressure. So Soham, my great friend, who's been my partner in crime in a lot of these Solve for India events, which we did together for the last 6 months in 15 cities. Over to Soham Mandal, who's a Google developer expert, giving a lot of his knowledge, sharing a lot of stuff with community and developers. Over to you, Soham.
Hi, everyone. I'm Soham, and I'm a Google developer expert for user experience. And I'm here to talk to you about the Google Developer Experts program. So Google Developer Experts is basically a global network of experts in these 3 focus areas. The first focus area is technology, which includes technologies like Android, web, cloud, and so on. The second focus area is product design, which includes the various disciplines of product design, strategy, and so on. The third focus area is growth and monetization, which includes marketing, branding, distribution, and so on. So to be an expert, you have to be an expert in some of these areas, and you have to undergo a thorough evaluation process. So currently, there are about 450 experts in the world, and just 13 of them are from India. I believe this is not truly representative of the amount of talent we have in the country right now, right? So I really look forward to having more experts from India join the program very soon. So what do Google Developer Experts do? The short answer to that question is Google Developer Experts contribute to the community in a very positive way. And this could be in one of many ways. For example, I have friends who are experts who write great blog posts, and their posts have lots of views and followers. Other experts contribute to open source in a very, very prolific way. They have lots of followers and stars on GitHub. Other experts mentor startups and actually help decide their future. More recently, I've also seen experts doing live streams, and that is a very, very interesting trend. In general, experts are all about helping people and solving problems. So in case you're interested in learning more about the Experts program, please visit this URL. Feel free to also reach out to me or any of the other experts in the room if you have any questions.
Thank you very much, Soham.
Thank you.
So what's been your learning after mentoring so many startups and sharing a lot of expertise on UX and Android, building apps during the Solve for India tour? So what is that one thing that sort of struck your mind?
So before joining the program and before joining Solve for India, I was able to contribute to my community here in Bangalore. But after the initiative, I was able to travel to various cities in India, like Bhubaneswar, Kolkata, and so on. And then I think I've been able to make an impact in the lives of designers and developers across India, which is something incredible, and I'm very thankful for the opportunity.
Thank you very much, Soham. Ladies and gentlemen, once more, Soham Mondal. So we're going to get to the last part of the lightning talk. We have the last speaker. So Srinath has been involved with the Launchpad mentorship program for many years. He spent thousands of hours mentoring startups across the various formats of Launchpad, and I don't want to steal the thunder away from him. So let's invite on stage Srinath VS. Srinath, come on up.
Thanks, Karthik. Good evening, everyone. My name is Srinath, and I am a product management consultant. I used to head product management for maps for a range of Nokia phones till about 4 years ago when I quit. And then I used to write a lot on product management on LinkedIn. Someone at Google once saw what I'd written, and then they called me and said they're going to start this whole series of programs called Launchpad, and would I like to come and be a mentor there? And that's how my journey with Launchpad started. So what really is Launchpad? Launchpad is a program that Google put together for startups to help them with various queries that they have. And realizing that startups have very different challenges early on and later, the program is structured differently for early stage startups as well as mature startups. So for early stage startups, you have the Launchpad Start and the Launchpad Build, which is a 2-day or a 5-day program. Largely what it does is it helps startups come back, reflect on a lot of things around how they're building their products, how they're doing their marketing, and brainstorm with a bunch of Googlers as well as industry experts across product, UX, marketing, or technology. For later stage startups or more mature startups, there is also a Launchpad Accelerator, which is a 6-month program, which usually starts with a 2-week, really intense sit-down, where you sit down with people and do the same exercise over and over again, and walk away with clear targets of what you're going to do over the next 6 months. Now, what's in it for startups? Launchpad offers a great way for startups to really work with some of the best mentors across the world, from Google and from elsewhere. And much of this is customized to the life stage of the startups. When you're very early on, you're looking at saying, how do I grow and how do I really build a market share? But later on, you end up having queries of, is this the right team structure? Why I want to move to a different geography. What do I do around that? And Launchpad lets you brainstorm not just with experts, but other startups as well. The team of Launchpad mentors, many of us have worked across geographies. So we're able to sit down with startups in some country and come back and say, hey, you know what, maybe some other country, some startups solved it another way. So why don't you learn? So there's a great opportunity for cross-pollination. Launchpad, the impact of Launchpad program, the start and build, there have been over 500 mentorship hours and rated very highly by startups. It's rated over 4.6. And the Launchpad Accelerator, which is a 6-month program, startups there have raised over 62 million of funding. Personally, it's been a great learning experience as a mentor because we get to see very diverse startups, and it's a great connect the dot opportunities, working with startups across different domains, as well as with working with the different communities. So working with other mentors and seeing what are the different perspectives that they bring. How does a UX mentor look at it versus how does a marketing mentor look at it, or a product mentor or a tech mentor, and just synthesize all of this and try and help the startups. For me, it's also been a great way of giving back, helping others see a little clearer by being a third-party view to reflect on the problem that they have. So if any of you have startups, I'd strongly encourage you to try out, to apply at this point. The Twitter handle is here, googledevs.in. Thank you.
Thank you, Srinath. Before you go, So you've been spending so many hours mentoring startups over maybe 4 years now?
Yeah, about 3 or 4 years now.
3 or 4 years. So what's that one thing which has struck you in all these 4 years of being associated with Launchpad and mentoring startups?
So I've done mentorship sessions in India, in San Francisco, in Istanbul, met startups from across multiple countries. I remember this one time we were sitting with this startup which was working for house help in Mexico. So they were trying to build a community of house help and a marketplace for them. So we were sitting and brainstorming about this whole thing, and they were looking at elements of saying, how do you make sure that we get the first visit from house help? And then we started brainstorming around this and realizing the emotional value of having someone trusted at home is far higher than something else. So that brought an entire shift to the way they looked at the problem. So for me, looking at these startups and then just helping them reflect on the problem and see it differently, that's been a big benefit.
Thank you very much, Srinath. Thanks for all your significant contribution. Keep it going. Thank you very much.
Thank you.
So with that, before I thank you all, I just want to quickly wrap up the session. So we heard about 6 lightning talks. There are 6 gorgeous programs from Google Developer Group. What's the first one? Developer Student Club. Okay, just if you're in college, if you're a student, just participate in the Developer Student Club, enroll, meet your leader, and start contributing to the community right away. So if you're still in college or if you're working and if you want to get certified on any of the Google technologies like Android to start with and eventually PWA and some point in time Google Cloud, please go out and use Kamal as an example and get certified. And then if you're professional developers already engaged in working with a startup or an enterprise or doing your own stuff, please join the Google Developer Groups, a vibrant community which always believes in sharing and gaining a lot from that by sharing. Become a GDG member right away. And then for all those gorgeous women folks out there, you can have an opportunity to become a WTM lead, start your own stuff within the GDG chapter, or get more women to participate in technology. And then the Google Developer Expert, which Soham talked about, if you want to share expertise, that's a great platform. And then finally, we had Launchpad, which is like if you really are good at certain skills and want to mentor and really give back to the community, you have the Launchpad program. That's the 6 flagship programs from the Google Developer Group. Me and the rest of the team are there. If you guys still have the energy and want to keep us engaged, happy to share more information, more knowledge, and see how we can get this going. So with that, thank you very much. Thank you. Thank you. Thank you. Yeah, so now I'm shifting gears here. So now I'm going to do the role on behalf of the GDD core team, and the boss of the GDD core team was sitting here, right here, Peter Lubers, to thank you all for being such an awesome attendees and audience and really making it very, very great, very encouraging, very exciting for all of us out here from the GDD India core team to bring this event to you. So I want to thank you all for being an awesome audience. Please give yourself a big round of applause, guys. Thank you. Okay, so a couple of small things before we actually close. Please check out your inboxes. You would have got email in your inbox. We value your feedback a lot. We want you to give your feedback so that we can keep improving and make things better. So if you like something, please let us know. If you didn't like something, please let us know. Either way, please just let us know. So we really, really want you to give us the feedback so that we can make things much more better and enhance your experience. Second, if you really enjoyed the GDD India experience, I all want you to share this with the community, do some social media updates, share the live streams. There's a lot of videos out there on the YouTube channel. Please spread the word around. Let the content go, reach other folks. If you liked it, please like it and share it with the rest of the other folks. So people within the community, or you want to join the community and want to get GDD extended, please check out the GDD India website. There are a lot of ways for you to access and start and do your own GDD extended events within your community. So we want it to spread, and this is available till Feb. So there's a lot of stuff which is available for you to host those events, and the time period for that is till Feb. And finally, my favorite topic, which we as the core team have been working on, is to make sure that this conference is very diverse. I want to give yourself a big round of applause for all the women and the men to make sure that it's a diverse event. Thank you very much for that. Yeah, and then we've had a lot of people attend GDD India, not only from Bangalore. It's been a kind of a global event, which is a great surprise. We have a lot of people from outside of Bangalore, across India. We have a very good representation. And more importantly, we have a lot of people from outside of India. There are many countries. I don't know the exact numbers. We'll publish it at some point in time. But there are a lot of people from outside of India. Please give them another round of applause, guys. We welcome you. It's great. So we look forward to having you again and again and again. Thank you very much. So with that, let's enjoy a brief video of what the exciting times we had together over the last 2 days. Let's roll the video, please.
This is the first GDD ever in India, and this is the largest developer event that Google has held in India ever.
We living, breathing, eating, sleeping Androids, and this is the first time the event is happening in Bangalore. So many of the people we have seen on online videos, we've seen them in person here. That's a different kind of a feeling.
Our purpose of being here is to know what's next. Firebase, Kotlin, we know that is the future that's going to change things. So we want to make our developers equipped with those technologies. Programming is like math, where you need to practice a lot to gain the expertise.
There was a session that I attended in the morning, which was about design. It was new to me, and that is how I can improvise my work. And also IoT, which I didn't know. So many things that you could do which you didn't know.
Okay, for one last time, on behalf of the GDD India core team, thank you all very much, and see you all next year.